In this video, I will explain what we want to achieve until the end of this course and how to do it in an efficient way. As you know, you're going to learn not only how to create a trading robot, but also to build an interface for it. So there are two types of applications with interface: the desktop application and the web application. So what are the pros and cons of both? For the desktop application, first, it's much easier to handle the security of the app. Indeed, the program is accessible only from your computer, so the security of the program is related to the security of your computer. If your computer is safe, then your program is safe. Then it's easier for beginners to start with a desktop application because there is usually only one programming language involved, and you don't need to deal with the configuration of a remote server. Then you can use your local machine computing power instead of renting the computing power from a server provider. And anyway, if you really need your application to run 24 hours a day, you can still rent a Windows server and deploy your application there. One minus is that the design is a bit more limited than on the web, but you will see that in the end, our app still looks pretty good. Of course, if you want to use the program on another machine, this involves installing it, configuring it again, and you need to make sure it's working on several operating systems like Windows and Mac. On the web application side, the main advantage is that you can access it from anywhere and from any device. So you only need an internet connection and a browser like Google Chrome to access it. You can create extremely nice looking websites and make the user experience better and more modern than on a desktop application. And finally, from a software architecture point of view, the web app makes it necessary to separate the interface, the front end, from the application mechanisms and logic, the back end, which is a very good and important practice. However, web application requires more experience and more skills, not only software development skills, but also handling the security of your app, deploying it, which involves knowing the Linux command line. And obviously, since you are renting a server, the more computing power required, the more expensive will be the server. So let's now see what we will need during the development of our trading robot and the challenges that we will face. From the interface perspective, there are four things we want to find in any trading application. First, we want to be able to display live market data, especially in the case where we build a semi-automated trading tool where the trader likes to keep some control over the bot. But for example, you may want to let the program open a Bitcoin USD position for you, but you still prefer to close it by yourself when some market conditions are met, when some news are released, or any other conditions that you have defined and that you need to check manually. Then you want to inform the user about what's going on inside the application, so that it's not just a black box that buys and sells with you knowing nothing about it. This is also called logging. Once you have your market data, you want the program to take decisions about opening or closing a position based on a predefined logic. However, this logic may require from the user some inputs. For example, the stop loss percentage, the percentage of the balance to allocate to the strategy, or anything else that you would need for your strategy. And you would definitely want to be able to start and stop a strategy with a button, with an on and off button. And once an order has been placed, or a trade has occurred, you want to be able to follow what's happening to the position. What is the current P&L? Is the position opened or closed? Or anything else you need, the time of the entry, the time of the exit, anything you want. So this gives us four components. And this is how I propose to have them organized. Here we have our main window. And this will contain the components. The first component, that we will call the watch list, will be on the top left of the window. You can see we have the symbol name, the current price, and a button to delete this symbol. We will also have an input box to add more symbols to the list. We could add more columns, like technical indicators values, like the RSI, anything you want. Below, we have the login component that displays messages to the user. When the program is started, when an order is placed, when an error can occur. So that's it for the logging part. And on the top right corner, we will have our strategy component, where the user can choose the strategy type, the symbol to trade, and other parameters like the stop loss, the take profit percentage, the balance to use, and of course a button to activate the strategy or not. Finally, the trade component shows the current and past trades with some information like the P&L, the time of the trade, the status of the trade. What's important to understand here is that each of these components will be coded in a separate Python file. We definitely don't want to have everything related to the interface in a single file, ending up with thousands of lines of code in one file and making it hard to debug or modify. Now regarding the connectivity. What I call the connectivity is what relies on external resources. In our case, we want to integrate Binance Futures and BitMEX to our application. So since we have two exchanges, we will create two connectors, that is two Python files. In each of these files, we will request market data from the API, authenticate using our API keys, and code more functions to interact with the exchange. Now let's see what we want to achieve regarding the trading automation itself. We want to be able to parse the parameters that the user types in the interface, parse market data received through the API of each exchange, and define an entry and exit logic for each strategy. In this course, we will code two example strategies to illustrate this part. Once a trade has been made, we need to follow it and get data like the execution price, which allows to compute the P&L, and the P&L helps you to know when to exit the strategy. So this is why we will have a Python file that handles everything that is related to the strategy logic. Finally, one note about what you need during the development stage. You need Python 3 to execute the code that you write. In the next video, we will go through the short process of downloading it and installing it. You need a code editor, also called IDE, Integrated Development Environment. And I'm using PyCharm. I strongly advise you to use it. It's a great tool and it will make it easier for you to follow what we are doing through the class. Also make sure your computer's clock in the date and time settings is synchronized. Sometimes the time of your computer might be delayed by 5 seconds or more, or even more. So this is necessary for the interaction with the Binance and BitMEX API. So we will see that more into details in the videos dedicated to the connectors, but until then, make sure that your time is synchronized, whether you're on Windows or Mac. So see you guys in the next two videos where we will explain how to install Python and PyCharm before starting the coding itself. Let's search for Python 3.6.8 on Google and select the first result. We will scroll all the way down at the bottom of the page and find the Python installer we want depending on our OS. Here we want Windows 64-bit, the executable installer. If you're on Mac, just select one of the two depending on your OS X version. When the download is completed, just open the file and don't forget to add Python 3.6 to path. It's important. Then you can keep everything as default and select Install Now. When the installation is completed, we will just check that Python is working as expected. For this, we open a command prompt in Windows or a terminal in Mac. We will output the Python version by typing Python space dash dash version, or if it doesn't work, try Python 3 space dash dash version. And we see Python 3.6.8, so everything works as expected. In this part, we will continue setting up our coding environment before starting the coding itself. I will first explain you how to install PyCharm, then configure it, and finally create the project for the course. So why do I like PyCharm and why do I use it for all my Python projects? First, it gives you all the tools for project management, from the simplest to the most complex project. In the case of trading bots, you can use it for a simple script of 50 lines, but as well for bigger projects, like the one of this course. Secondly, the free version is really sufficient for personal projects where you want to build desktop applications. The professional edition, though, comes at a very decent price and is great for web application development, but not only. Then, PyCharm helps you writing Python code with the right syntax, following the best practices described by PEP8, which in return improves the readability of your code. If you're planning to share your project or work with a team, you must use versioning. And PyCharm makes it very easy, for example, to push code to GitHub without using the terminal. Of course, you expect a code editor to help you with autocomplete mechanisms as you are typing, and avoid mistakes when using variables. PyCharm does it very elegantly, and we will see that all over the course. And finally, since we want this course to be adapted to both Windows and Mac users, we need an editor available on both Windows and OS X, which is the case for PyCharm. So let's first download PyCharm. We are now on Windows, but the procedure is the same on Mac. After searching for PyCharm community on Google, we land on that page and open the first result. We click on Download, and after the download is completed, we can open the file and start the installation. You click Next. Here you can keep the default installation folder. Now we want to associate Python files with PyCharm so that anytime we open a Python file on our computer, it will be opened directly in PyCharm and editable. And finally, install. Once the installation is completed, we want to run PyCharm and set up our project. Here it asks me whether I want to import settings from a previous PyCharm installation. I will just decline it. Here it requires to choose the interface theme. I personally prefer dark and I will use this dark theme across the course, but feel free to use the other one. We don't need more options to set up, so we will just skip the remaining configuration. We are now ready to create the project for the course, so click Create New Project. Choose the location of the project, and the last part of the path will be the project name. I will just call it Trading Bot Course. Then we want to set up our virtual environment for the project. Indeed, it's a good practice to separate your project from the others you may have in the future, which means that any external library that you install during this course will be installed only to the project folder, and we will record exactly which version of the library we installed. Our virtual environment will be based on the Python version we have just installed in the previous video, so the base interpreter field must be set to Python 3.6.8. and we don't need these tips for the moment. So here we are. We have our project folder, the virtual environment folder, and now we'll just add a new Python file to our project to make sure everything works as expected. So you right-click on the project folder, New, Python file, and we will just call it main. Then I press enter. So the file was successfully created, and now we will simply write a couple of lines of code to display the number of seconds elapsed since the 1st of January 1970. This is also called Unix timestamp. We will use the Unix timestamp a lot when connecting to Binance and BitMEX, so keep it in mind. For this we use the time library, and now we will print the output of the time method in the time library. Then executing our code is very easy. You just right-click on the file name and then run main. And this will be necessary only once, then you will just click on the top right corner on the play button. And we do see the number of seconds since 1970, so everything works as expected. To finish this video, I will explain you how to install an external library to our virtual environment. We first need to open a terminal directly in PyCharm. For this, the commands are a bit different in Mac and Windows. I give you both. For Windows it's Alt plus F12, and for Mac it's Alt or Option, Function plus F12. You can also open the terminal thanks to the icon at the bottom left of the screen. So we use the pip package manager, the install command, and finally we write the library name, Panda in this case, and we press enter. So let's import it to our main file and give it a short name. So import pandas as pd. Per convention, it's a name we usually give in Python projects for pandas. And now, as you can see, we can use the pandas methods and objects, for example, the dataframe1. So Python is installed, PyCharm is installed, our project has been set up. So we are ready to tackle the actual coding part from the next video. Before starting to code, you will need API keys on BitMEX and Binance Futures to perform actions like placing an order or getting the current status of your account balance. Better use the testnet platforms for the moment. For Binance Futures, you need to create an account on their testnet platform. And once you are logged in, you will see at the bottom of the page there is a tab named API Key. So your API keys are already created. And you even have a link to the API documentation. Just pay attention when you copy the keys to your program later on, not to add an extra space at the beginning or at the end. There should be no space in the API key. In the future, when you want to use your program with your real account, which you would do of course only after testing a lot on the testnet platform, you will have to create your API keys from the regular Binance platform. Then you would go to your account dashboard, the Settings tab, and then click on API Management. From here, you can give a name to the API key pair and click Create API Key. It will require to follow some steps like entering a phone and email verification code, and after this your API keys will be created. Again, to copy them to your program, use the copy button to avoid accidentally missing or adding characters. Then you have to pay attention to the permissions. To trade on the Futures platform with these API keys, you will have to click Enable Futures. And I would say in 99% of the case, you don't want to give the API keys the permission to perform withdrawals or transfers. Enable these options only if you really know what you are doing. If you are a beginner, you should not start with a strategy that requires to transfer funds from one exchange to another. As an additional security, you can restrict these API keys to be used only from some IPs. However, bear in mind that if you use the program on your computer might have a dynamic IP, which means that it changes every week or every 2 weeks. But this IP restriction might make sense if you deploy your program on a server that has a static IP. More generally, follow the exchange recommendation about the API key use, and don't share these API keys with anyone. On the BitMEX side, the security recommendations that I mentioned for Binance of course still apply. You click on your email on the top right corner of the screen, then Account and Security, API Keys. From here you can give a name to the API key pair. Select the Order permission to allow the API keys to be used to place and cancel orders. And as I said for Binance, in 99% of the case you wouldn't allow withdrawals. You also have an option to restrict these API keys to a certain range of IPs. And like they explain, the secret key needs to be written somewhere, because it is displayed only now. So for the purpose of this course, you can save these API keys to a text file in the PyCharm project folder. Be careful if you share your project, not to share a file where you would have stored your API keys. Now we are doing things with a testnet account, but it's better to take good habits from the beginning to the end. When I post the source code of the project, you will see that I always remove the API keys from the main Python file. So I showed you the testnet platform here, but the procedure is the same on the BitMEX real platform. As you understood, your API keys are precious, so keep them safe. In the course overview, I explained that we will have many Python modules: the connectors, the interface components, the strategy module. However, for our program to run, we need an entry point, a Python file that will initialize other modules and displays the interface. This is going to be achieved with a very simple and short file, not more than 50 lines of code, as we want this file to be extremely clear. The idea is to initialize in this file a few things: the two connectors that we will add to the entry point after the connectors have been coded, the interface main component, and the logger object. We already have talked about logging as an interface component, but here I refer to the practice of outputting logs to the Python terminal during the development to debug the program. We will see an example in this video. So the first step is to create a main window, the main window of the application. Thus, it's time to introduce you to Tkinter. Tkinter is a Python library that comes with the Python installation. So this is not an external library that you will need to install with the pip command. No, Tkinter allows you to create graphical components to interact with your program, like labels, entry boxes, drop-down lists, frames. There are other graphical libraries for Python, but Tkinter is free, easy to use, and it's easy to find support for it on the internet. And I've never faced a situation where Tkinter would not allow me to do what I want. Let's import Tkinter. So import Tkinter as tk, we give it a short name. And now we will create a Tkinter application by instantiating a Tkinter object. So tk.tk. It represents our root component, so we assign it to a variable called root, and it also represents actually the root window, so the main window of our application. If you execute the code, nothing happens. Indeed, all you have done here is to import the library. You instantiate your takinter object, and that's it, nothing more. So the program terminates. To actually display the root window, we need to call a blocking function that will prevent the program from terminating. The function that we will use will start what's called an event loop. It's an infinite loop that waits for actions from the user, like clicks or keyboard entries. So this function is called main loop. And when referring to a function within a class, we call it a method. So main loop is thus a method of the TK object. And now let's start the program. Now we see the root window. Of course it's empty, because we haven't added anything to it yet, but it's here. So you can maximize it, you can minimize it, you can close it as any other application. If you close it, you terminate the program because there is nothing more to execute. So I spent a bit of time explaining you the details of these few lines of code because these are really the fundamentals of any takinter application. It's important to understand what the takinter object does, what it is, and why you need the main loop method. I will now explain you how to create our logger object that will be used to display messages in the Python terminal for debugging purpose. For this, we need the logging library, so let's import it. Then we create an instance of the logger object by calling getLogger. We now need to configure this logger, setting the output message format and setting the logging level, since the logging messages can have various importance. Logger.debug, logging.info, logger.warning, and logger.error. So if we write logger.setLevel and we set the minimum logging level to info, only the info, warning, and error messages will be displayed. So for our logging messages to show up in the Python terminal, we need to add a stream handler object. So let's create it, stream handler, we call it this way, equals logging.streamHandler. So we initialize the stream handler object. To this stream handler, we need to provide a format for the message. So we are going to create a formatter object. And here we set the format of the message. So what we want is to show the current time of the log, the logging level, and the message itself. So let's add a formatter to the stream handler. So we take the stream handler instance and we set the formatter. Finally, we just we set actually a level for the stream handler itself. If the concept of logging handler is a bit confusing for you at the moment, don't worry. We will add another one right after so that you understand it better. Finally, we add the stream handler to the logger instance. We will test the few logging messages we have written above. I just copy them below after we've added the stream handler. And that's it. We have the info message, the warning message, and the error message. We don't have the debug message because we've set the minimum logging level to info. So you see that we have the expected format, we have the time, the logging level, and the message itself. So what now if we wish to save these logs to a file? Well, we're going to create a file handler. Unlike the stream handler that is non-persistent, the file handler is persistent. So let's add it here. Okay, file handler. And we need to assign it to a file. So we call it info.log. Again, we set the formatter, the same as for the stream handler. And the minimum level. For the file, we will set it to debug because we want to output more information to the file. We don't want to output everything to the stream handler because we don't want to overwhelm the terminal with not so useful information. If we now execute the program, you will see that, okay, we still have our window, but we also have an info.log file that has been created. So here we forgot to add the new handler to the logger instance. So we do it the same way as for the stream handler. We execute the program again. And you see that the logs now show up in this file. So the logger that we have configured can be used in other Python modules by calling it again, by calling the getLogger method. For example, let's create another module that would be dedicated to the Binance Futures connectors. So, new file, we call it Binance Futures. We will use it again later. We import the logging module again, and we create the logger instance. Now we write a simple function to output some log. So write log, logger.info, now let's go back to the main file and import this function. Okay, we will execute it here. So you see, the log is here, even though it's from the Binance Futures module. And of course, it still shows up in the file. So we can remove this. It was just an example. And one last thing, we will add this. Okay, let's remove also the log messages. So we'll add this. This means that what's after the if statement will be executed only if the main file, the main module, is executed. So what comes after the if statement won't be executed if we just import the main module to another module. So let's see an example. Okay, so now let's import the main file this time in the Binance Futures module. We won't do it actually in the program, but it will show you a good example. So we do nothing more than this. And now we start the Binance Futures module. Okay, this is logged in all cases, but this message hasn't been output because of this if statement. So this will avoid this part of the code with the interface to be accidentally executed twice if we would import it to another module. So we can remove this. Good. That's it for the moment with the entry point of the application, and in the next video we will start interacting a bit with the Binance Futures API. As you understood, the idea of this section is to get acquainted with the main topics of this course in a simple way without writing too much code yet. So it's time to get in touch with the APIs. But what is an API? API stands for Application Programming Interface. It is an application located on a server from which you can request data using code and to which you can send data still using code. The idea is that when you make a call to the API, whether it's to receive data or send data to it, the API will send you back a response. The response has a response code indicating whether the request was successful or not, and a response content containing the data you asked for, or maybe an error message, or maybe just a confirmation message. Two examples to illustrate that. You're making an API call to get the current price of the Bitcoin USD contract, and the API responds with the response code 200, meaning that the request was successful, and the response content with the bid and ask price. Another example, you are making a request to place an order and you send the data to the API containing the symbol you want to trade, the order size, the side of the trade, the order price. And it would return a response code 200 and a response content containing the order ID and other information like the time of the trade. Or it could return a response code, for example, 900. Because there was an error in your request. For example, you don't have enough funds to place an order of this size. And it is the same with any website. For example, when you visit google.com and start searching for something, you are actually making a request to google.com and an API response with the content that has a list of results related to what you've searched for. This model of making a request to a server and getting a response from it is called the HTTP protocol. To use the Binance and BitMEX API, we are not necessarily going to make calls directly to Binance.com or BitMEX.com, since they may have dedicated endpoints to access their API. For example, the base endpoint for the Binance Futures API is HTTPS fapi.binance.com, FAPI for Futures API. However, if we want to access the testnet API, that will be HTTPS testnet.binancefuture.com. So both Binance and BitMEX offers to interact with their server using the HTTP protocol. This is what I will refer to as the REST API. We are making requests and we are getting a response from the server. However, there is another API we can use, the WebSocket API, using the WebSocket protocol, which means that we will establish a connection with the Binance API and maintain this connection open to be able to receive data faster. It is the idea of streaming data, getting a live market data as a constant flow, instead of requesting all the time the latest market data from the REST API like every 2 seconds. To connect to the WebSocket API on Binance Futures, for example, we will use this endpoint. So you see, we are not using anymore the HTTPS protocol, but the WebSocket protocol. The other S is for secured. To summarize, the REST API will be used, for example, to place an order, cancel the order, get an order status, get the current balance of your account, and the WebSocket API will be used to get the live market data. Now let's code together a function that will get the list of contracts on Binance Futures using the REST API. For this, we need a Python library that is used to make requests using the HTTP protocol, the one we've talked previously. This library is simply called request, so import requests. So as you can see, this library is not included in the Python base installation. So let's install it to our virtual environment using pip and the terminal. Pip install requests. Okay, it's done. So let's reduce this, hide this. Now we write the function. We call it dev, get contracts. And we can use the request library. So we will use the get method of the request library. The get method expects the URL of the resource you're trying to get data from. So we know it will start with the base URL we kept here. So we don't use the testnet API for this example. And what we need is a specific endpoint that returns a list of contracts. So for this, we refer to the Binance Futures API documentation. This page contains the documentation of the APIs of all the Binance platforms. Futures, Futures testnet, spot, margin. So we'll take the Futures one, and we are interested in market data this time. One interesting point is that on Binance, on the Binance API, all the APIs, whether it's for spot, margin, or futures, are similar. So it's very easy to translate what you've learned about the Binance Futures API and apply it to your Binance Spot account. And more specifically, we are interested in this endpoint, exchange information. Because as you can see, it provides with a list of contracts and even with additional data about it. You see the documentation itself tells us which method, which HTTPS method to use. So we want the get method. The weight is related to the fact that you cannot make unlimited requests to the Binance server in a given period of time. So for example, you cannot send 5,000 requests to place an order in 2 seconds. So it's also called rate limiting. And we have the endpoint we were missing. So we copy it to PyCharm. So this method will return a response object. So we'll create a variable for it. And we'll simply run the function like this, just printing the response status code and the response content. So we call the JSON method. I will explain a bit later what the JSON format is. Now let's just call this function and run the Binance Futures module. As you can see, the response code is 200 and the response content has the data we wanted. But it's a bit hard to read, so it will be better if we can have a nice format in the terminal, at least to explore the data for the first time. So for this, we import a library that is called prettyprint, bprint, and we will print the content of the response with pretty print. So pprint dot pprint. Now I rerun the program. Okay, so we still have the response code at the beginning and the response content with a nicer format. It's much easier to read like this. So the Binance and BitMEX APIs return the response in a JSON format. The JSON format is a data structure. It's like a Python dictionary. Each key is associated with a value. For example, we have the exchange filter key, the features type, rates limit, server time, and symbols. And the value associated with each of these keys can be of different type. So it can be simply a string, it can be a list, here it's an empty list, and here for the symbols key we see there is a list, you can recognize it like this, and a list of what? A list of dictionaries. So you can have in the JSON format nested dictionaries. So dictionaries of dictionaries, making it easy to organize and access the data. Let's see an example. So we have several keys and we will display only the symbols one, the one we are interested in. And since this is the first time we have dealt with a JSON object, I will show each step of this JSON object exploration or parsing. So let's print only the symbol part. So we access it like any dictionary by entering the key. Okay, so we see now only the symbol part has been printed, so we have the list of dictionaries. And what we would like now is to loop through this list and display each dictionary one by one. So for contract in, so still response object.json. So this represents our list and this represents the element we are iterating. So we can see that now each dictionary, each element of the list has been printed one by one. And in each of these dictionaries, we see that there is a field, a key called pair, containing the contract name. So that's what we want. We will extract that, so we can print them just to see. And that's it. So we have now printed each contract name, and we would like now to add this to a list containing only the string, only the contract name. So we call it contracts, we initialize it here, and every time we iterate through an element, we will add the pair name, the contract name, to this list. And finally, we just return this list from the function. We can remove that. And we will print the output of the function. Okay, so we do have now a list of strings containing each contract that is tradable on Binance Futures. Before the next video, what I'd like you to do as an exercise is to repeat the exact same process with BitMEX this time. You will have to find the BitMEX API documentation, find the base endpoint, find the endpoint that will help you getting the list of all the BitMEX contracts, also called instruments on BitMEX, and write a function that returns the list of these contracts. Bonus point if you manage to return from the BitMEX API only the active contracts, because some endpoints return the full list of contracts, including the expired futures. The previous videos were devoted to some basic coding about the interface and the Exchange APIs. Now we can start combining the two and get a bit more into details regarding the way we are going to display data to the interface. To combine what we've learned so far, we are going to display the list of BitMEX contracts to the interface, which will introduce our first widget, the label, that is used to display text. I will first write a function to get a list of contracts from BitMEX to mark the previous exercise, and then we will import this function to our main module and use the output to create our widgets. First, I create the BitMEX module. We still import request. We call it the same get contracts. The list to output the result. So still the response object. And from the documentation that you may have found here, you can see that the base URL is this one. And so I'll copy it. And the endpoint we are interested in is located in the instrument tab, and we're looking specifically for the active instrument. So you can see details about the response format. We loop through the response content in a JSON format. And we progressively fill the list. So I already saw that we have a list of dictionaries and that there is a key called symbol. Then we just return the contracts list. Let's just test the output of the function. We do have the full list. For example, we have the Ripple USD contract. We have, of course, the XBT contract. So everything is there. Only the active contracts. You can see this contract is for the year 2021. So everything is fine. Now, getting back to the main module. So this is where we deal with the interface at the moment. I will import the function that we've just created from the BitMEX module. So from BitMEX, import getContract. I will call it here. So let's call the variable BitMEX contracts equals getContracts. Okay, so time to create the label widgets. So each label widget will contain one contract name. And the easiest way to create them without writing too much code is, of course, to do it with a loop. So this loop must be placed after the root window has been created, but before the main loop call. So it will be placed here. So we loop through the list of strings. Now, how do we create a label object or widget? It's very simple. So you create a variable to reference the widget, and you use the label class, the label object. So this label object expects a few arguments. The first one indicates where it will be located. what is a parent window. And since we have created only the root window so far, we will place it in the root window. This will be the parent window of the widget. The other important argument is the text that you will display in this label. So the text will simply be the contract name that we have here in this variable. If we just execute the code like this, the label still won't show up because we didn't specify exactly where to display the labels on the window, on the root window. Should they be on the top, on the bottom left, on the right? We didn't specify this. So there are two methods to do this, the pack and the grid method. So grid or pack. The pack method places the widgets relatively to each other. For example, this widget goes on the top, then the next one goes below it, the next one goes again below the previous one, etc. So it's good when you just have a few elements to place in a window or in a frame. But if you have many widgets to place, like in a table format, it's better to use the grid method, with which you can specify the column number and the row number of each widget. So it's like in a table. Let's see an example with the two methods. In the pack method, we can specify the side. So here, if we do tk.top, the widgets will be placed vertically, one after the other, starting from the top. Let's see how it looks. Okay, so we do have our contract list, and if you remember well, this was the first one, so TechInter placed it on the top, then the second one was placed below it, etc. If we do the reverse, we can start from the bottom. Okay, and you can do the same horizontally by doing tk left. And tk right. Let's now see the other method with a vertical placement. So we need to have a variable that represents the current row. So we are going to use the grid method and we'll call it I. So we initialize it to 0, which means that the first widget will be placed on the first row. And then we will just increment this variable. So the grid method, we specify the row, that is I, and the column, that will be always the first column, so 0. The indexing starts from 0. Okay, so we do have pretty much the same output as with the pack method when we used the tk.top argument. So to illustrate the flexibility we have with the grid method, I will make the maximum rows number for each column to be 5. So after 5, it will create a new column. Let's represent the column number with the j variable, starting from 0. So if the row number is equal to 4, this means that we have placed 5 rows, so we want to go to the next column. So we increment the j variable and we reset I to 0 because we want the row to start again from 0. Otherwise, we just increment the row as in the previous example. Okay, so we have maximum five contracts per column, and the last one is not full because we've reached the end of the list. So that's it. Most of the time you will want to display tabular data with a grid method, And the pack method will be useful to organize the big blocks of your interface. So for example, when we create our 4 components with the logging, the watch list, etc., we will create 4 subframes or sub-windows, and these frames will be placed with the pack method. Since we will have one component on the top left corner, one on the top right, and so on. To finish this section, I want to make a short introduction to interface styling to make things look a bit better. Indeed, if you follow this course, it is very likely that you will build your own application with an interface. And if it is successful, you are going to use it very often, maybe on a daily basis. So it's always more pleasant to deal with a program that looks good. What we have so far is the list of contracts displayed on a grid. So we have a number of cells, and each cell contains a label widget. However, the widgets do not fill the width of the cell automatically, and the cell width is determined by default by the largest string in the column. The easiest way to realize that is to add borders around the label widgets. So we are on the main module. Let's run it. You see, for example, on the second column, the column starts from here and ends here, while some label widgets, these ones, are a bit shorter. To make the table look more uniform, the solution would be to have the labels occupy the extra space on its left and on its right. This is achieved with the sticky argument. So E means east and the W means west. So you tell the label to fill the space on the left and on the right. So it sticks on the left and it sticks on the right. So you see now it looks better. One thing to fix is also that all the columns don't have the same width. We can fix this by assigning a fixed width to the labels that will be bigger than the largest string. So 13 should be enough here. Okay, now it looks alright. What about having a different background color, text color, and a different font? For the background, we use the BG argument, and for the foreground, the text color, it will be FG. So we can remove the borders and add the BG background argument and the FG argument. About the colors, these are just strings. So for the background one, we take this one, and the foreground we will take a blue one. You can find the list of Tekinter accepted colors on the internet very easily. There are a lot of different ones. And now regarding the font, it can be defined with a tuple of 3 elements. So for example here, so the tuple, the first argument is the font family, the second one is the font size, and the last one is the weight of the font. For example, normal or bold. So we'll set it to normal. Let's look at the result. Okay, it looks alright. The last thing to fix is the bottom right corner. Since the cells are empty, we see the cell background because it hasn't been changed. That is to say, this is the root window background. We cannot use the BG argument directly when initializing the TK object, but we can do it right after using the configure method. And here we use the BG argument. So that was grade 12. Let's test it again. Now it looks alright. You see the background is uniform. This section is going to deal with the two connectors. The reason why we are doing this before starting to build the interface and its 4 components is that it makes more sense to create the interface once we have data to display on it. And the data to display on it will be taken from the connectors. We will start with the Binance Futures connector, its public data, then the data that require authentication. And then we will go through the same process for the BitMEX connector. Since I want you to understand easily what we are doing, we will write the code for the two connectors very progressively. First by getting the basic functionalities right, and only then by improving the code and the structure of the code, so that you won't feel overwhelmed, because that's a lot of information to handle. But let's first get our project ID and create a folder where to put the two modules dedicated to the connectors. So we right-click on the project name, New, and Directory. Then I put the two files to the new folder. Well, as I said, we will start with the public data, meaning data from Binance Futures that do not require authentication. There will be 3 functions. One we have already seen in section 1 to get the list of contracts on the exchange. One function to get a snapshot of the bid and ask price, and one to get historical data. Since we are going to write several related functions, related because they all interact with the Binance Futures API, collect data, store data within variables like the prices, the balance of the account, it makes sense to bundle these functions, these variables, within a Python class. And it will also help us to organize the code. This class will be called Binance Futures Client, and we can erase part of what was done in the previous video because it will be modified a bit. As usual in Python, there is an initialization function called automatically when you instantiate the class. So when you create the Binance Futures client, this function is automatically called. When initializing the class, we must ask ourselves, what does the class need to know from the beginning? Well, several things, but starting with a very basic one. It needs to know whether we are going to interact with the testnet or the real platform. So we will give an instance variable to this class, a boolean, true or false, called testnet. So if testnet is true, we know we will deal with the testnet platform. The next question is, what does the testnet boolean change from an API perspective? Well, the base endpoint is not the same. And since the base endpoint will be used in the methods of the class and won't be changed, we can create a variable for it. So if testnet is true, the base URL will be this one. Otherwise, we have a bit different URL. And finally, we can display a log message indicating that the Binance Futures client was successfully initialized. Let's define our 3 class methods. We have the one we've seen in the previous section, get contracts. We have one that will be used to get historical candle data. and one to get a snapshot of the bid and ask price. Okay, so before rushing into writing our request.get, 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 like everywhere in every function, in every method, we need to remember about something that is part of the DNA of this course, something that I committed to do and to show you. We want to keep good coding practices and keep the code as clean as possible. So instead of writing 3 times request.get, checking the response status code 3 times and getting the JSON content of the response 3 times, why not having a method in the class that will handle this? And the method, the 3 methods we have here, will simply send to this other method the right arguments, the right endpoint, and parse the data received. This new method can be called makeRequest. And it will avoid repeating all the time the same lines of code. It will take as arguments the HTTP method, so get, post, delete. So far we've only seen get, but we will see with authentication the other methods, the other HTTP methods that exist. It will also take the endpoint, the one that goes after the base endpoint, and the parameters that I will call data. So I will get back on the parameters argument in a few seconds. So if the method is get, we are going to use the requests.get method and still use the base URL, the endpoint, and the parameters. Otherwise, we just throw an error. So we want the program to crash in case we haven't set the method to be equal to get. Because so far, this is the only HTTP method that we will use. If you call the makeRequest method with another value for method than get, it means that there is an error somewhere. So if the response status is 200, so first we need to create a variable with the response object. So if the response status code is 200, we will just return the JSON content of the response object, as we did in section 1. Otherwise, we want to display a log message, and a log message showing the error with some details about the error. So error while making request, and the %s will be replaced by the method to some endpoint, and in the JSON content there should be some information about the error. So we can still call the JSON method to display the error. And we can also display the error status code. So I'll go to a new line to have everything clear. So this is, by the way, how you display variables in a log message. This %s will be replaced by the first argument here, the second one will be replaced by the second argument, etc. And we return nothing from the function, so that we will know that if getContracts gets none as a response from makeRequest, there was an error somewhere and we cannot use the output of makeRequest. So let's write the makeRequest method call from the getContracts one. So we'll call the output exchange information. The method is get. The endpoint I'll refer to the documentation here. If this one. And there is no parameter needed. We'll double check in the documentation. So market data, exchange information. So get method, the endpoint, and they say, okay, no parameter needed. So if exchange info is not known, we can parse the content of the response, the JSON content. So for S or for contract in exchange info not symbols, remember what we've done in section 1. We will actually rather return a dictionary from this function. So the key of the dictionary will be the contract name, and the value of each key will be all the details that we get here in the response. So in section 1 we were returning only the symbol or the pair field, and in this section, in this video, we are returning the whole list of keys. So the contract, the pair actually is the key in the dictionary, and the value is this whole list, this whole dictionary. So contract. And to make it more clear, we'll call it contract data. And we can return the contracts dictionary. So we are good with this method. We can move to another one, the get bid ask, for instance, as it will let me explain you what parameters are. So if we go to the Binance Futures documentation and find the order book ticker endpoint, so this is the one that provides us with the bid and ask price, as well as the bid quantity and the ask quantity. So we see that we still have a GET request. We have the endpoint that I will copy right now. And they tell us about a parameter. So we can have a parameter, it's optional, to specify the symbol for which we want the bid and ask, instead of getting the bid and ask for all the symbols. So a parameter is an additional field that is appended after the endpoint. So taking this one, this endpoint, so let's write full URL. We will have the HTTPS, okay, so the base URL. Then we have the specific endpoint to get the bid ask information, and parameters are added after the endpoint. So we add a question mark, and we write the parameter name and the parameter value. If you have more than one parameter, you would just add the and sign and add any other parameters that is specified. So key equals and a value, and key 2 equal value 2. So just for the example. To make our life easier, the request library and the get methods can take an argument called parameters. That will be a dictionary. The keys of the dictionary will be the parameter's name, like here, and the values of the dictionary will be the parameter value, so Bitcoin USD here. So if you call the get method with the parameter argument, params actually argument, you don't need to append the symbols in the URL like I did here. Request will do it for you. And this is why the get bid ask method, okay, I wrote it in the wrong function here, but anyway, And this is why the getBidAsk method will take the contract name as an argument. So we'll call it symbol. So this is a symbol for which we want to get the bid and ask. So I will store the output from the makeRequest method in a variable called obData, like order book data. Still a get method. The endpoint that we copied from the documentation, and the data. So the data is going to be a dictionary, as I said. And the only key we need is the symbol. So if this variable is not known, so if the request was successful, we are going to parse the data. And for once, we won't return data from the function, but we will rather store the bid and ask that we've got in a price variable that is available across the Binance Futures client object. The idea is to have a Python dictionary with the contract name as a key and the price as a value. So the instance variable will be defined here. We call it simply prices, and this is a dictionary. So I remind you, the key of this dictionary will be the contract name, and the value of this dictionary will contain the bid and ask price. So if the symbol is not yet a key in the dictionary, so if not in self.prices, we create a key for this dictionary, and the values will be the data we've just got from the makeRequest method. So let's get back to the documentation for this. We get a dictionary, and we have several keys, including this one we are interested in, and this one. So bid price and ask price. We also need to convert these strings to a number, to a float. So obData bid price converted to a float, and the ask is pretty much the same. Otherwise, we simply update the key, the contract that we already have. And we do the same for the ask. Well, actually, we can still return something from the function, since this will be helpful to test it. So we will return the data for the specific symbol we requested. Okay, so let's forge ahead with the last method. So we still have a dictionary for the parameters. So what do we need exactly? So market data, candlesticks data. So the parameters we need is a symbol, the interval, for example, 1 hour candles, 1 day candles, 1 minute, and some non-monetary parameters. We won't use it yet. We won't use this one yet. This one, we won't use it either. And the limit, we will increase the limit to 1000. So this is how many candlesticks the API is returning. So our function, our method needs some arguments, the symbol, the interval that we assign in the dictionary. And the limit will be fixed to always 1000 candles. Okay, so the output from the makeRequest method will be called raw candles, still a get request, and the endpoint, so get request, and the endpoint is this one. We send the parameters. We can prepare a list of candles that will be returned from the function. And if the request is successful, so if row candles is not none, we can loop, because we actually get a list from this endpoint, a list of candles. So we loop through the candles. So let's say for C, like candle in row candles, we will append to our list some elements. So the first element is the candle timestamp, open, high, low, close, and we will return the volume as well. And of course convert them to floating numbers. So candles can be a list of lists, that's not an issue. So each element will be a list containing C0 is the timestamp, because this is the first element. C1 is the open price. We said convert it to a floating number. C2, this is the high price of the candle. C3 and C4 and C5, because we still want to get the volume in this candle. So we have coded the three methods that are using the public API. It's time to test them. So where are we going to instantiate the class to create the Binance Futures client object? Well, in the main module, because this has to be done when the program starts, and it has to be done only once. So we import the Binance Futures client from the Binance Futures module located in the connectors directory. And we can remove part of the code from section 1. And create the object, the Binance Futures object, just before the root window initialization. We will use the testnet environment. So if we just run the main module like this, we see the log message about the successful initialization, and we can then print the output of each function one by one. So this one works. We do have a dictionary with the key that is the contract name and the value that has everything we saw in the API documentation. Then get bit ask for, let's say, Bitcoin USDT. So we have the value of the dictionary for the Bitcoin USDT, that is the bid and the ask. And finally, the historical candle method, still for Bitcoin USD, and let's say on a 1 hour interval, so 1 hour candles. So we get an error here. Oh, okay, probably a typo. Yeah, I forgot this slash. Okay, so we do have a list of lists. Each element of the list is itself a list containing the timestamp of the candle, the open price, high price, low price, and close price of the candle, and the volume. That's it for the public method. We will tackle the authenticating methods in the next video. With the previous video, we have taken a big step on the road to build our connectors. because we have spent some time explaining the structure of the Python class and explaining how to perform requests with parameters for public endpoints. What we need to do now is to keep adding more functions, more methods, and explain how the private endpoints are different from the public ones. There are two main differences. The private endpoints require additional data for the request to be accepted by Binance. This is where the API keys will be used. To authenticate the request, we also say to sign the request. The other difference is that we won't use only the get HTTP method. We will also use the post and delete HTTP methods to send information to the Binance server, to request the Binance server to do something about our account, like placing an order or deleting an order. Let's write 4 additional methods to our class. So getting back to the Binance Futures module, one to get the current balances on the account, one to place an order, another one to cancel this order, and the last one will be to get the order status. If we explore the documentation a bit, the endpoint security part, we see that depending on the endpoint, we might need to add a header to our request. For example, the endpoints that are in the user data category, they require to send your public API key. And you send your API key by passing a header to your request. From a Python point of view, a header is simply a dictionary to pass as argument in the get method. For example, there will be one key in the dictionary that is called xmbx API key, and the value of this key will be your public API key, not the secret one. Let's add this header to our makeRequest method. But first we need to pass our API keys somewhere. Since this is an essential information, we are going to pass them when instantiating the class, together with the testnet boolean. So we add 2 arguments, public key and secret key. We create instance variables for these 2 new variables. And in the main module, when we instantiate the Binance Futures client, we can copy the API keys that have been created on Binance. So these are API keys for the testnet platform. Getting back to the Binance Futures module and the headers, since the headers will not change, we can declare it as an instance variable. So as we said, this is a dictionary, and the only key is xmbx API key, and the value is the public key. What is left to add is the instance variable as an argument to the get method. So headers equal self.headers. The documentation also indicates that we need an additional parameter to authenticate our request, a signature. The signature is a long and complicated string that is generated using an algorithm called HMAC SHA-256. We are not learning cryptography here, so you don't need to know the details of how this algorithm works. There is a Python library that will handle the calculation for you. However, you need to know what to input to this algorithm. There are 2 elements to input: your secret API key and a string, a message, that is the concatenation of all the parameters you are sending with your request. We have an example in the documentation. So this is a concatenated string. So it's like a query string that we used after the base URL. So it has the same format as the parameters we add after the endpoint. One last thing, the generated signature must be the last parameter you add to your request. Let's see an example with the getBalance method. We'll use the account endpoint, and there is only one parameter needed, the current timestamp. Remember the video about the PyCharm installation where we discussed this. So creating the dictionary for the parameters, the timestamp parameter, converted to milliseconds, and we want a long number. So a long number is an integer. As I say here, type must be long. So long is just a big integer. If you remember well, in the course overview, we said that your computer time must be synchronized and not delayed, because Binance will check that this number, the timestamp, is not too far from their server time. Otherwise, the request will be rejected, with a message like timestamp for this request was 1 second ahead of server's time. We also need the time library. Now calling the makeRequest method, account data that will be the output variable, self.makeRequest, still a get request, the endpoint we can copy it from the documentation, and the parameters. About the signature parameter. As per the documentation, the last one in the dictionary, we are going to create a method that returns the signature generated by the HMAC algorithm. And take as argument a dictionary with the other parameters. Let's have this method almost at the top. We need two libraries to be able to execute the HMAC algorithm. And the HMAC algorithm is executed that way. HMAC library, the new method. You see the arguments, they expect a key, the secret key, the message, the query string, and a digest mode that is SHA-256. So the secret key, that must be a byte, not a string. So we convert a string to a byte object by calling the encode method. The second argument is currently a dictionary. So we need to convert the dictionary to a query string. A query string like this, I show it again. This can be done easily with a function from another library called URL encode. And finally, we convert this string to a byte by using the encode method. Finally, what is called the digest mode. This is why we need the hashlib library. and we call the xdigest method. Again, it's absolutely okay if you don't understand what's going on with this HMAC algorithm, what xdigest is, what SHA-256 is, etc. The HMAC algorithm is used in many crypto exchanges, so what you need to understand is how to transpose the documentation of the exchange to Python code. And since the part with the API key is never going to change, you only need to understand what the exchange expects as a message. That is to say, the second argument. So the whole point with Binance was to understand that the API expects a query string representing the parameters you are sending with your request. Some exchanges will require you to make sure the keys in the query string are sorted in alphabetical order. Some exchanges will not use the SHA-256 digest mode, but another one like SHA-512. Okay, let's finish this getBalance method. We are going to return a dictionary. The key of the dictionary will be the asset name, and the value will be the information we have here. So if the request is successful, we loop through the list of assets, this list. And that's it, we return the dictionary. I'm going to write the code for the getOrderStatus method as well, because it uses a getHTTP method, so nothing different from the getBalance one we've just coded. It just expects two more parameters. Let's have a look. The symbol, and since we want a specific order, we will also add the order ID parameter. So these two parameters will be taken as argument by the function. As usual, we create our dictionary of parameters. The timestamp again, I will just copy it. Signature as well. So the symbol parameter, the order ID, and finally, we just call the makeRequest method. So still a get method, the endpoint, I'm just copying it. And the output variable will be called order status, because we see that the information that we get is simply a dictionary with information about the order. So we can return the dictionary directly. Okay, we can at least test the getBalance endpoint, the getBalance method. And we do have a dictionary with the key being the asset and the value being the rest of the information. So with the testnet account, you get a Tether balance of about 100K. Finally, the last two methods are going to be very easy to write because nothing really changes except the HTTP method. We are going to use a post HTTP method for the placeholder function and a delete HTTP method when canceling the order. First, let's take these two new alternatives to the makeRequest method. So else if the method is post, we have a response that we can actually copy from the get part and just change the method. Almost the same for the delete HTTP method. We are going to use this endpoint to place an order. As you can see, the HTTP method is post, and some parameters are mandatory for any kind of order, like the symbol, the side of the trade, the order type, and some parameters are required only depending on the type of order you're sending. So for example, time in force is required only when you send a limit order. Time in force is the lifetime of your order, hence why it doesn't make sense to add it with a market order because it's executed immediately. So the place order function first. We need a symbol as an argument, side, the quantity, the order type, potentially the price, but not always, so we'll just assign a default value for the price argument, and same here for the time in force argument. We assign it a default value of none. Again, the dictionary of parameters. The order type. So when calling the function, so when calling the method, if we set a price argument, so if price argument is not known, we add price to the dictionary of parameters. Same thing for the time in force. Unlike the two other functions we've already coded, we need the timestamp and the signature in the end. The placeholder function also returns simply a dictionary with some information about the order, so we can call the output order status. The make request method, we send a post method. The HTTP, the endpoint is this one. And the parameters. We then return the order status. The cancel order function is going to use this endpoint. So we repeat the same process. So we need two arguments, symbol and the order ID. The timestamp, the signature, and almost the same call to make request, except that we send a delete method. Okay, time for some testing from the main module. So we've already tested the getBalance method. Let's try to place an order. So the symbol is going to be Bitcoin USDT, the side buy in uppercase, The quantity 0.01 Bitcoin. The order type will be limit, still in uppercase. And we need to set a price because this is a limit order. Let's say 20,000, so that it won't be executed, given the current market price. And the time in force is good till cancelled, GTC. Then we will use the order ID that we get to test the get order status and cancel order methods. Great, so the order was placed with this order ID. And let's try the get order status function. So still the symbol Bitcoin USDT, the order ID. We get the same output. This is normal because the status of the order has not changed. And finally, let's cancel it. So Bitcoin USDT. Good, so we see that now the order status shows a status of cancelled. So the operation worked. Well, we have just taken another big step in building our connectors because there is not much secret left about the REST API and its implementation in Python. You may have noticed that if we take apart the signature generation, we wrote the 4 additional methods pretty fast. The good news is that the BitMEX connector is going to be very similar to what we have learned with the Binance connector, so no big surprise ahead. That will be a perfect practice exercise for the REST API implementation, and it will help you to demystify the crypto exchange APIs in general. As you know, the WebSocket API lets us establish a persistent connection between our application and a server. On one side, there is a WebSocket server, and on the other side, our side, there must be a WebSocket client that will initiate the connection. To create our WebSocket client, we are going to use an external library named WebSocket Client that is very user-friendly. So I'm removing this. We open a terminal. And I install the library called WebSocket Client. The idea behind this library is that we create a connection to the WebSocket server and an infinite loop that waits for messages from the server. When a message is received, a function of your choice, also called callback function, will be triggered. Other callback functions can be triggered as well, for example when the connection has just opened, when the connection closes, or when there is an error somewhere. So we are going to create a method in our class that starts a connection and assign which function is triggered when an event occurs. In this method, we will need the base URL for the WebSocket server. So 2 URLs, one for the testnet environment and one for the live environment. So you can find them easily on the documentation. And the one for the live environment is quite similar. Then we create a WebSocket app object. So I forgot to import the WebSocket library. So the WebSocket object, the WebSocket app object. The first argument is the WebSocket URL, so the one we've just written in the class initialization. And the other arguments are to specify the callback functions. So we are going to have a callback function when the connection is open. So on open, you have the list of the callback functions you need to define here. So on open, we will call it on open as well. And we will have like a welcome message just to say that the WebSocket connection has been established. The callback for when the connection is closed. Another message to inform the user about the fact that the connection has been closed. Maybe let's set it as a warning message. Another one that says, okay, there was an error somewhere and probably the connection will drop. Unlike the first two, there will be an argument, a parameter that will be sent with the callback with some information about the error. So this is the message parameter. We will display this message in a logger.error message. And finally, okay, on error. And finally, a callback when you just receive data from the Binance server, like normal data, market data. And it also has an argument containing the data. We'll just print it for the moment and we will parse it a bit later. So for the connection to start, we use the run forever method. However, as its name points it, this method is an infinite loop. Remember, I said it's an infinite loop waiting for messages from the server. So if we decide to launch the WebSocket connection when initializing our Binance Future Client class, for example here, the initialization function will never return. So everything that goes after this, so root, etc., will never be executed because our program will be stuck here. This is why the startWS method must run in a thread, that is to say, in a parallel task. So it will run in the background and let our program do other things. The Python library used to create threads is named threading. And the way to run a function in parallel in a thread is to create a thread object. So t equal threading.thread. We write the name of the function or the method to run in the thread, and then we just start it. Let's have a look. So you see the Binance connection has been opened successfully. If you're on Mac, it's possible that you will see an error message indicating that an SSL verification failed. If this is the case, open a new Finder, select Applications, then open the Python 3.6 directory and double-click on Install Certificates. If you are on Windows and you still get this error, open a terminal, a command prompt, and type pip install upgrade certify. If you still get the same error after this, import the SSL library and add this argument to the run forever method. It will disable the SSL verification, which is okay as we are not going to receive private data, we only receive public market data from the WebSocket API. We don't receive any data yet on the onMessage callback method because we haven't subscribed to any channel yet. So we are going to create a class method to subscribe to a channel that will provide us with market data. So the only argument is going to be the symbol for which we want to receive live market data. And we are going to request to subscribe to the data by sending a message to the Binance server. This message is going to be a JSON object, like in this example in the documentation. So creating the JSON object will be very similar to what we have seen with the REST API. We create a Python dictionary. We fill it with the right keys, still following the example from the documentation. So the method, a list of parameters, and the ID. So method is always subscribe. The WebSocket ID, so it needs to be different for every channel we will subscribe to. Let's create an instance variable for this ID. So self.id, and we initialize it, let's say here, to 1. And every time we call the subscribe channel method, we will increment this variable. We only miss the params key. Let's put it here. This is a list. So a list of channels you want to subscribe to, because as you can see, there are many feeds, like K-line data, symbol ticker, order book ticker, liquidation data, and we are going to subscribe only to the book ticker channel for the moment to get live updates about the bid and ask price. So let's append one channel to the params key. So symbol, the one we have in our function argument. We make sure it's in lowercase, otherwise it won't work. And then we add the channel name, book ticker. Now, how do we send this JSON object through the WebSocket connection? We use the send method. We use the send method of the WebSocket application class, and since we need to use the WS variable we've defined here across several methods, we are going to create an instance variable for it. So it will be self.ws, and we will declare self.ws when initializing the class. So that will be none when declaring this variable, and then we assign a value to this instance variable when starting the WebSocket connection. Hence why we can use this instance variable here and use the send method. So the send method expects a string as an argument, not a dictionary, like the data one we have. So we need a function that converts this dictionary to a JSON string. a bit like we had converted the dictionary to a query string in the previous video. Let's import the JSON package and use the dump method from it in our data object. So json.dumps data. I'm going to print the data object before and after the conversion so that you can see the difference. And I will print the type of the object also. So we first call this method when opening the connection. So when the connection opens, we directly subscribe to a channel, let's say for Bitcoin USDT as usual. Okay, so here we have a dictionary, like before the conversion, and after we have a string, even though they look similar. So this is a JSON string. You can also see that when we run the program, the live data starts coming in. So this is in the onMessage callback, and in this callback we will have to do the reverse operation, that is to say convert the JSON string that we have received to a JSON object that we can parse. This is achieved through still the JSON library and using the loads method. So we load the message string. So you see there is a E key in the JSON object, that is to say what event we have received, what channel is this message for. So let's first check that the E key is in the dictionary. Because as you can see, we may have different messages without the E key. And if the message that we have received is an update from the book ticker channel, we are going to update the self.price instance variable like we did in the getBitAsk method. So I'm going to copy this part and just modify it a bit. So symbol is represented by the S key. We create the entry in the dictionary if it doesn't exist yet. And here, instead of obdata, it will be simply data. The bit price is represented by a B and the ask price by a A. And we still have to convert it to floating numbers. So if we constantly print the updated bid and ask prices for Bitcoin USDT, so you see we have, well, I'll remove this message, this output. So you see we have a fast live feed and it is pretty clean because we have a simple dictionary with a bid and ask key. That's it for the basics of the WebSocket part. In the next video, we are going to go through everything that was done in the Binance connector so far and improve the code. The goal of this lecture is to take what we have created in the Binance Futures module and make everything more reliable and usable by adding good coding practices in it. The first thing we want to add to the code to improve it is called data models. Indeed, we are collecting data from Binance, and so far we mostly used dictionaries to access the collected data. For example, when getting the contract's information or the current balances of the account. So this is what we get when collecting the balance data, for example. So this is a dictionary. The problem is that when the data will be needed, for example, when you need to know your available balance to calculate the size of a trade, it's going to be complicated to use the dictionary containing the balance data for example, let's say USDT, because, well, can you remember exactly what is the dictionary key to get the available balance? Hard to say without having a look at the documentation again, right? So we see the wallet balance is this key. What we can do is to create a balance class and then have a dictionary with the currency being the key, and the balance object will be the value. The balance class will be a data model. That is to say, we will know exactly what's in there. Let's have a look. We will first create a dedicated module for the models. So we simply call it models. And we create a balance class. So when initializing it, we give an argument that contains the information, the dictionary actually, with the information about the balance. Then we create instance variables for each key of the dictionary. For example, initial margin. And we take the key from this dictionary. At the same time, we will convert it to a floating number. And we do the same for the information we are interested in. For example, maintenance margin. Now we know that if we create a balance object, there is an instant variable representing the wallet balance of the account. And there is another instance variable representing the initial margin. Let's modify a bit the getBalances method to illustrate this. So instead of having the value being a dictionary, we'll have a balance object. I need to import it from the models module. So I import all with a star, and see how it is easy now to get the wallet balance for, let's say, USDT. For example, print balances, we access it with a key USDT, and surprise, we have a list of the instance variables. No need to remember them anymore. So we know that if we want the wallet balance, we just select the wallet balance instance variable, and that's it. We can do the same with the getHistoricalCandles method by creating a candle model. So as you remember, the first element of the list we had is the timestamp. Candle info is a list. And then we'll just get the open, high, low, and close price, and the volume. And we convert everything to floating numbers. Except actually the timestamp, that is already an integer. So I modify the getHistoricalCandles method. We just create a candle object and provide it with the candle information, the list actually. So this function will return a list of candle objects. Selecting, for example, the last candle, we can access the close price of the candle, for example. We can also create a contract model for the getContracts method. There are many different fields in the original dictionary, but I will keep only the ones we need for the course. Also, let's create an instance variable containing the dictionary of contracts, because this is definitely going to be useful, and we won't have to call the getContracts method again. Let's put it here. And we can do the same for the getBalances method. And we return a dictionary, not of dictionary this time, but a dictionary of contract objects. So again, very easy to access it. If we take the Bitcoin USDT contract, for example, PyCharm would suggest what instance variables are available. And maybe one last class, the order status one, that will be useful when we actually go to the trading part. And we will see later if we need more than these three attributes. Thus, some methods won't return a dictionary anymore, but an order status object. If the cancel order call to the API was successful, we actually replace the order status variable by an order status object. Same thing actually for the getOrderStatus method and the placeholder function, the placeholder method. Next step, to make the methods and functions more understandable and avoid using them the wrong way, for example, passing the wrong type of argument to a function, we can specify the type of argument, of each argument. For instance, when initializing the Binance Futures Client class, we know that the public key is going to be a string, so we specify it this way. Same for the secret key. And the testnet argument is going to be a boolean. If you type the wrong type of argument, for example, I put, instead of testnet equals true, I put testnet equals 12, which doesn't make sense, PyCharm will highlight it. Expected type bool instead of int. So let's do it for every function. So for the generate signature one, we know that it is going to be a dictionary. So you cannot write actually this. When you want to type more complex variables, more complex than strings or floating numbers or integers, you need to import the typing library. Let's say here import typing and use the dict object for dictionaries. So that will be typing.dict. For the make request method, well, the method is a string, as you can see. The endpoint is also a string, and the data is a dictionary. So no argument for the getContracts method. So about the getHistorical candles. We currently pass a string, but since we have created a contract object, a contract data model, Well, we could replace the symbol by a contract, the name of the argument, that will be a contract object. And to pass this value, the symbol value, to the dictionary, we'll simply take our contract and use the symbol variable that we have defined here. The interval is going to be a string, for example, 1 hour, 2 minutes. Same for the following functions. We are going to use a contract instead, a contract object. I've just noticed that we need to return this only in case the request was successful. Otherwise, we wouldn't have necessarily this key in the dictionary yet. Same thing here for the symbol. Oops. The side is going to be a string. The quantity will be a floating number. The order type is going to be a string. Then since we have assigned a default value for the last two arguments, we cannot do like this because the price argument can be none. So none is not a floating number. So we'll just leave it as it is. Again, a contract. The order ID from the documentation is an integer. Then we have strings here. And let's have a contract again here. We can also use the typing library to indicate what is the output of a method. For example, let's get back to the get historical candles method. We know that we have what is the output. This is a list. A list of what? A list of candle objects. So this is the way we hint it. That way, when you call the get historical candle from another module, assuming this is here, so the output, we call it candles. Binance get historical candles for, let's not even put the arguments. If you select the last element of the list, PyCharm recognizes that this is the last element of the list, like any other element of the list, is a candle object. So it finds the attributes of the models module. So the generate signature is going to return a string. The make request method doesn't return always the same output. It can be none or a JSON object. So we are not going to type it. We are not going to hint the type of the output. The get contracts, we know it returns a dictionary. A dictionary of what? We can specify it here. So a dictionary of strings as keys and contract objects as values. By the way, you can see that PyCharm is highlighting the last argument we passed to the makeRequest method, because we specified it must be a dictionary. And in the previous video, we decided that if we do not have any parameter to pass to an endpoint, we just send none as parameter. To fix this, we can simply send, instead of none, an empty dictionary. And this time, PyCharm is okay with that. So really, indicating the types of your method arguments is very useful to double check that you're not making any mistake. Let's continue. So the getBitAsk method will return, if there is no error, a dictionary of, so the key is a string and the value are floats. So we have the bid and ask keys and the values are float. The getBalance method returns a dictionary, so still strings as keys and the values are balance objects. The placeOrder method, cancelOrder and getOrderStatus all return an orderStatus object. And this is it. No more methods has to return something. So I'm removing this. Then, the most important feature we want to add to our code is definitely error handling, which means analyzing the code and try to identify where it could fail. The most obvious type of error in a connector is the network error. So something related either to a problem on our side, like the internet temporarily disconnecting for a few seconds or for longer, or on the Binance side, for example, when they perform a maintenance. On the REST API side, it's quite simple because the only place in the code where we really interact with the Binance server is in the makeRequest method. And in particular, when using the requests library. We are going to surround the get, post, and delete methods with a try except statement, that is a classic Python error handling method. What's happening here is that we handle any kind of exception, not only a specific one. For example, here we use a value error exception. Exception means simply any exception. And we store it to e variable to be able to print it. So let's say logger.error, connection error, while making the method, so get and we display the error message. Same thing for the two other HTTP methods. And we can directly return none because we won't have anything to parse. We won't even have a response status code. Another possible network or connection error is when we subscribe to WebSocket channel. So this is when we use the send method. So we surround it with a try except statement as well. And a similar log message to show the error. I'd like also to change this variable name because ID is too simple. We will say WebSocket ID rather, WSID. Okay, one other very important thing is to add the ability for the WebSocket connection to reconnect automatically. Indeed, if your connection drops, the prices won't be up to date anymore, leading to potentially wrong trades. From a programming point of view, if the connection drops, the run forever method will terminate. That means the infinite loop will stop, potentially with an error. So first we need to handle the possibility of an error with a try except statement. And we can log the error message as well. And then we place the run forever method in an infinite while loop, so that if it terminates, it will actually restart immediately. Actually not immediately, because I prefer to wait for, let's say, 2 seconds before starting the run forever method again. Because from experience, there may be situations when the connection simply cannot restart. In case, for example, of big maintenance on Binance that lasts for a few hours. So if we don't have a 2-second pause, the program will constantly try to reopen the connection because we have an infinite loop, and it will be done at a very fast pace, which is useless. So even if there is no maintenance on Binance, the program will try to reconnect only every 2 seconds, instead of 100 times 4 seconds, for example. Another good practice is to allow or not class variables or methods to be accessible only from within the class. In the previous videos, we were testing the placeholder method from the main module. But if we add an underscore before the method name, the method won't be listed in the accessible method of the Binance object. You can see, indeed, there is no placeholder method anymore. So we say that the method is private. It is useful to organize your code, and especially when sharing it, so that people working with your code will understand how class methods should be used. However, if you do not do it, this is not something that will prevent you from writing good code for yourself. So it is not essential, it's just a good practice, so I'm still going to do it in this course. Let's find which functions are private and which variables are. So the generate signature is definitely a private method because we are calling it only from other methods of the class. We are never going to call the generate signature from the main module, for example. Same for the make request method. The get contracts, get historical candles, get bit ask, etc. must definitely be used from other modules. For example, we might have a button on the interface that is called get bit ask, and when you click on this button, so this will be coded in another module, the get bit ask method will be used. So it must be public. The placeholder function, the placeholder method definitely needs to be public as well, actually. And all the WebSocket methods, except maybe the subscribe channel one, because it could be triggered from the interface when we add a new symbol to the watch list. All the other ones can be private. So start WS, on open, on close, etc. And of course, don't forget to add the underscore everywhere. Regarding instance variables, almost all can be private, except the prices, the contracts, and the balances. So just replacing this because we don't need a string anymore when using the subscribe channel method. We need a contract, so let's take it from the contracts variable. And that's it. Now we have a much cleaner and nicer code, which will be very helpful when you are going to modify it. Currently, we subscribe only to one channel and one symbol of the WebSocket API. To avoid having to manage constantly the WebSocket subscriptions, what we can do is to subscribe to all the symbols for a given channel. So I will modify a bit the subscribe channel method. Instead of having one contract, we will have a list of contracts. Then we are going to loop through the contracts list. And we will have also an argument for the channel. Finally, in the onOpen method, we can pass the list of contracts to the subscribe channel method. So for this, we take the contracts variable, the values method to get only the values of the dictionary, and we convert this to a list. And we will subscribe to the book ticker channel. If you get a WebSocket error message right after connecting, like invalid close OP code, or simply if the connection is closed immediately after opening, it means that there is a problem because of the subscribe channel method. This will happen if you subscribe to too many channels at once in one WebSocket message. So for example, if you send a subscription request for all the symbols and two channels at the same time, like the book ticker and trades data, there will be this error message, and the connection will be closed. But if you send two separate requests, one for each channel, that will work. This is why we have the channel argument in the subscribe channel method. And for the log message about the error, we can simply, instead of displaying the contract name, the symbol name, log the number of symbols we tried to subscribe to, and the channel. Since we have already learned a lot when building our Binance connector, we have learned how to access a REST API, a WebSocket API, how to authenticate to access private endpoints, while the BitMEX connector is going to be much easier to write. The main difference have been tackled in the previous exercise. The goal was to make you aware of these differences to make it even easier for you in the current video. So if you haven't had a look at the exercise yet, I strongly advise you to do it before watching this video. Okay, let's go. So removing the previous part of the BitMEX module. Regarding the libraries to import, these are exactly the same for the two connectors. So we still need to log information, the request library for the REST API, the time library to post the WebSocket reconnection, the typing library, of course. We still need the URL encode function. The HMAC algorithm, because we authenticate using the HMAC algorithm as well on BitMEX. the WebSocket library, the JSON one, and the threading one. We also need to import all the models from the models module. And we instantiate our logger object. Okay, so the class is going to be named BitMEX client. The initialization function as usual. So we still need the public and secret API keys that are strings. The testnet boolean. So now the first step is to get the base URL both for the REST API and the WebSocket API, and for the testnet and live environment. So if testnet self.base URL, we'll find it right after in the documentation. Otherwise, we'll take the base URL of the live environment. So we can find these URLs in the documentation. So this is the base URL for the live environment. And I'm not taking the API v1 part because this part must be included in the endpoint when generating the signature. This is what you have seen in the previous exercise. So it's better to have this API v1 part in the endpoint argument of the make request method. Because as you can see in the documentation for the signature generation, when sending the part with the endpoint, it doesn't only take this /instrument part, but also the API v1 part. So we need this to be passed to the make request method. So the base endpoint for the live environment regarding the testnet environment, it has a dedicated documentation on another URL. And regarding the WebSocket base endpoint, we can find it here. So this is for the live environment. So actually mixed them. And for the testnet environment, it's almost the same, just replacing this by testnet. Okay, still instantiating our API keys because we are using them in several methods. Still public, still actually private variables. Secret key. We prepare a variable for the WebSocket app object. We are still going to need a contracts variable. So we will get the contracts when initializing the class, like on Binance. Same for the balances. So get balances. We need a prices variable to store the prices we are getting from the WebSocket feed. And we will need to start a thread with the WebSocket connection. So I'm already writing the name of the functions because they will be the same as on the Binance Futures connector. And just a log message to say that the BitMEX client was successfully initialized. Okay, let's tackle the make request method first, because it's almost the same as on Binance. So I'm going to copy it, and we'll modify the part that do not match exactly what's on Binance. So what is not going to match is, as I said in the previous exercise, the headers part, because the headers on Binance were fixed. We had always the same headers, this one, while on BitMEX there will be a variable, because the value in the dictionary is going to change. Indeed, we have 3 keys in the dictionary, so let's create it. So the first one is what's called the API expires, meaning that you need to specify a timestamp until when your request is valid. And since we are going to use it several times, let's put it to a variable. So this needs to be a string. We get the current timestamp, we convert it to an integer. Otherwise it will return some decimals with the milliseconds that we do not need. And we add 5 seconds to say that, okay, our request is going to be valid for 5 seconds. So this is the value of the first key. Then the second key is the API key, so the public one. And the last one is the signature that we are going to generate. So we're going to have a generate signature function as well. So we'll put the argument right after. Let's just replace first the dictionary in the headers argument. So instead of taking the self.headers that do not exist anymore, we take the headers dictionary we create on every make request call. So how do we sign the request? Let's create the generate signature method. As I explained in the exercise, we can have several arguments that will be used to concatenate a string that we will pass as a message to the HMAC algorithm. So these strings need to be the method, like get, post, delete, the endpoint, with, like I said, the API part. So the endpoint, what they call the endpoint to generate the signature, is not just the instrument part in this case, but also the API v1 part. So it's going to be a string, and the expires variable that is also a string. There is also the parameters, that is a dictionary. And it returns a string. So we need to concatenate. So let's have our HMAC algorithm first. So the secret key as usual, encoded to make it as bytes. And the second argument is the string that we need to concatenate from the arguments we passed here. So we just call it message and we will encode it as well. So the message, it needs to be, as we saw in the exercise and in the documentation, a concatenation of the method, the endpoint with the API part, and the parameters as well at the end of the URL, plus the expires string. So the method plus the endpoint plus the parameters. So we convert the data dictionary to a query string. And however, if you remember, the query string will return, for example, only this part. So we miss the question mark. So we need to add it, plus question mark, plus the parameters, and the expire string. However, if there is no parameter, well, we don't need any more of this question mark, because this will be an empty string, and when there is no parameter, you do not add the question mark. So this is valid only if we can add an inline if data length, so length of data, which means the number of keys is more than 0. Otherwise, we'll just concatenate the method plus the endpoint plus the expires string. So about the HMAC algorithm, we had the digest mode that is also SHA-256. And the xdigest method. And this is what we are going to return from the method. And this is it for the signature. So now we can code a few REST endpoints. So for example, the getContracts method. And it will be extremely similar to what we have with the Binance connector. So it's going to return a dictionary of string and contract objects. Let's store the output to an instruments variable. So self.makeRequest. We have a get method, API v1, instrument, active, and we don't have any parameter. So this is taken from the documentation. If the API v1 part was not here, but in the base endpoint, that means that when we call the makeRequest method, the endpoint argument is this. So we get it here. Then when we actually, okay, I forgot the generate signature arguments. So method, endpoint, expires, and data. So we get the endpoint here, that is instrument active. Then we pass the endpoint to the generate signature method, and it's going to concatenate only this part. While from the documentation, we need the API v1 part as well. So it's more convenient to have this here than leaving it here as part of the base URL. So we prepare our dictionary for the output of the function, of the method. If the request was successful, we're going to loop through the instruments, because instruments is going to be a list. And we do exactly the same as for the Binance connector. Now the problem was tackled in the exercise, but I'm going to get back on this. We are passing an argument to the contracts object when initializing it. This argument, the structure of the argument, is going to be different whether we are on BitMEX or on Binance, because this S is a dictionary with some information, and the keys of the dictionaries are not going to be the same. So this contract info, for example, won't have necessarily a base asset key, or it won't be written exactly the same way. So we need another argument, that is the exchange. And depending on the exchange, we are going to have still the same instance variables, symbols, base asset, quote asset, etc. But we are going to take different keys from the dictionary, from the contract info dictionary, depending on the exchange. So if the exchange is Binance, we change nothing. But if it's BitMEX, so let's say else if exchange equals bitmex. The keys are a bit different. So I'm going to copy them and just modify the keys. So for symbol, it's the same. For the base asset, they call it root symbol. For the quote currency, they call it quote currency. So we don't have a price precision equivalent key in bitmex, but we can calculate it. We can still find the price decimals from what they call the tick size. And same for the quantity, we have the lot size. So to compare, on Binance, the price decimals would be 2. And on bitmex, they would say the tick size is 0.01. So it's quite the same. So we also need to change the contract initialization in the Binance module. So let's find with Ctrl F, we can search for all the contract initialization. So this is only here, and we need to pass an argument, the exchange Binance. We can test this already and initialize and create our bitmex object. So bitmex, we need to import the class from the bitmex module, from connectors, the directory, bitmex import bitmex client. Bitmex client will pass the API keys, and that will be a testnet environment. So just passing the argument here as well on the bitmex module. We'll actually write the getBalances method as well, because we call it when initializing the object. So it returns a dictionary of strings and balance object. The string is the currency name, and the balance object is the one we have in the models module. So we need parameters. We need a parameter called currency, and that will be all. Calling this variable, let's say margin data. So the output will be stored in margin data. This is a GET request, the endpoint, still API v1, user margin, and we pass the parameters. The balances dictionary to store the parsed output, to return it from the function. So if the request was successful, we have a list, so we loop through it, and we do pretty much the same thing as on the Binance connector. So we find the currency name in the currency key. We create the balances object, the balance object. We pass the dictionary, and we're going to have an argument that is the exchange as well. So same thing. We modify the balance model to take exchange as another argument. If the exchange is Binance, we take what we have done in the previous videos. Otherwise, we'll have a few different keys. So we have, let's copy them and modify the keys. So they are already floating numbers, so we don't need to convert them. Initial margin is called just init margin. Maintenance margin is the same for both. We have margin balance on both. Wallet balance as well. And unrealized profit is unrealized P&L on BitMEX. So it's almost the same. So one important point that we tackled in the exercise as well, these values, so they are Bitcoin values, because your account wallet in BitMEX is always in Bitcoin. These are returned in Satoshis. So in order to get the initial margin in Bitcoin, you need to convert this to Bitcoin. And 1 Satoshi is equal to 0. There are 7 zeros. 1. We can store this to a global variable called BitMEX multiplier. And we will need to convert each of these values to Bitcoins by multiplying them by the BitMEX multiplier. So here we have Satoshis, and here we have Bitcoins. We modify the balance object initialization in Binance Futures as well. So balance, we give it the Binance argument for the exchange, and we'll test here. Well, actually we can finish the function first. Same for the contracts. So we return the contracts dictionary, and we return the balances dictionary. So let's remove temporarily this part and already test these two methods. Okay, I probably missed something. Yes, it's not a Z, it's a S. Let's retry. Okay, no error, so that means everything worked. We can check again by accessing the balances and let's say one contract of the BitMEX object. So BitMEX.contract, if we take XBT USD, so Bitcoin USD, we can display the base asset and let's say the price decimals. We'll also show the balances. So balances, that should be XBT. And the wallet balance. There will be nothing new in this video, we are just going to add the remaining methods to the BitMEX connector. The remaining ones are the get historical candles, place order, cancel order, and get order status methods. So removing this, and getting back to the BitMEX connector. So let's write the 4 functions, the 4 methods, get historical candles. So we take a contract object like we did in the Binance Futures connector. The time frame, what we call the time frame, that is the interval on Binance Futures. So this is still a string, and it's going to return a list of candles. The parameters, as usual, we create a dictionary. We need the symbol that we are taking from the contract object. Let's have a look at the documentation. So in the documentation, they call the interval or the time frame bin size. You have only limited options for the interval, 1 minute, 5 minutes, 1 hour, and 1 day. But from these, you can still build other time frames. So from the 5 minutes one, for example, you can build the 15 minutes one. So we see, unlike the Binance connector, unlike the Binance API, this endpoint returns a list, not of lists, but of dictionaries. So we will have each key representing either the open, high, low, close, or volume of the candle. And there are already floating numbers. You see these are not strings, so we won't need to convert them. So in terms of parameters, we need the symbol, whether it can return a partial candle, that is to say, if now it's 8 p.m. and we are looking for 1 hour candles, the 8 p.m. candle is already started but not finished, and this partial argument, this partial parameter says whether it returns this candle that is not finished yet with the available information that we have at the moment, or if it returns only data until the last finished candle. So in this example, it will return only the candle until 7 p.m. So we are going to return the partial candles. So the bin size, the interval or the time frame is this argument. And so how many can we return? How many candle can we return? So the maximum candles we can return with one API call is 500. So the output from the make request method will be called raw candles. Self.makeRequest, get request. So the endpoint is API v1 trade bucket and the parameters. So we prepare our method output. If the request is successful, we are going to loop through the list of dictionaries. So C like candle. And we are going to add to the list a candle object. So we need to modify a bit this candle object to take into account the exchange that we are using. So the exchange parameter is going to be bitmex here. We are going to modify the model a bit. So like with the other models, we add the exchange parameter. If this is Binance, we use the instance variables that we had so far. Otherwise, we're going to pass the data a bit differently. So no need to convert the data to floating numbers. We have the dictionary, so the open price is represented by the open key, and same for the others. Regarding the timestamp, we see that it returns a string with the timestamp key. And for the moment, I'm going to leave it as it is. So I'm just going to take the string without modifying it. And I'm going to make a short video, just to explain how to convert this string to Unix timestamp, so that we have the same type of data when getting candles from Binance and from bitmex. So timestamp, so else if exchange equals bitmex, and we return the candles. Let's modify a bit the get historical candles method on the Binance futures side as well, because we need to add the exchange argument. So the last three methods. For the placeholder one, we create our dictionary of parameters. We are going to need still the contract object, the order type, the quantity. So the quantity will be an integer because on BitMEX we actually buy contracts. So you cannot buy 1.5 contracts, you have to buy 1 or 2 contracts. The side is a string, and same thing, the price, we give it a default value, and the time in force as well. It returns an order status object. So the symbol, still the same way, we get it from the contract object. The side. So the side is going to be capitalized. So you will have either buy or sell. So to help the user, to help you not to make any mistake when passing the order type argument to the placeholder method, what we can do is to take the parameter, the argument that was passed to the method, and capitalize it. So that if the user passes this argument, the program will transform it to this. The order quantity nothing special with that. The order type, so same thing, we need it to be capitalized. If this is a limit order, the price is not going to be known, so we are going to pass it as an argument. And same thing for the time in force. Oops. Okay, so we're going to return the output of the make request method to the order status variable. We have a post request. So API v1 order, the parameters. If the request is successful, we are going to replace the order status variable by an order status object. And we're going to modify a bit the data model as you're already used to. So the exchange. So order ID, the key is a bit different on BitMEX. Status is old status, and the average price, average PX, and we modify it on Binance as usual. So order status when we cancel the order, it's quite simple. I'm not even going to write everything again. So I'm just copying the part from the placeholder function, from the placeholder method. We only need actually the order ID. So this is going to be a string, we pass it. We have it as an argument. So the order ID of the order we want to cancel. And this time we have the same endpoint but a delete request. it returns a list of dictionaries and not just one dictionary, because you can cancel several orders with one API call. So this is why the order status is a list, and we are just taking the first one of the list because we are going to cancel orders one by one. So if it's not known actually. So the last method, the getOrderStatus1. So we have to pass arguments. So actually we can only pass the symbol. We cannot pass the order ID of the order we want to get data from. So we need to get all the orders of a given symbol, for example, XBTUSD. So the symbol that will be, so we use actually a contract. And the response is going to be a list of order status for the symbol we have selected. So we have a GET request. And since we are interested in only one order ID, we have to loop through the result. So for order in order status, and compare the order ID of the element of the list with the order ID that we want. So if this is true, we know that we found the order ID we are interested in, and we are going to return it from the function. So we don't need this actually. We directly return the order status object. So I explain it again. This is a list of order status of order dictionaries related to this symbol, the symbol we've requested, and we are looking for a specific order ID. What we can add also as a parameter is reverse equals true. This means that it will return first, so the first element of the list will be the newest order IDs. So it will most likely find the one we want faster, because we assume that if we request some information about an order, it's not about an order that was placed 6 months ago. It's one that was placed recently. So let's have a little test. BitMEX will place an order first. So we'll take the Bitcoin USD contract. We place a limit order, let's say 50 contracts. It will be a buy order, and the price, so that it's not executed, price is going to be 20,000. And time in force, I need to check the documentation again. So good till cancel. So print so that I can see the order status, and the contract actually is XBT USD. Okay, let's have a look. Yes, I wrote the wrong argument for the side. So we have our order, it's been placed. We have the order ID. Let's get the status of it. So print BitMEX get order status, the order ID, and the contract. Yeah, we do have information about the order. Let's say we'll print the status. Good, new. And we will cancel it. So we need only one argument. And we can print the status that should be cancelled as well. Okay, perfect. So we can tackle the WebSocket API from the next video. There are not many differences between the Binance features and the BitMEX WebSocket API. There are three differences. The WebSocket base URL, of course, that we have indicated here. There's a way we can include this back. Then the data that we receive on the onMessage callback is a bit differently structured. And we subscribe differently to the feed. So on Binance features, you can choose to subscribe only to one channel and to one contract, while on BitMEX, you have to subscribe to a whole feed. So if you choose the feed that gives you updates about the bid and ask price, you will get this information for all the contracts that are available on BitMEX. By the way, this returns all the status. We can copy most of the WebSocket methods from the Binance Features module. I just noticed I didn't set it as private variables because we are taking this one, the one from the class initialization. So I'm changing this. Okay, so I can copy it to the BitMEX module. Well, nothing to change here. On the onOpen, we need to change the exchange name. Same thing here, here, and that's it. So we don't need the WebSocket ID. When subscribing to a channel, we are actually going to subscribe to a whole feed. So one we're interested in is the instrument one. So this is not going to be a contract anymore, but just what they call a topic, that is a string. The method is OP, parameters is arguments on BitMEX, and this is in lowercase. So we only append the topic we subscribe to. And yes, here as well. So on the onMessage callback, the data is going to be a dictionary as usual that contains the name of the feed that you subscribe to. So it's a bit like the E we had on Binance. So this is going to be called table, and the value of this key must be the channel we subscribe to. So instrument in this case. The symbol is, so actually we have a key named data. So data, and again data, that is a list, because we may receive several updates for different instruments in one WebSocket message. So we are going to need to loop through this list and parse the data for each element. For D in data, the data key, the symbol is going to be represented by the symbol key. And what's important is that you don't necessarily get a bid and ask update in the same message. You may have only the bid or the ask updated. So if the key is not yet in the dictionary, we are only creating it, but we don't initialize yet the bid and ask keys. Then we can check if, so the key is called bid price, is in the element in the dictionary. If yes, we can update the bid of our prices dictionary. Same thing for the ask. So let's print the output of the function. Let's have a look at the updates. Okay, looks like it's working. We can print the symbol as well. Okay, so you see we subscribe to the instruments feed and we get updates for all the instruments. When we wrote the methods to get historical candles from Binance and BitMEX, we noticed that Binance returns directly the Unix timestamp of each candle, while BitMEX returns a standardized string to indicate the time of the candle. This standard is called ISO 8601. Date and time are separated by a T, and the Z in the end means UTC for the time zone. What we would like is to have a Unix timestamp in the candle object, both for Binance and BitMEX, because it's going to be easier to manipulate. So we are going to convert this ISO 8601 string to a datetime object first, and then convert the datetime object to a timestamp. For the conversion to a datetime object, there is a library named Python dateutil that has a method to parse ISO 8601 strings. Let's install it. Then we import it in the models module. And using the isoparse method, the self.timestamp variable is now a datetime object. And datetime objects have a method called timestamp to convert it to a Unix timestamp in seconds. Self.timestamp equals self.timestamp again, dot timestamp. So this is a datetime object, and this is a Unix timestamp. Since the Binance timestamp is in milliseconds and an integer, we just multiply this one by 1000 and convert it to an integer. So let's print the timestamp before and after conversion. Running a small test with the get historical candles method of BitMEX. For, let's say, 1 hour. So you can see here we have a string, then we have a datetime object, and finally a Unix timestamp in milliseconds. So we almost got what we wanted, almost because of a very important detail, and this is why reading the documentation of any API that you use is important. The timestamp that BitMEX returns is the end time of the period. So the end time of the candle, not the start time of the candle. So if they say that a candle timestamp is 3 p.m. and we are on a 1 hour time frame, it means that the candle started at 2 p.m. and finished at 3 p.m. While it's more common to use the candle start time with other exchanges like Binance. So we are going to change this as well. It's not difficult. We are just going to use the self.timestamp variable when it is a datetime object, so at this stage, and use the datetime library to subtract some time. So I import the datetime library, and we are going to use the time delta method. So cell.timestamp equals cell.timestamp minus so you can subtract minutes, hours, seconds, even days to a datetime object. We are going to use minutes. And to know dynamically how many minutes to subtract, we are going to create a global variable that we are going to call bitmax tf, like time frame minutes. That will be a dictionary. For example, 1m is 1 minute, 5m is 5 minutes, 60m, so actually it's 1 hour, is 60 for 60 minutes, and 1 day is going to be 1440 minutes. Then we simply need to add an argument to the candle object, that will be time frame, and depending on this value we are going to select a key in the dictionary. So if we pass a 1 hour argument, it will find 60, and minutes will be equal to 60. So it's going to subtract 60 minutes to the current datetime object. And we will have the start of the candle. So the last thing to do is to modify the connectors. So the getHistoricalCandles method. So when initializing the object, we actually pass the time frame. Then if we print the output, so if we print the output of each candle for the timestamp variable, so let's display it as the datetime object because it's easier to read. Okay, so it shows the oldest 500 candles. To show the newest ones, we are going to add an argument in the bitmax module, in the getHistoricalCandles method, that is reverse equals true, to show the newest ones, like they indicate here. So now at the time I record this video, it's 4 o'clock 38 minutes in my local time, that is 3 o'clock 38 minutes UTC time. And thus, the most recent candle that the API returns is the one of 3 p.m., which is right, because this is the current candle. So it's a partial one, as we decided with this parameter. It's not finished, it will be finished in 12 minutes, but it's still displayed. One last thing we can do is that, as you can see, it returns first the newest ones, the 500 newest ones. We could actually reverse this list of row candles so that it returns first, so that it starts with the oldest candles and ends with the current one. So if we do reversed on this, we do see that the last candle that is added to our list is the most recent one. In this video, I'd like to talk about the problem of rounding prices and quantities when sending an order to BitMEX or Binance. Let's take an example of BitMEX and XBTUSD. If you call the placeholder method with a price that has 2 or 3 decimals, the order will fail because it needs 1 decimal maximum and only with increments of 0.5. This is the tick size. So we need to round the price to the nearest 0.5 multiple, or whatever is the tick size for the contract. Let's change what we called price decimals and quantity decimals in the contract model to the tick size and lot size on the BitMEX side. On the Binance side, To calculate the tick size and lot size based on the price and quantity decimal, we divide 1 by 10 to the power of the number of decimals. So for example, if the number of decimals is 3 for the price, we will have the tick size equals to 1 divided by 10 to the power of 3. So 1 divided by 1000. On the BitMEX side, we do the reverse. That is to say, we already have the tick size, but we want to calculate the number of decimals corresponding to the tick size, because the number of decimals will be useful when we display prices on the interface. So I'm writing a simple function that takes as argument the tick size or the lot size, and returns the number of decimals. So I first convert the tick size to a string so that it shows 8 decimals in the string. Otherwise, the string will display a scientific notation. Then I'm going to remove the extra 0 at the end of the string in case the initial tick size had less than 8 decimals. Then I'm going to split the string in two based on the dot that symbolizes the start of the decimals of the tick size. And finally, I'm going to return the number of decimals after the dot, if there is a dot. So if length of the split is more than 1, that means there is a dot in the string, because we were able to split the string in two. I'm returning the length of the second part of the split. So for example, if we have a string that is 0.001, it's going to split this based on the dot. Then we select this part and we count the length of the string, so that will be 3 here. Otherwise, if there is no dot, we just return 0 because that will be the number of decimals, so no decimal. So I can apply this to the model. That will be price decimals and quantity decimals. We call the function Finally, we are able to write a simple formula to round the price to the right tick size in the placeholder method. Let's start with Binance, for example. And then BitMEX, we do the same. By the way, if order status is not known, because we want the request to be successful. And one last point, since Python floating numbers might return extra decimals when you perform operations on them, for example, when you do print 1.1 plus 2.2, you expect the output to be 3.3. Let's see. Okay, let's remove that. So you see we don't get the exact output that you wanted. So because of this, so let me remove that. It would be wise to make sure that we round any number that has more than 8 decimal places. Because on BitMEX and Binance, you won't have more than 8 decimals for a price or a quantity. On BitMEX, I only do it for the price, because anyway, the order quantity is an integer. And that should work. Let's see. If we send to BitMEX, or let's say BitMEX, so placeholder on the XBT USD contract, then that will be a limit order. Quantity, let's say we have a wrong input. Then we input a wrong price as well, like 20,000, and let's say we add too many decimals. So let's see if the order still is rounded to 20,000.5 because of what we've added. And good till cancel. So you see, it returns an order status. So it means the order was placed successfully. That means no error. Otherwise we would have a log message. So everything works as expected. Okay, welcome guys to a more artistic part in this course. After the section about the connectors that was very technical, you are finally going to see some colors on your screen. Before starting to write the 4 components that were described in the course overview, we need to prepare the root window so that we can place the components on the top, on the left, on the right, etc. There will be a few lines of code to do that, not too many, but still we don't want to write that in the main component, because the main component is just an entry point to our application. This is why we are going to create a Python module dedicated to this component. We are going to name it root component. The root component will also be used to code later some functions that are not related specifically to one component. For example, we will have a function to save the current workspace, to save the strategies that you have created in the interface, for example. So let's create it. The class will be called root. As usual, the init function. And you remember we used the tk.tk class to create our root window. tk.tk has methods and attributes, like any class. For example, we saw the main loop one. But as I said, the root class is going to have more methods than the basic tk.tk class. For example, the save workspace method. And it's going to have attributes like takeinter frames or other takeinter widgets. So how do we keep the tk.tk class methods and attributes while instantiating our root class? Well, the answer is that we will make our root class inherits from the tk.tk class. Inheritance is a programming concept that is used in other programming languages as well, but this is the syntax in Python. Now, self can refer to a tk.tk object. As you can see, we can have access to the main loop method. Let's import and instantiate the root class to the main module. By the way, we can create a directory to store the modules dedicated to the interface, just to keep the project structure clear, like we did with the connector directory. So I put the root component in it, and now I'm going to import the root component here. We can remove this. Let's see how it looks. So you see, it works exactly as before, but now the root object can be customized. Let's give a name to our application. This name will be displayed at the top of the root window. Self.title, we'll call it Trading Boat. And you see the name is displayed here. Let's also change the background of the root window. That will be the background we used previously. I'm actually going to store all the variables related to the application design in another Python file called styling. Because this background color, for example, is going to be used in other components as well. So we don't want to repeat bg equals gray 12 all the time. bg color equals gray 12. It will be like a global variable, but we still need to import it. So we import the variables from the styling module. And we have access to the bg color variable. Okay, what else do we need? If you remember in the introduction, we said that when placing the widgets and the components, when placing the big blocks of our application, the pack method is going to be the best. So we are going to have our root component separated in 4 blocks. However, how do we code that some component is on the top left, another one on the top right, another one on the bottom left, and the last one on the bottom right? Well, we first separate the root window in 2 vertically by creating a left frame and a right frame. Then we separate the left frame in 2, but this time horizontally, having a top and bottom frame. And we do the same with the other frame, with the right frame. Let's first do the left and right split by creating 2 frames in the root component. So this is a widget for the frames. The parent component, the parent widget is root, so we can refer to this as self. The background is going to be the same as the root component, so bg color, the gray one. We place this left frame, well, with the pack method to the left. And we do the same with the right frame. So that will be placed to the left, but after the left frame. That has a priority because it was placed, packed before. So if we run the program, there won't be anything in it because the left and right frames are empty. We haven't added anything to it. There is no component, there is no widget in it. The logging component is going to be the simplest one. So this is a good way to start. Let's create the module and the class. So we call the class simply logging. This class is going to inherit not of a tk.tk class like the root component, but of a frame class, a frame widget. So when we are instantiating a logging object, we are actually creating a takinter frame that we will place in the left frame of the root component. So we are going to assign a variable called logging frame to the logging object. I need to import it first. And we set that the parent widget is the left frame. By the way, it can be a private variable. Same for the right frame. So we place it with the pack method again. And there is just one thing to add to be able to pass arguments when instantiating the logging object. Arguments like self.leftFrames or background color like BG. We are going to add this in the init function, in the init method. And same in the super init method. Args means that we are allowed to pass arguments without specifying its name, like we did when passing the left frame argument. And KW args means that we can pass keywords arguments, like BG equals gray12, BG equals BG color. So what happens is that we pass these two arguments to the class, and then what happens here with the super.init method is that we instantiate the frame. Back here. Okay, so the logging component is going to display messages to the user. We already have a way to log things in the Python terminal that is useful for debugging purpose, but there is some information that we would like to be displayed directly to the user interface. Information about the trades mostly, like when an order is successfully placed, so that the user doesn't have to constantly check the Python terminal and gets the essential information directly in the interface. One long message is going to be one line. So we have a takinter widget that is perfect for this, and it is called text. So we place it in the frame with self, because self designates the frame, and then we just pack it. We use the pack method to place this widget in the frame because there won't be many widgets. Actually, there will be only one in this frame, So it's not like a complex structure that makes a grid method necessary. We can specify the height of the text widget, that is the number of lines. If there is more than 10 lines in this widget, then you will have to scroll down or up so that you can see them. The width can be 60, that should be enough. We can also specify the state argument. That is to say whether the text widget is locked or not. So when we write to this widget, we will have to unlock it and then directly lock it again, so that the user cannot manually write text in it. And the background color can be the same as we had before. Regarding the foreground color, let's create two variables in the styling module. One for the white foreground and the other one will be steel blue. At the same time, we can create a Calibri font. And now we can specify that the foreground color is going to be the steel blue one. And the font is going to be the one we've just defined. Okay, let's have a first look at this widget. You do see the text widget exists. I cannot click on it because it's locked. And of course we need to have a method to add a new log. So that will be the only one of this component. Add log, it has to be public. And the argument will be a message, a string. So we first unlock the text widget. And in the end, after adding the message, we will lock it again. So I'm doing it right now. To add a message, to add text to a widget, we are going to use the insert method. So what happens here is that the 1.0 argument indicates that the text is going to be added at the beginning, so before the existing text. And if we add tk.end, the text will be added in the end. By choosing 1.0, it will make the newest logs to show at the top of the widget. And we also add the message, plus a new line character after the new text, so that this log will appear on a new line. So let's see with an example. So we can have it here, after instantiating the logging object. Okay, the message is displayed, so everything is fine so far. It could be nice also to add the time of the log before the message itself. For this we can use the datetime library. Let's import the datetime class from the datetime library. We get the current UTC timestamp with the UTC-now method. But you can also get your local time with the now method. And then we can convert the datetime object to a string with the string_from_time method. And then we specify the exact format of the string. So with %A, it means to have the weekday, actually the first 3 letters of the weekday. For example, Monday will be M or N. Then %H is for the hour, %M for the minute, %S for the second. Let's see by adding not 1 but 2 logs. So after some time, so you see that the time followed the format we have described here. And the 2 messages are displayed one after the other, and the most recent one is at the top. In the previous video, we have created the logging component and tested some log messages from the root component, which was easy. Let's remove them. But how do we log information when this information comes from another module? For example, the connectors. If we take the BitMEX module, we don't have access to the interface from it. There is no variable to access the root or logging component. We could think, okay, we can create our BitMEX connector after the root component and pass the root object as an argument to BitMEX, like this. And then we are going to find a way to access the interface. So let's assume we have this. Then let's assume that in the WebSocket thread, every time that you receive a bid and ask update, we want to display it to the logging widget. So and if we just check by running it once, this should work. However, this is one of the worst things that you can do with Tkinter, because what we are doing here is that we update the user interface from another thread, and this can typically make your program freeze and eventually crash. The rule is that no other thread has to tell Tkinter what to do. So the WebSocket thread should never say, okay Tkinter, I got new data and now display them, and force Tkinter to update. Instead, the WebSocket thread should say, okay Tkinter, I got new information, a new bid and ask for Bitcoin USDT, and I'm storing this information in a variable. And when you're ready, you can take this information by yourself and update your user interface by yourself. So let's remove what we've just done. From a programming perspective, what we are going to do is to create a function that checks periodically for new data to display, let's say every second. What we can do is to have in every connector a self.logs list, and we are going to add logs there. And the root component is going to take this list, loop through it, and display the new items. So let's have a method to help us adding new logs. We are going to log it as well in the Python terminal. And we are appending to the list a dictionary with the log message and whether it was displayed yet or not. When this element of the list has been treated, we will turn the display key to true. For example, let's add a log. So let's first add it both to Binance and BitMEX. And this is a string. So let's add a log when we receive an update about the XBT-USD contract. So if the symbol is XBT-USD, we call the add log function, we display the symbol, then a space, then the bid price converted to a string, and same with the ask price. So we separate this with a slash. Then we are going to write in the root component the function, the method that checks periodically for new logs to add. So we are going to call it update UI. So we actually need access to the BitMEX connector from the root component, which we haven't yet. Let's fix this. We are simply going to pass the Binance and BitMEX objects to the root component when we instantiate it. So we create arguments for both, for Binance and BitMEX. And we are going to import the class, the Binance and BitMEX classes, because we want to be able to type these variables, to know what is their type. So we create instance variables because we want to have access to the Binance and BitMEX objects everywhere in the class. So now we can loop, for example, through the BitMEX logs, through the list. And if this log, this element hasn't been displayed yet, we are going to add the log to the interface, to the logging component. We do the same with Binance. And once the log has been displayed, we can modify the element, the key, the displayed key, to true. Then when we instantiate the root component, we are going to call this updateUI method once. So it's going to perform an initial check. And once the first check has been finished, we are going to call this updateUI method again after 1 second. So in Tkinter, there is a way to call a method after some time, and this method is called after. So self representing the root component that has an after method. Then we specify after how many milliseconds. So let's say 1.5 0.5 seconds. So we call again the self.updateUI method. So it's going to call itself every 1.5 seconds. This value of 1.5 seconds has to be adapted on your program, depending on how many information there is to update. Because if there is too many information to update and you call this function every half a second, it might slow down the program. So it really needs to be adapted. Let's see if everything works. So it looks like I haven't converted. Yes, I concatenated strings and floats without turning the floating numbers in strings. So let's have a look. It was on BitMEX. Yes. The parentheses must end here. Let's try again. Okay, so we do have an update every 1.5 seconds. So for now, the price, the bid and ask price do not change much, but the update works. So this way of updating the interface will also be used when creating the watchlist component, so keep it in mind. The watchlist is going to be a component where we can monitor market data. For example, the bid and ask price for some symbol. But you could actually monitor anything. Monitor an indicator value, the last 1 hour volume, anything you want. This is a good opportunity to learn how to update a Techinter label, organize a grid, see new Techinter widgets like buttons, entry boxes, and learn more about Techinter in general. The code itself isn't going to be too long and complex. We just need to understand well the structure of the component. There will be 2 parts. At the top, we will have 2 entry boxes where we can type the name of the symbol we want to add to our watch list. 2 entry boxes because 1 for each exchange. At the bottom, we will have the actual watch list that will look like a table with columns like the symbol name, the exchange, the bid and ask price. And at the end of each row, there will be a button to remove the symbol from the watch list. Let's write the class first and place it on the root component. So I create the module first, watchlist component, I import Techinter, so the class, calling it simply watchlist. It inherits from a frame, like the logging widget, like the logging component. Then I'm creating the 2 main frames. So the one at the top, I will call it commands frame. We pack it at the top. And the one at the bottom, I will call it table frame. Okay, now in the root component, let's place the component we've just created. So import it. And I place it before the logging frame so that it will be really at the top. Then the idea is to populate the comments frame with 2 entry boxes, plus 1 label above each of them to know whether the entry box is for Binance or BitMEX. So creating the 2 labels first. The text is simply the name of the exchange. So this one will be at the top left, in the first cell. We place this widget on the first row and the first column. And this one will be on the second column. Regarding the entry boxes, so that will be Binance entry. We have the entry widget. So that will be the color of the text. Then we choose to center the text. And that will be the insert background, that is to say, the color of the cursor when it is placed on the entry widget. So we place it on the second row, but still the first column. So it will be under this label. We do the same with BitMEX, placing it on the second column. Let's also create a specific background color for the entry boxes. So currently we have this, and let's make the background blue. So that will be PG color 2, let's say. So this is a color I found on the internet, and it is some dark blue color. At the same time, we can create a bold font that will be useful for the headers, for the labels. Okay, so the bold font will be here on the label, as well on BitMEX. And as we said, the background color of the entry boxes will be PG color 2. Oops. So let's have a look. Okay, it looks nicer, and we do have the cursor, as I said, the insert background. Okay, so this was it for the upper part of the watchlist component. Regarding the lower part, with the actual watchlist, we can already create the table headers that will be on the first row. And instead of writing the headers one by one, we can simply have a list of these headers and use a loop to create the widgets dynamically. So the list, we have the symbol, the exchange, the bid, and the ask. So we create a loop. The enumerate function lets us access at the same time the value of the element of the list and the position in the list. For the first element, idx will be 0, the second element, idx will be 1, etc., which will be useful when we place the widgets on the grid, because we can have access to the column number this way. So that will be a label that is placed in the table frames frame. The text is the element, the value of the element in the list that we can capitalize. The background color is the main one. The foreground color is white, so FG color. And let's say that the font will be bold. We place it with the grid, so on the first row and on the column that is indicated by IDX. Okay, let's have a look. We do have the headers. If we now think about the functionalities that are required in the component, there are actually only two: adding a symbol to the watch list and removing it. From a user experience point of view, the easiest setup is that we have the user type the symbol name and then presses enter to validate. So no button is required. When the user presses enter on the bitmex box, it's going to trigger a callback method. And when pressing enter on the Binance box, it's going to trigger another callback method. Remember, we talked about callback methods in the connectors section to understand the WebSocket client library. To do this, we take the entry box variables and we use the bind method to associate a keyboard action to a callback function. So when the user presses enter or return, we are going to call this function, this method. Let me create the method. When the method is triggered, it automatically receives an event argument that contains some information about the user action. For example, we can access information about the widget. And since this is an entry box, we can use the get method to get the entry box content. So that will be the name of the symbol. We can do the same for bitmex. Then, in these two methods, we are going to trigger another method that will be the same for the two, to actually add the symbol to the watch list, creating the necessary widgets, add a new row, and start displaying data. We can call it add symbol. And pass two arguments, the symbol name, that is a string, and the exchange, that is also a string. So cell.add symbol, we pass the symbol, and the exchange name, that is Binance. And here it will be bitmex. So let's return nothing for the moment. And when the symbol has been added, we can erase the content of the entry box with the delete method. So event, we access the widget, delete from 0 to tkn, which means that we delete the entire content of the widget. However, it could be nice if we first check that the user didn't make any mistake when typing. For example, if the user types XBT/USD in the Binance box instead of Bitcoin USDT, we don't want to add the symbol. For this, we need, in the watchlist class, a list of symbols for both exchanges. So we can pass the dictionary of contracts for the two exchanges when initializing the watchlist object. Then if we want to specify the type of these variables, we need the typing module, and we also need to import the models. So that will be, as usual, a dictionary of strings and contracts. Same for the two. From this, we can get simply a list of symbols. We don't need more information, like we don't need the price decimals, etc. We only need a list of strings, the list of symbols. So let's create a list called Binance symbols. We will convert the Binance contract keys, so the strings that we have in the dictionary, using the keys method, to a list. And we do the same for BitMEX. So we pass the two new arguments when initializing the watchlist component. So first Binance, we get the contracts, and same for BitMEX, the contracts, because contracts is a public variable of the Binance object. So we can access it from the root module. Okay, let's have a look. Just print the list for Binance, just so that you can see that we do get a list of strings. Okay, so we can verify that any symbol that we type for the Binance box will be inside this list. So in case there is a wrong input, you will know about it, because the widget will still contain the symbol name. For example, if I type something wrong for Binance, you see it doesn't disappear. While I do Bitcoin USDT, it disappears because the if statement was true, so it got to this part. When the method to add a symbol is triggered, it's going to add 4 labels to the watchlist component on a new line. 1 label for the symbol name, 1 for the exchange, 1 for the bid price, and 1 for the ask price. There are 2 new things to take into account though. The bid and ask labels will be updated, their text will change. And there are going to be multiple widgets that share similar features, so we need to store the widgets in a variable, for example, a dictionary. What we can do is to create a dictionary with 4 keys: symbol, exchange, bid, and ask. And for example, in the symbol key, we will have another dictionary with IDs corresponding to a widget on a row. We can have the ID be equal to the row number to simplify. Let's create this dictionary that we will call body widgets because it will refer to the widgets in the table body. Then we create the keys of the dictionary in a loop so that we can reuse the self.headers variable. So the symbol exchange bid and ask keys are going to refer to a column of the table. So when we need to access a specific widget, we first select the column, for example, and then we can access a specific row with its ID. We also need an integer variable that is the current last row of the table. And every time we add a new symbol to the watch list, we will increment this variable. I'm calling it body index. It starts at 1 because the row 0 is occupied by the column headers. So when triggering the add symbol method, I'm creating this variable that is a reference to the self.bodyIndex variable because we are going to write this variable many times in this class method, so it's more convenient to have a short name for it. Let's create the 4 labels. Okay, so as you may have noticed, for the bid and ask labels, I changed the text argument to a text variable argument, because these labels are going to change. The value of this argument must be a techinter string var object. And this object has a method called set that lets us change its value. For example, let's say we have a bid var. We would be allowed to change the value of the string var object with the set method and, for example, set it to 20.38. Since there will be 2 string var objects for each row, one for the bid and one for the ask, we will need to store these variables together with the other widgets of the row. So we can add 2 keys in the body widget dictionary, bid var and ask var. I'm going to create them dynamically with the other ones in the loop that we had. So if the header was bid or ask, we're going to create a key called bid var or ask var. So let's say h plus underscore var, that will be bid or ask, just to save some space. Then when we create the 4 labels, when we create the bid label, for example, so just before it, we are also going to create 2 string var objects. Still in the body widgets dictionary, so bid var, the index, and we create the tk.stringvar object. Same for the ask, and we can set this variable to be the text variable argument. So when we want to modify the value of the bid and ask labels from another module, we can simply access the body widget, because it's public, and the bid var or ask var key, and then use the set method on it, and set it to whatever value we want. And we don't forget to increment the row in the end, the body index. Okay, so far this is what we have. We run the program. Then we type, for example, Bitcoin USDT in uppercase for Binance. And we have a new row with the symbol, the exchange. The bid and ask are not updated yet. We will do that in the next video. What we need, what's the last method to add to our watchlist, is the one to remove a symbol from the watchlist. We will only need to know the row ID, the row number of the symbol to delete it, and remove the labels with the grid forget method. So I'm defining the method, let's say here. It takes a body index argument, so an integer. Then when the method is triggered, we loop through the columns, we select a row that we want to delete, and we apply the grid forget method on the widgets of this column for the cells to disappear. So looping through the columns of the dictionary. We select the column, then we select the index, and we call the grid forget method. We also delete the ID of this specific row from the dictionary, so that it will delete the widget. Now, how do we trigger this method? Well, we need an additional column in the table that will contain a button that triggers the method. Let's call the column remove. And we don't need a header actually. We don't need any text displayed in the header for this column, because the button will be clear enough. That will be a red button with a white cross, so that's easy to understand. So inline if. Now adding the button when we add a symbol to the watch list. We replace the label by a button. We access the remove column, we place it at the end. We'll simply have a text across. The background color is going to be dark red. So this is the background of the button. The foreground color can be white, so this is FG color, I think. Yes. And we can keep the same font. On Mac, you will see that the button background doesn't change. I will address this issue in another video. We are going to use an external library called TK Mac OS X. We also need, so let's see how it looks so far. Add in Bitcoin USDT again. Okay, we do see the button. we also need to add an argument called command to define what happens when the button is clicked. That is to say, we are going to trigger the remove symbol method. Usually when you define a callback method, because this is a callback method, you don't add the parenthesis like I did here. Otherwise, the method will execute immediately when you create the widget. However, unlike the other callback methods we have seen so far, this one requires an argument from us. The row index, b-index, body index. So we are still going to add the argument between the parentheses, that is b-index. But to avoid the function to be triggered immediately, we use the lambda keyword before it. It is necessary only when you have a callback method that must take arguments. Let's have a look. So I'm adding again Bitcoin USDT. Let's add XBT USD as well. If you delete a row, okay, it disappears. So let's assume I'm adding ETH USDT, Bitcoin USDT. If you delete a row that is between two other rows, Takinter will automatically adjust by filling the gap, as you can see here. In this last part, we want to finally display the bid and ask data to the interface. Remember the good principles about Takinter interface updates. Outside of actions triggered by the user, like clicking on a button, the only part where we are allowed to update the interface is the update UI part, the update UI method, in the root component. So the idea is to loop through the body widgets dictionary, loop through the indices, representing the rows, and update the bid variable and ask variable. To loop through the keys and values of a dictionary, we do for key value in, so the dictionaries, watchlist frame, it's body widgets, and we take a column, any column, dot items to loop through the items of the dictionary. I'm looping through the symbol key, the symbol column, because I need access to the row IDs. But you can replace symbol by exchange, bid, ask, it doesn't matter. Let me separate this a bit. To find the bid and ask for the row that we are currently looping through, we need to know the symbol and the exchange of the row. We can access the value of a Takinter label with the cget method. So symbol equals, so still self.watchlistFrame, body widgets. This time we do need precisely the symbol key, the symbol column, the key, the ID, so the row number, cget text. We do the same with the exchange, but this time we access the exchange key. So if the exchange is Binance, first, let's make sure that the Binance Contracts dictionary has a key with this symbol. So if the symbol is not in self.binance.contracts, we can just continue and we won't update anything. Then we check that the prices dictionary has a key with the symbol. Otherwise, it means that we haven't received any update with this symbol yet. Because unlike BitMEX, Binance doesn't send a bid and ask snapshot when subscribing to a symbol update. This is why I wanted to have in the Binance connector a method with a REST API to get a snapshot of the bid and ask price. So in this case, we call the get bid ask method of the Binance connector. And we pass the contract as an argument, because we have already checked that symbol is in Binance.contracts. And on the next update UI call, we should have a bid and ask for this symbol. So if the key exists in the prices dictionary, we can create a temporary variable to store the value. If the exchange is BitMEX, we do the same. Except that we are not calling the getBidAsk method. Okay, so else if. And let's stay on the safe side and take into account the case where the exchange, for some reason, wouldn't be exactly Binance or BitMEX, maybe because we had a typo in the watchlist component. One last check, whether the bid and ask is not known. If prices bid, we access the dictionary, is not known, then we can update the bidvar variable. We use the set method and same with the ask. As you can see, I'm really checking every possibility, anything that could go wrong, because the update UI method is like an infinite loop, so we really don't want it to crash. Just before testing, I noticed that in the Binance connector, in the getContracts method, we need to have the key of the dictionary be symbol instead of pair, because there are two contracts with the same pair name. Just to show you, if we print contract info and start the program, you see we have the pair name that is here Bitcoin USDT for some futures contract, and for the perpetual one we also have Bitcoin USDT. So if we take the symbol key, we will have only unique keys in our contracts dictionary. Okay, let's have a look. If we type BTC USDT, we do see the updates, XBT USD, same. You can type also ETH USDT. We do get updates about everything. There is actually one problem left. Let's restart the application and add a symbol that has a price with 8 decimals, like ADA H21. So depending on when you watch this lecture, this particular futures contract might have expired already. You see it shows the scientific notations, which doesn't look great. What we can do is to format the floating number to a string. with a predefined number of decimals, and this is why we needed the price decimals attribute in the contract model. So precision is going to be cell dot, in this case bitmex. We access the contract, the symbol, and we get the price decimals value, and same for Binance. And this is how we do the string formatting. So let's create a variable called price string. We call the format method. We provide the bid as an argument, and we pass a keyword argument to the format method. So the value of the argument is the value we got from the contract subject. Same for the ask. And now we will set the bid variable to the price string format that we have. So just forgot this. Let's have a look. So again, add a H21. Now it looks better. I'm going to surround, so removing the empty lines. So I'm going to surround this loop with a try except statement. Because if we loop through the dictionary while a new key is being added or a key is being deleted from this dictionary, for example, if we are looping through the dictionary and at the same time the user clicks on the button to remove a symbol from the watch list, there will be an error. So that will be try except, and the error is a runtime error. We are going to log, we still can log a message to see how often it happens. Or just error while looping through the watch list dictionary. And this is something that is not easy to guess when you are a beginner, but when you write some code to loop through a dictionary, try to always wonder whether it might be modified by another part of your code at the same time. And one last advice, okay, actually, yes, there is no logger object, so let me copy it from another module. And one last advice, do not perform heavy operations directly in callback methods. Otherwise, the UI won't be responsive during this operation. For example, if I'm simulating something that takes 3 seconds, importing the time library, okay, I run the program. Let's say I add XBTUSD. Okay, you see the program is not responsive for 3 seconds. So this is why you should not have something that is too long in your callback method. The trades component is going to be a useful tool to follow what's happening with the trades that are taken by the program. We will be able to know what is the trade status, the strategy used, the current P&L, the quantity traded, and of course you can add more data as needed. If you understood how we built the watchlist component, The trades component is going to be easy for you because we are reusing the idea of adding rows to a table. We will have only one method in the class, the method to add a new trade, add a new row, so things are going to be easier than the watchlist component. The code is going to be shorter. In the previous exercise, I mentioned that some labels are going to change, like the bid and ask labels on the watchlist component. We will still use the updateUI method to update the trades component, but we won't write the code of the updateUI method yet in this lecture because it relies on the strategy module that we are going to tackle only in the next section. Okay, let me create the trades component. So still in the interface directory, trades component, import TechInter, the styles, the interface styling, so I create the class that we'll call TradesWatch that inherits from the ticket.frames class, and the init function is going to be the same as for the watchlist component, except that we don't need additional arguments because we had the Binance contracts and BitMEX contracts in the watchlist class. Okay, so the headers are going to be, so the time of the trade, it can be the entry time when the order is executed, the symbol, the exchange, the strategy, so we will have two in this course, the side, long or short, the quantity traded, the status of the order of the trade, whether it's open or closed, and the current P&L. I'm still creating a frame specifically for the table, even though we don't have an upper and lower frame in this widget, in this component. So we place it on the TradesWatch frame. The BG color is as usual. Okay, again looping through the headers with the enumerate function. Or actually we could simply copy this part from the watchlist component, so that will be from here. So the body widgets still used to reference the labels or the widgets that are on each row. So we don't have a remove column. We will keep all the rows all the time. And the variable parts are the status, because it can be opened and then changed to closed. So the status is a variable, and the P&L, of course, because it's going to change as the market price changes. Okay, I can already place this new component on the root component. So that will be on the right frame. So let me import it from interface.tradesComponent, import TradesWatch. So trades watch here, trades frame, and let's have a first look. Okay, we do have the headers. Then the only method, as I said, is the add. We will call it add trade. It has to be public because it's going to be used by the root component, by the update UI method. The arguments are going to be, for the moment, we will have simply a dictionary. A dictionary that will contain keys like symbol, PNL, or quantity. So importing the typing module as well. Then we can reference or create our b-index variable to have a short reference to the body index variable. So that will be used to add a new row to know what is the current row number. And the difference between what we had with the watch list and this component is that with the watch list, when we were creating a label, so let's say the first label is going to be the time column, we were using the body index as an ID for the row. What we are going to do instead is to have a unique ID for the trade, so that we can identify the trade with something else than the row in the interface. So this ID, the easiest one, can be the time of the trade, because it's going to be in milliseconds, so it's precise enough, and that should be unique. You're not going to have two trades within the same milliseconds. So I'm going to call it t-index, like time index, and we will take it from the time key of this dictionary. So typically the index will be something like this. So that will be a Unix timestamp in milliseconds. And that will be used as the ID in the body widgets dictionary. So we create a label. We place it on the table frame. The text is going to be, for the moment, we'll simply display the Unix timestamp, and later we will convert it to a string. Then the background color, the same as before. The foreground color, we use the blue one. The font. And we won't forget to increment the body index in the end every time we add a new trade. So now I'm just going to write all the labels and the string variables, because there won't be anything new compared to what we have seen with the watchlist component. So nothing special here. It is like in the watchlist component. As you noticed, I created a status var entry and a PNL var entry as well. Don't forget to increment the columns number, and that's it. The strategy component should not be mixed with the strategy module. Indeed, the strategy component only has to do with the interface, triggering methods to help the user to input parameters and activate or delete a strategy. It doesn't have to do directly with the strategy logic. It's going to be harder to code than the other components because we have more features to add, more methods. So not only do we need to have a table with a list of strategies, similarly to the trades and watchlist component tables, but we also need a button to add a new strategy, a new row, a button on each row to delete it, and a button to activate or deactivate the strategy. The component should look like this. We will have the strategy chosen, the symbol and exchange name, the time frame because the strategies will be based on candles, and then 3 parameters that can be used for both strategies. The percentage of the balance to allocate to a trade, the take profit, and stop loss percentages. Why do I mention this before coding the strategies? Because as you can see, we have a button named parameters. And this button is going to open a pop-up window where we can set the parameters that are specific to the strategy chosen. Having this pop-up window also avoids having too many parameters on the screen that would overload the interface. As usual, I'm going first to write the class and the init method, and we are going to have a comments frame, like in the watchlist component, for the button to add a new strategy, and a table frame. So creating first the module, strategy component, importing takinter, STK, and the typing module, the styles, okay, we can copy a big part of the watchlist component just to save some time. So the name is going to be strategy editor. No argument for the moment, except the ones for the frame. So the command frame stays, the table frame as well. We can remove these labels and these entry boxes. Okay, so first the button to add a new strategy. We can simply call the variable add button. So a takinter widget, we place it on the commands frame. The text is going to be add strategy. The font, the normal one. Then the command, I can already write the name of the method that we will use in the other videos. So strategy, add strategy row. The background of this button is going to be BG color 2. And the foreground is going to be white. We can pack this button. It's going to be the only one in the frame. So ticket at top or ticket at left, it doesn't make any difference. Then the headers. So we will write them directly with the capitalized letter. The strategy, the contract, the time frame, balance percentage, take profit percentage, and the stop loss percentage. So we can remove the capitalized method. and we still have the body index. So let's see first by placing this new component on the root component. Let's see if we at least have the headers, if everything works. So still on the right frame, but before the threads watch, because it will be placed really at the top, so before the threads frame, it has the priority. Then I place it with the pack method, and I forgot to define this method, even though we don't write it completely in this video. We simply return immediately. Okay, so we have the headers, and in the next video we will see what happens when we click this button. Regarding the method that adds a new strategy, we still have the body index variable, and we increment it in the end. So this is nothing new. However, we have 9 widgets to add on every row, which is twice more than the rows of the watchlist component, for example. And we said that the strategy component is going to be more complex than the other ones, meaning that the code is going to be longer. So we need to find ways to shorten the code when it's possible. The technique I'm using in this case is similar to the one we have used so far when creating the table headers. I create the widgets in a loop. However, the difference is that the widgets are not going to be all the same. We don't have only label widgets. We have buttons, entry boxes, and a new widget called option menu that is like a drop-down list. What we can do is to have a dictionary to describe each of these widgets, to add and put these dictionaries to a list. Let's call it base params. So this is a list. And let's see an example with, for example, when we need to describe the strategy option menu. So we're going to have an entry, a key in the dictionary that is the code name, that is just an identifier, a key for the body widget. So we are going to call it strategy type. Then the widget, this is an option menu widget. The data type, whether it's a string, it's a floating number, an integer. So here we have a string, the strategy name. And then, depending on the widget, we are going to have additional keys in the dictionary. Like, for example, for the strategy type, we'll have the values. That is a list of values you can select in the option menu, the list of options. So we're going to have 2 for this one, technical and breakout, which are the names of the strategy we will code in the next section. Then let's do the other ones. Okay, so the contract is still an option menu. We have a string and the values will be a list of strings, a list of contracts for Binance and BitMEX. I will just provide an empty list for the moment because there are a few things to explain about this. But I can still create the variable. So we will create it, let's say here, sell.allContracts, that is a list that we will populate in another video. So the value, so let's rather say values. What we can also add is the width of each widget of the option menu widgets. Okay, and the time frame, we can create a list of time frames, so it will be all time frames. So for example, 1 minute, 5 minutes, 15 minutes. We'll have also, okay, 30 minutes, 1 hour, 4 hour, and of course we could add more. So it doesn't need to be as wide as the contracts option menu. Then the free entry widgets. So that will be the first one. We are going to call it balance percentage. Data type is a floating number. We don't have the values here because this is an entry widget. And same for the two others, the take profit and stop loss percentage. Then the button widgets, there are actually two, actually three. So that will be, let's have 3. Then the widget is a button. We're going to have additional parameters here. For the balance percentage and for all the other ones, we'll have the text that is displayed on the button. So actually, no, it's not balance percentage, it's parameters. Parameters, activation, and the delete button. So parameters is to configure additional parameters, more than these 3 ones. Activation is to activate or not the strategy, and delete is a button to delete the current row. So parameters for this one. We will set also the background color of the button. So that will be PG color 2. And a last parameter, that is the command. That is to say, the callback method, the method that is triggered when the button is clicked. So I'm already setting the names, even though we won't define the methods yet. So that will be show pop-up. And same for the 2 others. So this one will be off by default. Switch strategy. Background color is by default dark red, and same for the delete button. For the delete button, we'll have a method named delete row. And the default text will be simply a cross. So we can write the methods first, just to remove this highlight. So show pop-up, switch strategy, and the one to delete the current strategy. Okay, we can remove this for the moment. We'll leave the width be automatic. And actually, instead of populating the body widgets dictionary with a list of headers as usual, we can use the code names in the base params dictionary. So for H in base params, the keys of the body widgets dictionary will be the same as the code name we have in the base dictionary. And when we create the keys for the option menu, we actually need a string var object to be able to get the currently selected option. So that will be if h in strategy type contract and time frame. We create an additional key that is cell.okay body widgets h plus var, like we did with the other components. Well, the only thing left is to write the loop where we create an entry, button, or option menu widget. So this happens in the add strategy row method. We loop through the base params dictionary. We'll have a short name for the code name because we are going to use that very often. So base params, base param, code name. Well, if the widget is an option menu, we are going to create an option menu. So that will be still referenced in the body widgets dictionary. So this is exactly as we did with the watchlist component. So nothing new here. The option menu, we place it in the table frame. Then we need to input actually the string var that we need to create just before. So that will be codename plus underscore var. We create a string var object, and then we can add it as a second argument of the option menu class when we initialize it. Then each of the following arguments is going to be an option in this option menu, so an element of the drop-down list. Of course, we are not going to write Bitcoin, USDT, ETH, USDT, etc. one by one. Instead, we can take the list that we have here, so all contracts, and use the star operator in front of the list of values to unpack the list. So star, and then let's assume we have this list. Will be equal to so we can have this at the end of the option menu initialization without writing one by one each element of the list. And we cannot add other arguments in the option menu instantiation. So if you need to change other features of this option menu, like the width, we need to use the config method afterwards. String var here. So that will be, we select the widget, the option menu, config, and then we can set the width. Then with the other options, with the other widgets, that will be nothing very special because we have already seen that in the previous components. So if the widget is an entry, we still use the body widget dictionary to reference the widget. Ticket of entry we place it on the self.table frame. We center the text in it. And if this is a button, we need to add the text. So base params, and we select the text key. We need the background color. And the foreground color is always going to be white, so FG color. The last argument is going to be the command to trigger a callback method. So that will be lambda base params. So we select the function, the method that we defined here, and we pass one argument, that is the row number, so b index. Otherwise, if it's none of them, that won't happen normally, we can continue the loop. And yes, let's add this argument. So b index is going to be an integer. And the last thing to do is to place the widgets that we have just created. So that will be, with the grid method, we use the row equals to b index, and the column, we use the variable created by the enumerate function. Okay, one last check. Yes, this shouldn't be necessarily all contracts, but simply the value we indicate in the base param key, that will be values. And I think that, yes, if this is empty, this operator, the *1, is not going to work. So let's add at least one contract, Bitcoin USDT. Okay, let's say 2. Now, when we press this button, okay, everything works. We got the 9 widgets. So we see strategy, we have the 2, the contracts, the time frames. Here we can input floating numbers. And in the next videos, we will see what these 3 buttons will do. So we will code the methods associated to each of them. Starting with the shortest method, the method that deletes a row from the table, there is just one difficulty to consider. First, let's simply use the grid_forget method in a loop like we did when removing a symbol from the watchlist component. For element in self.baseparams, we use widgets stored in the body widgets variable. We access the column thanks to the code name. Then we access the row, the b index that we have clicked, and we press and we activate the grid_forget method. Here we are simply accessing each of the 9 columns thanks to the base param code names, and we access the row that is clicked with the b index to remove it from the interface. And we can also delete the element from the body widgets dictionary. If we test this, it looks like it is working. You will see. So we add a few rows and deleting them seems to work. However, if we click on other buttons, well, for some reason, it also triggers the delete row method. So there is something wrong. Testing also with the on/off button, it does the same. The problem is that when we create the lambda function in a loop, and the base param commands in the lambda function changes in every iteration, this change also applies to the previous lambda functions that were created dynamically. So in the end, every function has the value of the command of the last element we iterated through. So the last element of the list is the delete button. So what happens is that in the end, all the lambda functions that we create here take this value as a command, because it is the last element of the list. To avoid that, to kind of freeze the value of the lambda function, of the command key, we are going to create a variable to store the value of base param command. So that will be, let's say, frozen command equals to base param command. And then we can use this value that is fixed, that is frozen, here, so that on the next iteration, this value will not change. So let's see if things work normally now. We add a few strategies. And now the on/off button doesn't trigger any method because we haven't configured it yet. And same for the params button, while the delete button works, so no weird behavior anymore. So just be careful when using the lambda function in Python. The parameter button is used to open the pop-up window that will let us input more parameters. Parameters specific to the strategy chosen in the strategy type option menu. To create the pop-up, we can use the TechInter top-level widget. So we do this in the showPopup method. We call the variable pop-up window. It's going to behave a bit like the root component because it's a new window. So we can, for example, assign a title to it. And a background color. To make sure that the window pops and stay above the root component, we set the topmost attribute to true. So that will be attribute topmost with a dash true. And the grabSet method will make sure that you can click only the pop-up window until it is closed. So let's see with and without this. With the grab method, you can click only there. You can see I cannot select anything else. If we remove this, we can still click on the other TechInter entries. It could mislead the user a bit. What could be nice also is that this window pops up next to the button that we have clicked instead of popping up randomly. We can get the coordinates of the buttons that was clicked. So the X coordinate will be the parameters column, the row that was clicked, and the winfo root X method. Same with the Y. And we place the top level widget next to the button thanks to these coordinates. So using the geometry method, that requires a string, the x plus y coordinates. So that will be using a string formatting. We offset the x position a bit by a few pixels, and same for the y. And we need a plus sign here as well. So you see now the window is next to the button. It works if we add more strategies. Still next to the button. Okay, so in order to create the widgets to input our parameters, we first need to know what strategy is selected. So we need to get the value of the strategy type option menu thanks to its string var widget. So the strategy selected is, so we use still the body widgets that store all the widgets in the strategy component. The strategy type var key and the b index, and we use the get method. However, there could be a problem because, as you can see, currently the option menus don't have a default value. What we can do is to assign a default value when creating the option menu widgets. That will be the first element of the list we provided. So that will be done here. We can set the string variable of each option menu to the first element of the list. So we use the set method, we take the list of values, and we take the first element. So you see, the first element of the strategy list was technical, so it's by default technical. So these boxes, these option menus, will never be empty, because you cannot set it to an empty value. Perfect. So to keep saving lines of code, we are going to create another list of dictionaries to describe the additional parameters depending on the strategy chosen. So we can do this, let's say here, so we call the dictionary extra params. This is a dictionary because we need to separate the technical strategy that will contain a list of parameters, and the breakout strategy as well that contains another list of parameters. Now we can add some example parameters to the list. For example, the parameters required to calculate the MACD indicator for the technical strategy. So that will be, we'll have only entry boxes. So the code name of the first parameter is going to be EMF fast. Then the name, that will be actually the name of the label next to the entry widget. So MACD fast length. The widget is an entry. Data type is an integer, because from a technical indicator point of view, the EMF fast, what I call the EMF fast, is the number of candles required to compute the exponential moving average. And same for the two other parameters. So we have EMA slow and EMA signal. So we'll get more into details about the technical indicators in the next section. And for the breakout strategy, we'll have just one. That will be the minimum volume of the last candle. So min volume. And this is a floating number. We can then loop through the elements of the list in the show pop-up method. So that will be for param in self.extra params, we select the keys associated to the strategy selected, and then we can loop through. So this part is only a dictionary, but this part with the strategy selected is a list. The code name, we access it with the codename key. Then we create a temporary label. We don't need an instance variable for it. tk.label. So placing it on the pop-up window. Then the background color is this one. So we'll do, the foreground color is still white. The text of the label is the param text key. So I called it name actually. And the font is going to be bold. Then we place it on the grid. So the row number we need to reference it, so it will start at 0. We create a variable for this, and we will increment this variable every time we loop through a parameter. So row equals row number. The column, so for the labels, we'll have them on the left column, or the first column, and the values, the entries, the entry widgets will be on the second column. That will be label on column 0, and the entries on column 1. So if the widget is an entry box, so we'll take only this case into account because so far we have only entry boxes. We create an input. So BG color is going to be BG color 2. We center the text in it. Foreground color. The insert background. And we place it on the grid. So still on the same row as the label, but on the second column. And let's see how it looks so far. Okay, so we do have the labels on the first column and the entry widgets on the second one. The only thing we miss is a validation button. And same if we select the other strategy, we have the minimum volume parameter. So let's add a validation button. Actually, it doesn't need to be an instance variable. So the text is simply going to be validate. The background color is the one we have for all the buttons. Foreground color is going to be white. The command, so the method that it will trigger will be called validate parameters, and we'll provide the body index as an argument. So for example, we can define it here. And we will write it completely in another video. So we place the validation button on a grid. So we can still use the row number and the column is going to be the first one, and in order to make it occupy the two columns, we can use the column span parameter, the column span argument. So that will mean the validation button is placed on the first column, but it occupies two columns. So you will see the result that the validation button is actually centered. So you see, we have first column here, the second column here, and the validation button is between the two. So that's it for the creation of this pop-up window. In the next video, we are going to see what happens when we enter values and press the validate button. When you press the validate button of the additional parameters window, what you actually want is to store the values you have input, because the values will be required when you activate the strategy, and you also want to delete the pop-up window. To delete the pop-up window, it's pretty simple. We just use the destroy method. That will be self pop-up window.destroy. But before that, what we need is to again loop through the parameters, get their values, and store these values somewhere. To store the parameters values, we can have a dictionary called additional parameters. So we are going to create it when initializing the class. For example, let's put it here. So that will be private variable. And every time that you add a new strategy, a new row, we will create a key in the dictionary for this new row. So that will be self.additional parameters. We create a key based on the index. That will be a dictionary. So as you can see, the b-index key contains another dictionary, and this other dictionary is going to contain keys that are the parameter code names. We can create these keys dynamically by looping through the extra params dictionary. So that will be strat params in self extra params items, because we loop through the keys and the values of the dictionary. Then we loop through the list of each key. So for param in params, that will be this part loops through this, and the second part loops through each of the list. So the second part is this one. So self additional parameters, the index, and we create a key based on the code name. And by default, we will assign a known value. Then in the validate parameters method, we will just loop through the additional parameters again, based on the strategy selected. So that will be the same thing as here. The code name is going to be taken from the params key. However, from this method, from the validate parameters method, we need to be able to access the entry that we have created here. So currently we only have a temporary variable. What we will need instead is, for example, a self.extra input, and that will be a dictionary, and we will access the key that is the code name. So we need to create an extra input dictionary. And every time that we create an entry box, we are going to reference this entry widget into the extra input dictionary, so that we will be able to access this and this in another method. So let's say code name, we can access the values that we have in the entry widget with cell.extra input. We access the code name, and there will be two cases, whether, so to get the value of the input we use the get method. If the user has input nothing in the entry widget, so if the entry widget is empty, we are simply going to add a value to the parameters dictionary. We'll just assign none to the parameter in the additional parameters dictionary. Otherwise, if it's not empty, we can assign a value to the key in the additional parameters dictionary. So we take this value, and since this will be a string currently, since we take it from an entry box, we can convert it based on the data type that we have described in the dictionary. So this will be either str, string, float, or integer. So just to remind you, this is based on what we have indicated here in the, I called it data instead of data type. Well, actually, data type makes more sense. We will see in another part how to avoid input errors from the user. For example, if the user tries to type a string in the minimum volume field, so if he types ABC instead of 1, 2, 3, 4. So if we type parameters, let's say 1, 2, 3, then we close the window, and if we reopen it, well, the problem is that the parameters don't show. So we need to modify a bit the showPopUp method so that it displays the parameters that were stored in the additional parameters dictionary. So the showPopUp method, and when we create the entry widget, if cell.additional parameters bIndex and the code name, if it's not known, so if we have input a parameter, we can take the entry widget that we have created and insert text in it in the end. So since it will be empty, it doesn't make any difference. So we insert in the end a string, because it has to be a string, it's an entry box. This is why we convert the value that we will add, even if it's an integer or a floating number. So, additional parameter, bIndex, and code name. And I think, yes, I forgot the bIndex here. So now if we type again the parameters, close the window and reopen it, the parameters still show, so everything looks as we wanted. Last part of the series of lectures dedicated to the strategy component. You see that we have used many dictionaries to either store parameter values, store widgets, or store parameters and widgets descriptions. So I hope you're not too lost, because we are almost done with this component. Of course, feel free to add your own notes to the code with some comments next to the variables to remember what they are here for. The strategy editor is going to be able to activate or deactivate a strategy. So at some point, we will need to access the two connectors from this component. Let's pass these two connectors as arguments when initializing the class. So Binance and BitMEX. We will provide the type of these variables by importing the two connectors. And we pass them in the root component. So this is first Binance and then BitMEX. We can store them in a simple dictionary that we name exchanges, because it will be easier to dynamically use them when something applies to both connectors. So that will save some lines of code. The first reason why we need the connectors is to have a list of symbols in our option menu. So let's populate the all contracts list. So first we loop through this dictionary. So for exchange, the key, and client, because this is a client. Then we loop through each contract. So symbol is the key. Then we have a contract object of the client contracts variable. Here we can populate the all symbols, all contracts list by appending the symbol plus underscore the exchange. We also add the exchange because the contracts of both exchanges will be in the same list, so it will help to distinguish which contract is for which exchange. Now, if I add a new strategy, you can see we have access to the full list of contracts, and the ones of BitMEX are in the end. Getting to the last method to write, the switch strategy one. There will be two parts, one to activate or deactivate the strategy, and one to check that when we tried to activate the strategy, we didn't forget any parameter among the mandatory ones. So we first check the three parameters that are common to the two strategies. So we're going to loop through the for param in balance percentage, take profit, and stop loss. If the body widget, so we use the body widget dictionary, we access the column we want and the row that we want. So this will be an entry widget. We use a get method. If it's empty, it means that the user didn't input anything in it. So we are going to return from the function. But it would be nice if we could tell the user why it doesn't go further by displaying a log message in the interface. For this, we can simply pass the root component as an argument to this class. So that will be root. and we create an instance variable for it. And then we will be able to access the logging frame and thus the addLog function. And it's not a problem because this thread, the one of the strategy editor, is in the same thread as the root component one. So it's not a problem like it was when adding a log from the connectors. So actually, if we want it to be displayed, if we want logging frame to be available from another component, we need it to be public. So we remove this. And we can access the root component, the logging frame, and the addLog function. And the log message is going to be using a string formatting, missing the name of the parameter, and parameter. And just before testing it, we need to pass the root component here, so self, okay, we add a strategy. If we try to activate it, you see we didn't indicate the balance parameter, so we indicate it. Okay, we still miss another parameter, the take profit one. So let's say 20, stop loss 10. Now we try to activate it again. Okay, we can go further. The next check is to see if the specific parameters of the chosen strategy are all set by the user. So we are first going to get, as usual, the strategy selected. We can copy this part. Then we loop through the additional parameters. So for param in self.extra params, so we loop through the description of these parameters to get only the parameters that are specific to this strategy. So we get this key. So to remember, we get this dictionary, this key, and then we loop through these elements, for example, or through the other element. So if self.additional parameters, parameters that we have recorded in a variable, bIndex param codename, if this value is none, so if we haven't set any parameter for it, we're going to log a message. So root.logging frame, addLog, a string format, missing param codename, parameter. That's it. And we return, we don't go further. Then once we know that all the parameters are here, we can parse them and store them in variables. For example, the symbol, we get the body widgets, the strategy, the column that is for the contract, that is to say the contract variable for the option menu. We get, so first we need to have the body indexed. We use the get method. Then to get only, let's have a look, the symbol, we need to split this, for example, thanks to the order score, and take the first part, and the second part will be the exchange. So split, and we take the first part. For the exchange, we'll just take the second part. And for the time frame, we use the time frame variable. No need to split it. And then it's quite similar for the balance parameter, the take profit, and the stop loss. And we can convert these three to floating numbers. At this point, there will be two cases. If the button is currently off, it means that we clicked to activate the strategy. So if self.body index, body widgets, so activation, we select the column of the button, then the B index for the row, use the cget method to get the text of the button. So if it's off, it means that we are going to activate the strategy, otherwise we will deactivate it. There will be a few things to code when activating the strategy, but this is related to some content that we are going to discuss in the next section. However, what we can already code is that when we activate a strategy, the option menu, entry widgets, and other buttons will be deactivated to prevent the user to change their value while the strategy is already running. To do this, we again loop through the base params. We can reference the code name. And if the code name is not the activation button, because we don't want this one, it's the only one we don't want to deactivate, because we need to be able to click on it to stop the strategy. And also if there is no var string in the code name, because remember, in the base params list, we'll also have an additional entry that is a strategy type var. And we don't need to deactivate this because it's not a button, it's not an entry box, it's invisible. So no need for this. So and var not in the code name. Then we can deactivate this widget. So body widgets, code name. So code name simply the body index. We use a config method and the state is going to be disabled. We'll see how it looks when it's disabled. And we can also change the value and the color of the button we've just clicked. So that will be the activation button. We configure the background color to be dark green, the text to be on, and we can also log a message just to inform the user that the strategy was successfully activated. And we do simply the reverse when deactivating it. So that would be normal to reactivate the buttons, to reactivate the entry widgets. The text is going to be off again and dark red. And yes, it's var not in code name. So let's see how it looks. we had a strategy, let's say 15 minutes. If we try to activate it, it doesn't work. So balance 2%, take profit 10%, stop loss 20, the parameters. So if we try to activate it like this, it will require to input some parameters. Let's say 5, 9, 4, we validate. And now it works. And you see, we cannot click this entry widget anymore. We cannot change the contract. So it's perfect. It's safe. If we deactivate it, it still works and we can change the parameters again and reactivate it. So that's it for the strategy component and for the interface as well. In the next section, we will tackle the trading part, the actual strategies, and sometimes we will get back to the interface to add a few things to it. Well, first, congratulations that you have reached this section, because we have gone through many difficult things in this course so far. We have a bit more than 1000 lines of code currently, which might seem a lot if you are a beginner in Python, but actually it's not that much considering all the things that the program does. Realize that we have connected to 2 big crypto exchanges, and we have designed an interface. But the most important point is that it doesn't really feel like 1200 lines of code. It doesn't feel that heavy, and the reason for that is that we really focused on the code organization. We know what each Python module does, and it's not too hard to get back on a module and modify it, because the longest modules are roughly 200 lines of code. The reason why I'm talking about all this is to emphasize the importance of creating your application using classes in a modular way. When you start to learn programming, you learn about classes, but it's often very abstract and you don't necessarily see why they are so useful. So I hope that what we have done so far will convince you about the usefulness of classes, because we will continue adding more classes in the strategy module. As you know, we are going to code 2 strategies, one that relies on technical indicators and one that is based on entering a trade when a certain price level is broken by the current price. So when you click on the on-off button of the strategy component, we need to create a strategy object based on a strategy class that will have attributes and make it unique, like the contract that is traded, the time frame, the take profit percentage, the stop loss percentage, and the balance percentage. The attributes that I have mentioned will be common to the 2 strategies, but each strategy will have its particularities. The most obvious one is that the conditions to enter a trade will be different. To handle that, we could have a lot of if-else statements in the strategy class. If class is technical, then, else if class is breakout, then, etc. But there is a more elegant way to do it, and we have already seen an example of it. We can have one class, a strategy class, that will contain attributes and methods that are common to the 2 strategies, and we can have 2 more strategy classes with specific methods and attributes. For example, the technical strategy class will have a method to compute the technical indicators, but these 2 classes will inherit from the parent strategy class. So the 2 child classes will benefit from the methods of the parent class. Let's code these 3 classes so that you will really understand the power of this kind of structure. So I'm first creating the module dedicated to the strategies. As usual, we are going to need the logging library. So about the first class, the parent class, it will be named simply strategy and will be initialized with the common parameters for the 2 strategies, like the contract, So we'll need to import the models. The time frame, that will be a string as usual. The exchange, let's have it before. The balance percentage, floating number. The take profit percentage, floating number as well. And finally, the stop loss percentage. So we create instance variables for each of these attributes. Okay, so we know that any strategy will have these attributes. About the child classes, there will be the technical strategy that inherit from the strategy 1. And we are going to initialize it with the same parameters plus an additional one that will contain the other parameters of the strategy specific to the technical strategy. For example, the EMFast, what we called the EMFast in the previous section. And that will be a dictionary. We initialize the parent class with the super init method. So we need the contract, the exchange, the time frame, the balance percentage, the take profit percentage, and the stop loss. So this technical strategy class will have 3 specific attributes for the moment. We will add more a bit later. EMFast, it comes from other params, and we take the EMFast key. And same for the 2 others. So EMS slow and EMA signal. So these can be private variables. And we do pretty much the same for the breakout strategy. So we only change the name and the attributes. For the moment we just have one, that is the minimum volume. So you see, from this strategy you still have access to the contract object. That is an attribute of the strategy parent class. So most of the code will be in the strategy parent class because many methods are common to the 2 strategies. And the technical strategy, for example, we'll have a method named compute MACD, for example. We need to initialize these 2 strategies depending on the strategy that we activate from the strategy component. That means if the strategy selected is technical, we are going to create a new strategy object equals to, so I need to import the classes from the strategy module. Here we initialize a technical strategy object. We need the contract, so we can create it here based on the symbol. Then we pass the exchange, the time frame, balance percentage, take profit and stop loss. We also need the dictionary that contains the parameters specific to the technical strategy. So this is the cell.additional parameters dictionary, and we select the key that is the B index. Almost the same for the breakout one. And otherwise, we'll just continue. And let's test a bit, just to be sure that there is no error. So if we activate the technical strategy, for example, we can print like activated strategy for, and the contract name, the contract symbol. Okay, new strategy, balance percentage 1, take profit 20, stop loss 20. And yes, that works. Activated strategy for Bitcoin USDT. So from that point, we'll be able to build more methods to the strategy class, to strategy parent class. The two strategies will need candles data to be able to calculate whether to enter a trade or not. Since we want to be able to trade immediately after the strategy has been activated, what we can do is to get historical data right after creating the strategy object. Just before doing this, we need to have a variable in the strategy class to store the candles, a list. So removing this and creating a variable to store the candles. We can also specify that this variable expects only a list of candles objects. That will be typing at list candle. So actually I will import everything from the typing module to save some space in the code. Now getting the historical data when initializing the strategy. Selecting the candles object, the candle list. I select the client, so Binance client or BitMEX client. And I use the getHistoricalCandles method. I will pass the contract object and the time frame. Then if the list that we got is still empty, so if the length of the list is 0, it means that there was an error during the request. So we won't go further and we will inform the user about this. So displaying a log. No historical data retrieved for, and then the contract, so using a string formatting, and the contract symbol. Once the strategy object has been created and historical candles have been fetched, we need to store this new strategy object somewhere where it's going to be easily accessible. Since trades will be triggered by new price data coming in through the WebSocket channels, it would make sense to store these strategies in a variable in each connector. So when a strategy is created to trade a contract on Binance Futures, we will add it to the Binance Futures connectors. And the same applies with the BitMEX connector. So we will simply have a dictionary variable in each connector that will be initialized here, let's say here, that we name simply strategies. The type is going to be a dictionary with the key being the body index, so an integer, and the values will be either a technical strategy or a breakout strategy. So that will be typing union so that we can indicate two possible values. Technical, we need to import it. Technical or breakout strategy. So getting back to the strategy component, if the get historical candles method was successful, we will use the client, the strategies variable that we have just created. We use the body index as a key, so we create a new key. The value is the strategy object that we have created here or here. Also, if we switch the strategy off, that will be, we simply delete the key from the dictionary. So exchange, we select the client, we select the variable and the key. Okay, so we got the strategy objects with some historical data. But the problem is that the historical data is not updated. And obviously we are not going to request historical data every time we want to check a signal, because that will be too heavy. What we can do is to use the WebSocket feed to keep building the candlesticks using live data. When you see a candlestick on a chart, it is based on trade data. So every time a trade occurs, it can change the high or low of a candle. First, let's add the trades data to our BitMEX and Binance subscriptions. So for BitMEX, that will be in the onOpen method. So subscribe channel, and the channel for the trades is simply called trade. To parse it, it's quite simple, very similar to what we had with the instrument channel. So if the table is trade, we loop through the data key. The symbol is represented by the symbol key. And that would be good to also parse the timestamp, so that we can have a Unix timestamp in milliseconds. So timestamp is going to be, so this is the timestamp key. You can find this in the documentation. And the timestamp key is actually in ISO 8601 format. So we have already seen that in the connectors part. To parse this, we have the Python date2till library. So we can import it here again. And use the isoparse method. This creates a datetime object that we can convert to Unix timestamp with the timestamp method. The timestamp method returns a timestamp in seconds. We need to have milliseconds and convert this to an integer. On the Binance side, we need to subscribe to the AdTrade channel. And the message format is going to be similar to what we had with the bookticker channel. So if the event is ActTrade, the symbol is going to be data S. And in the next video, we will implement the method that lets us update the candlesticks thanks to the trades WebSocket updates. Now that we have parsed the trade coming in from the WebSocket, we need to know whether this trade will have an influence on the current candle, like if it's, for example, the new high of the candle, or maybe this trade is the first trade of a new candle, so that will be the candle open price. To know that, we are going to create a method in the strategy class that updates the candles list thanks to the new trade data. Just before this, I'm adding the strategies variable in the BitMEX module as well, because I hadn't done that in the previous video. So, the strategy module, we are creating a method to parse the trade, to parse the information of the trade to update or not the current candle. So we said the price, the size of the trade, and the timestamp in milliseconds. What's going to happen in the connectors is that we are going to loop through the strategies every time that we get a new trade data. So that will be in the onMessage function. When we get a trade data, we loop through the strategies for key strat in self.strategies. So this is a dictionary. If the current strategy contract, so we take the symbol, is the same as the symbol of the update, we are going to use the parse method, the parse candle method of the strategies module. So we call the function that is public. We pass the price represented by the P key of the data object, of the data dictionary, converted to a floating number. We pass the size as well. So this is represented by the Q key. And the timestamp represented by the capitalized T key. We do the same on BitMEX. So just before, yes, we need to add the strategy models, the strategy classes. And we go to the onMessage method. So same thing, if the contract symbol of the strategy is equal to the symbol that we have the update for, we will pass so the timestamp that we have passed in the previous video and the D object that has a price key and a size key. So there can be three cases in the parse trade method. First, the trade updates the current candle. Then, second case, the trade is the first trade of a new candle. And the last possibility is that this trade is the first trade of a new candle, but some candles are missing between the last one we had recorded and the new candle. It can happen with contracts that don't have a lot of volume. Sometimes there is no trade during a few minutes. To know which of these three cases must be used, we are simply going to compare the timestamp of the new trade with the timestamp of the most recent candle that we have recorded. But for this, we need to know the length of one candle in milliseconds, depending on the strategy time frame. So we are going to create a global dictionary variable named tf_equiv, like time frame equivalent. That will be the time frame equivalent in seconds. For example, 1 minute will be 60 seconds. So we have 1 minute, 5, so 300 seconds, 15 minutes, 30, 1 hour, and 4 hours. When we initialize a strategy, we can create a variable for the time frame equivalent in milliseconds. So that will be tf_equiv equals to tf_equiv. We select the dictionary, the time frame key, and we convert this to milliseconds. So let's take a simplified example. Let's assume the timestamps are in seconds. The last candle timestamp that we have recorded is 100. the time frame equivalent in seconds is 10. So one candle is 10 seconds. If we receive a trade update through the WebSocket and its timestamp in seconds is 108, we know it belongs to the current candle because its timestamp, 108, is less than 100 plus 10. So in terms of code, it can be written like same candle, so just to remember what we are doing. So let's also have a variable for the last candle because we are going to use it very often. So if the timestamp of the trade is less than the last candle timestamp plus the time frame equivalent, it means that we are on the same candle. Then second case, we have a new candle. So this will happen, for example, if we have a timestamp of 112. That means that we have a new candle because 112 is more than 100 plus 10. So else if timestamp is more or equal than the last candle timestamp plus the time frame equivalent in milliseconds. But if the trade timestamp is 132, it means that we have a new candle, but we missed two candles because there was no volume. So no trade during these candles. So we still need to add them to our candles list, and this needs to be checked before the simple new candle case. So let's call it missing candles. So if the timestamp is more or equal than the last candle timestamp plus at least twice the equivalent time frame, so 2 candles, it means we are missing a few candles, at least one. Okay, now we have identified the 3 possible cases. Let's code what happens in each of them. If we are on the same candle, the first consequence of a new trade is that the trade price will now be the close price or the last price of the candle until a new one comes or until the end of the candle. So that will be last candle close price equals to the new price that we got from the WebSocket. We can also add the trade size to the current candle volume. So that will be last candle.volume, and we add the size. Then the trade price can potentially be the new high or the new low of the candle. So if price is more than last candle high, the new last candle high is the price. Else if the price is less than the last candle low, we have a new low, so we update the object. Now about the case where we have a new candle. We need to create a new candle object and add it to our candles list. Calculating this new candle timestamp is easy. We just take the last candle timestamp and add the time frame equivalent in milliseconds. So new timestamp equals to last candle timestamp plus the time frame equivalent. If we have a quick look at our candles model, currently it takes into account the case where the data comes from Binance or BitMEX. We will need another case for when the candle comes from the post-trade method. So let's say else if exchange, even though it's not an exchange, is post-trade, and the candle information will simply be a dictionary. So we can create a candle info dictionary. and the open, high, low, and close prices will all be equal to the new trade price that we have just received. And the volume is equal to the size of this first trade, of the candle. So we pass this to a new candle object. We pass the time frame and pass trade as an exchange equivalent, let's say. And we append this new candle to the list that we have. Okay, here we need, yes, a typing module. We can actually even add a log message to the terminal to check that the update is working. So let's say logger.info, new candle for, we'll have the symbol and the time frame. We can even add the exchange. Okay, the last case will be a bit similar to the previous one, where we simply add a new candle, because we still have this part. But just before that, we also need to calculate how many candles were missed before this new one. So the number of missing candles is going to be missing candles equals to the difference between the timestamp, the new trade timestamp, and the last candle timestamp, based on compared to the time frame equivalent. We then convert this to an integer and -1. You will see it works. If we have in our previous example 132 as the new timestamp, and the previous one was 100, so we have 132 minus 100, so this is 32, divided by 10, the time frame equivalent of our example, so this is 3.2, converted to an integer, this is 3, minus 1, this is 2. So we do have 2 missing candles. We will log this. So the exchange still. Missing, so the number of missing candles. Candles for the symbol and the time frame. We can even log the current timestamp and the last ones that we had recorded. So that will be timestamp and last candle timestamp. Then we are going to add the number of missing candles that we found to the candles list. So for missing in the range, so the number of missing candles, we create a new timestamp, that is the last candle timestamp plus the timestamp equivalent, then a candle info dictionary. The price is going to be the same as the last candle close price for the open, high, low, close price. The volume is 0. We create the new candle and we add it to the self.candles variable. Then we also need to replace every time the last candle by the one we've just created, so that when it creates the new timestamp, it will take the last one. So we have our three cases, and what we can do already is to return something from the function, from the method, because we are going to need that after calling this method from the connectors, was this method adding a new candle or updating a previous candle, an existing candle. Because in the next video, we will actually compute the indicators only when a new candle is created, because we are not going to compute constantly at every trade the indicators. So here we return, let's return simply a string, so same candle, so the function returns a string. Here it returns new candle, and here as well. Now that we have candlesticks data that updates thanks to the WebSocket data, we can create a method that will check the signal, that is to say, indicate whether we should enter a long or short trade or do nothing. This method will have the same name for both strategies, but the logic in it will be different. So we can create it in the child classes, technical strategy and breakout strategy. I'm calling it check signal. It returns an integer because for a long signal we will return 1, for a short signal -1, and if there is no signal we will return 0. I'm going to start with the breakout strategy because it only needs the candles and no need to compute an indicator. We will say that we have a long signal if the current candle close price, so the current price, is more than the previous candle high price. So we return 1. The short signal will be similarly if the close price is below the low price of the previous candle. So we return -1. Otherwise, we just return 0. In both cases, we want an additional condition. The current candle volume must be more than the minimum volume parameters that we have input. This kind of logic can be useful if you want to implement strategies based on candle patterns. For example, the inside bar pattern or the outside bar pattern, where you have what's called the mother bar and the next bar is within the limits or outside of the limits of the mother bar. For example, here is how to code the inside bar pattern. So if the previous candle high is lower than the candle before high, and the previous candle low is higher than the candle before low. So we have an inside bar pattern, and if the current candle close goes above the mother candle high, then we have an upside breakout. So just commenting this out to remove the highlight here. Otherwise, if we have the candle, so the current price that goes lower than the mother bar low, we have a downside breakout. There are dozens of patterns that you can code simply by using the candle open, high, low, and close price. So feel free to apply your own patterns using this kind of logic. You can, for example, code a pattern that will recognize the swings for day trading, or find the support and resistances of the day, or even calculate the Fibonacci retracements. So, removing this. In the next video, we will see how to calculate the indicators for the technical strategy. On the technical strategy side, things will be a bit more complicated because I want to show you how you can use the candlesticks to calculate indicators. There will be two indicators, so two more methods, the MACD and the RSI, Relative Strength Index. So, RSI and MACD. There are 4 steps to calculate the MACD, the moving average, convergence, divergence. Calculate the fast exponential moving average, fast EMA, then calculate a slow exponential moving average, so the slow EMA will be using more candles than the fast one. This is why it's slow, because its slope will change more slowly. Then you subtract the slow EMA from the fast EMA, and finally you take the result from the previous step and you calculate the exponential moving average of it. After each step, what you want is not just one figure. You want to have a list of exponential moving averages, each EMA corresponding to each candlesticks that you have recorded. So the EMA of the current candle, but also the previous candle, the one before, etc. So we already have the candles. The only thing we miss is the function to compute the exponential moving average based on the close price of each candle. What we will provide as an argument to this function is the list of close prices of our candles. So let's have a list of close prices for candle in sell.candles. We append only the close price of the candle. Then we are going to use the Panda library that we have already installed in the first section of the course. Just to remind you, Panda is a Python library that is useful to work with data frames or time series, because candles can be represented as time series. Each row is a new timestamp and the columns represent the open, high, low and close price. So I need to reinstall Panda, pip install Panda. Then I import it. First, let's convert the list of close prices to a Panda series object. So that will be closes equals to Panda. We take the series object, the series class, we create an object from the list of close prices. Then calculating the EMA of a series is fairly simple, using the EWM method first, and then the mean method. It will calculate iteratively the EMA of each candle based on the EMA fast previous candles. So the span argument is the period chosen, the one you have input in the strategy parameters. We can do the same with the EMA slow. So these were the first 2 steps. Then the first step is very easy to do with Panda, is to subtract one series from the other. And that will give us the MACD line. The MACD indicator is based on the close price. We are not going to calculate it on every new trade. Instead, we are going to calculate it when there is a new candle. So we will be interested in the MACD of the last finished candles. And finally, last step, we create a MACD signal variable that is the moving average of the MACD line. So the signal will depend on whether the MACD line is above or below the MACD signal line. So there will be a long signal when the MACD line goes above the signal line. So we need to return two elements from this method using a tuple. We return the MACD line of the previous candle and the MACD signal of the previous candle. So -2 and not -1, because -1 represents the new candle, not the one that was just finished. Then we can say it returns a tuple of floating numbers, and creating the check signal method, we have a variable for MACD line and a one for MACD signal when we call the MACD method. Regarding the RSI, we are still going to use the close prices and the Panda series object, so we can copy this part. And we need an additional parameter in the strategy component, that will be the RSI periods. That is to say, the number of candles used to calculate the RSI. So let's create a variable here first. So getting back to the strategy component, we have the extra parameters. For the technical strategy, we add one that will be the RSI length, the RSI period. The RSI formula is the following. What we need to calculate is the average gain and the average loss over the period. To get a Panda series representing the variations, the gains and the losses, between each close price, we can use the diff method. So we create a variable called delta that will be a series based on the close prices series and the diff method. We also apply the drop NA method in the end because we need to remove the first value of the list after the diff method has been applied, because the variations can be calculated only once you have at least two values, of course. So for the first line of the series, there won't be any value. Then we are going to separate the upside variations from the downside ones. So let's create two copies of the delta Panda series. From the up one, we filter the rows that are under 0, so the losses, so that we can keep only the gains. So we set the losses to 0. We do the same with the down. We select the values that are more than 0 and we set them to 0. So that when we do the average gains of the up side, it will take only the values, only the close that has increased compared to the close price before. So only positive numbers in the up series and only negative numbers, or 0 of course, in the down series. Then we use an exponential moving average on the 2 panda series to calculate the average gains. And same with the average loss. There are several ways to calculate the EMA. This is why we have the COM, center of mass argument, instead of the span argument that we had before. I won't go into details about this in the lecture because it has more to do with some mathematics, and explaining the calculation details of each technical indicator is not the main goal of this course. But that way we get a RSI that corresponds well to the one that you can find, for example, on the TradingView charts. Then we apply the final formula. And we can round it to 2 decimals. Then, like the MACD, we return only the candle before the current one. So we select this with the iLock method. Okay, and we call the method in the check signal method. So RSI equals to sell.RSI. Now we have the 2 indicators data available. So we will say that we have a long signal if the RSI, if the contract is oversold, so if the RSI is below 30, and if the MACD line is above the MACD signal line. Otherwise, if the RSI is above 70, so the contract is overbought, and the MACD line is below the MACD signal, we return -1, so indicating a short. Otherwise, we return 0. And this must be EWM, not EWN. We need to call the iLock method to select the row before the most recent one. And let's have a look at the RSI. Yes, we need the absolute method to convert the down variations to a positive number for the calculation. So that's it. Let's have a look. By testing, we will print the RSI, the MACD line, and the MACD signal. We can call this function, this method here, when initializing the strategy. So new strategy on 15 minutes. RSI 14, it's a common setup. 12 for the MACD fast. 26 for the slow. And 9 for the signal line. So 51.15 for the RSI, yes, exactly. And 93.22, right, and the last one was, yes, minus 4.6, so this is exactly it. Perfect. Since we are now able to calculate whether we have a long or short signal for each strategy, the question is how and when are we going to call the check signal methods? Well, the when question depends on you. Do you want to call it every time we have a live price update? Is it useful to do so? Or do you want to call it only once per candle? This is really up to you, and there can be many answers to this question. You could even think of calling the check signal method only at some specific times of the day, if, for example, you have noticed that the MACD of 8 AM is a good indicator for the rest of the daily trend. In this course, we can already answer the how question. How do we call these methods? We want to call these methods when there is a long or short signal and there is no ongoing trade. Because once we enter the position, it will be closed when a stop loss or a take profit has been reached, which might take some time. This condition is not part of the signal itself, so let's have a public method that we can call from the WebSocket onMessage method. I'm calling it check trade. And the tick type argument is the one we have discussed in the previous lecture. So that will be also in the breakout strategy. And we will call that from the two connectors. So the result of the past trades method is whether the trade updates the current candle or creates a new one. And we can call the check trades method from here. We do the same on BitMEX. For the technical strategy, we will compute the indicators and check for a new trade only when there is a new candle. So if tick type equals new candle. Then we compute the signal result. And we will call the method that actually opens the position only if the signal result is -1 or 1. This method will be the same for the two strategies. It will be called open position. I'm also creating a variable at the parent level, at the parent strategy level, to know whether we are already in a position or not. So by default it will be false. And we want to trade only if we are not already in a position. So if we have a new candle and sell.openPosition is false. On the breakout strategy side, there won't be the new candle restriction. So only if not sell.openPosition. And one important point, be careful if you are calling the check signal method at every trade. Because if the calculations in it are too heavy, and there are many trade updates coming through the WebSocket, the updates might start to be delayed. To make sure we monitor this, let's calculate the difference between the current Unix timestamp and the timestamp of the trade when we pass this trade. So we take the current Unix timestamp multiplied by 1000 to get milliseconds. We convert it to an integer and we compare it to the timestamp of the trade. Then if this difference is more than 2 seconds, so 2000 milliseconds, you can adjust the value as you wish. We will log a message to warn the user about this. So if you see a log message like this printing too often, it means that there is probably something wrong in the check signal method that slows down the WebSocket updates. To go further in our signal processing, we can now code the open position method. We already have almost all the information to send a buy or sell order. We know the signal side thanks to the argument that is passed to this method, and we are going to place a market order, so no bid-ask price required at this stage. If in your program you need the bid-ask price though, you can create an argument in the check trade method, and for example, bid float, and pass the bid-ask to it in the, for example, BitMEX check trade method, like this. And then you would pass the bid or ask price to the open position method. The only element that we miss is the trade size, that is based on a percentage of the account balance. Since the trade size is calculated differently on Binance and BitMEX, due to the nature of each futures contract on these platforms, we are going to create a method in each connector that we will call getTradeSize. The easiest calculation is on Binance, so we will start with this. We will need the contract, the price as a floating number, the balance percentage parameter. We need the contract to be able to round the quantity to the right lot size. First, we need to make sure that the balance is updated and that we have a USDT key in the balance dictionary that we obtained. So we call the getBalance method. We make sure that the request was successful, otherwise we'll return none. Then we check that there is a USDT key in the balance because this is a margin asset that we will trade. If yes, we replace the balance that we got here by the value of the USDT wallet balance. Otherwise, if there is no USDT key for some reason in the balance, we return none. So if everything went fine, that means we got the USDT wallet balance, we can calculate the trade size with balance times a percentage of the balance So this gives us the USDT amount to invest, and to know the quantity that we can buy with a USDT amount to invest, we divide it by the price. Then we will round this trade size to the right lot size, like we did previously in the connector section. And we round it just in case we got extra decimals unwanted. We can even log the quantities that we got, because it's an important information. However, to be able to call this method from the strategy class, we need to have the connector available in this class. So we are going to pass the connector object, the Binance or BitMEX client, when initializing the strategy. So getting back to the strategy interface component, when initializing the strategies, we will pass the client. And we add it to the class initialization. Now we can call this method from the strategy class. So that will be client and get trade size. We pass the contract, the current price, and the balance percentage parameter. If the trade size is known, it means something went wrong, so we'll just return. On BitMEX, calculating the trade size, the number of contracts to trade, is a bit more complicated. So we still have the getTradeSize method. The first part doesn't change much, so we can copy it from Binance Futures. We just have XBT instead of USDT. Because the balance on BitMEX is in Bitcoin. And the XBT size, the Bitcoin size to invest, is going to be the balance times a percentage of it. But once we have the XBT amount of the order we want to place, we need to convert it to a number of contracts to buy or sell. This calculation will depend on the type of contract. To know about the type of contract, we need to add more attributes to the contract data model for BitMEX. We need to know whether the contract is a Quanto contract and whether it's an inverse contract. So we get it with the isQuanto key of the contract info dictionary. And for the inverse, self.inverse, almost the same, is inverse. We also need the multiplier, that is the contract value, and it's in Satoshis. So multiplier and we multiply it by the BitMEX multiplier, so don't mix it. The BitMEX multiplier is just to convert from Satoshis to Bitcoin. If you print the multiplier, you will see that for inverse contracts, the multiplier is negative. So we can convert it to a positive number, because otherwise, when we use the multiplier to get the number of contracts to trade, it will return a negative value. So if we have an inverse contract, we will multiply the multiplier by -1 to make it positive. Okay, so now that we have more information about the BitMEX contracts, we can calculate the number of contracts to buy or sell. The number of contracts to trade is the XBT amount that you are ready to invest divided by the XBT value of one contract. So we need to find what is the value of one contract depending on the type of contract, inverse, quanto, etc. So this can be found in the BitMEX documentation about futures contract specifications. For inverse contracts, both perpetual and non-perpetual contracts, the XBT value of one contract is 1 divided by the price of the contract times $1, so times the multiplier, which can be rewritten as multiplier divided by price. So if the contract is an inverse contract, the number of contracts to trade is going to be the XBT size you are ready to invest divided by the value of one contract in XBT. So we said this is contract multiplier divided by price. Otherwise, if we have a quanto, the XBT value of one contract is multiplier times price for both perpetual and non-perpetual contracts. So we have contracts number equals to XBT size divided by the value of one contract in XBT. We said contract multiplier times price. Otherwise, if it's not an inverse contract and not a quanto contract, we are in the case of a linear future, and the calculation is the same as for the quanto. So we return an integer, well, actually it can be none, so we won't indicate the type of the returned value because of this. If the differences between the type of contracts on BitMEX are a bit confusing for you, I suggest that you check their contract guides page. It is very well written, short, and great to understand everything. So don't forget to output in a log the amount that we have found. BitMEX current XBT balance equals, and the contracts number equals and in the next lecture we will have everything needed to place the order. Just before calling the placeholder method, let's make sure that the arguments are the same in the same order for the two connectors. For example, BitMEX, we have contract order type quantity side, and on Binance contract side first. So let's put the order type first here, and the side will be the fourth argument. Another point, currently we didn't hint the type of the client variable, and because of this you cannot see the method of this object. So you can still use them, you can use the placeholder method, but it won't help you finding the arguments. So you could make an error while coding. To handle this, usually we import the connector. So we do from connectors BitMEX import BitMEX client, for example, and we type the client here. But if you start the program, it triggers an error. Why? Because we have what is called a circular import. So you import the connector here, but the connector itself imports the strategy module here. So there is a solution for this. We are going to use a variable from the typing module that is called type checking, if type checking, which will be false when the program runs, but still, if you do from connectors.bitmex import bitmex client, you can still have access to the bitmex client here, but it won't actually execute this line because this variable will be false. But you can still use this to hint the type of variables. The only restrictions is to put this as a string. So if we have union, because we can have two possible clients, bitmex client, and we will have from connectors, Binance Futures, we can indicate that the client variable will be either of the bitmex client type or Binance Futures client type. And you see now you can call all the methods from the two connectors. So getting back to the open position method, we can log that a signal has been triggered, but remember that we are currently in the WebSocket thread, so we are not going to log the message directly using the logging frame component. We are going to have a list of logs, and the update UI method of the root component is going to pick these log messages and put them to the logging frame. So that will be a list of logs, and we can have a method to add an element to the list. So a string as an argument, the message. We log the information to the terminal still. And we append a dictionary with the log message and whether it has been displayed to the interface yet or not. We can create variables to indicate the trade side and the order side. So order side equals buy if the signal result is 1, otherwise sell. On Binance Futures, I think, yes, it would be good to make sure that we pass the side as an uppercase string. For the position side, we'll have long if the signal result equals 1, else short. That will be used for logging. So we add a log. So long or short signal on the contract, the symbol, and let's say the time frame. Now we can place the market order. So order status equals to client.place order, the contract. Then we know exactly which arguments to type because we have hinted the type of the client. So that will be order type market, quantity the trade size, and the side will be the order side we have defined here. When you call the open position method, since it's getting the trade size and calling the getBalance method and placing the order, so we have two REST API calls, there might be a small delay, so the message that we have defined here might appear. So if the order status is not known, the request was successful, so the order is placed. We add another log. Order placed on and the exchange. We can log the status of the order. We can turn, so let's call instead of, we currently have an open position variable, but it's the same name as the method to open the position, so it's not ideal. Let's have rather ongoing position, and we will modify it here, ongoing position, and ongoing position again. We will turn this variable to true when the order is placed. It's very important, otherwise the program will keep trying to place an order. When we place a market order, there are two possibilities. The first case is that the order is immediately executed. So that will be order status equals field. On Binance and BitMEX, it returns the word field to indicate whether the order was filled or not, but some exchanges might return another word, for example the word executed. So pay attention to this if you try to integrate more exchanges to your program. And in that case we can get the average execution price, the average field price. Otherwise, maybe the order needs 1 or 2 seconds or a bit more to be executed, especially if the order size is big for the market. So in that case, we don't get immediately the field price, the execution price, and we need to check the order status regularly. So we will call a function, the getOrderStatus, every 2 seconds, for example, until we get an order status of field and until we can get the execution price. So for this, we're going to use the timer object of the threading library. We import it. That allows to call a function with a delay without blocking this one. So it works a bit like a thread. So timer, in 2 seconds we call, so lambda, and we'll call the method check order status and passing the order ID. Then we start the timer and the function can continue. In both cases, we are going to record this trade to a list. So we'll have a new trade equals to. So let's create a data model for the trade. That will be, we add the order status and we will have a class named trade. So that will be easier to access the information about the trade rather than having a dictionary. So we will pass as argument a trade info variable that is a dictionary. The variables will be, so the entry time, that will be an integer, a milliseconds. Then I'm going to copy this field just to go faster. We will need the contract, so this is a contract object. The strategy traded. The side, so long or short. The entry price. So the side is a string, the strategy as well. The entry price is a floating number. The status is a string, so that will be open or closed. The P&L will be 0 at the beginning, but still a floating number. So the quantity, the trade size. So it can be either a floating number or an integer, so I'm not going to type it. And finally, the entry ID, the order ID that we used to open the position. So same, it can be a string or an integer depending on whether we are on Binance or BitMEX. So new trade will be a trade object. We pass a dictionary, so the time is the current time, a Unix timestamp in milliseconds. Then we have the entry price. So maybe we don't have it yet, so let's create a variable, a default variable for it. The contract, we have it in the class, so file.contract. The strategy, we can add it to the class when initializing it. So that will be strat name. We can have it here. and we will pass it when initializing the strategy object. So here we have breakout, and here we have technical. So strat name, then the side, position side, the status, so we'll say it's open at the beginning. The PNL is 0 for the moment. The quantity is trade size, and the entry ID is the order ID. We get it with the order status object. Then we are going to add this object to a list. So we create it here, for example. Trades is a list of trade objects. So really always think how you can make your life easier when coding by adding data models like the one we have just added, the trade model. The whole program will feel cleaner with data models than with simple dictionaries, with keys that you will anyway forget. So the last method to code is check order status. Check order status, we can have it above this one. We pass the order ID, and we are going to call the getOrderStatus method. If the request is successful, then we can even log the status of the order. So the exchange and the status of the order status, and the status attribute. If the order status attribute is filled, we're going to loop through the trades, the ones we have recorded, because it's maybe not the first one that we have placed. So for trade in sell.trades, if the trade ID, so entry ID, is the same as the order ID we are getting the data for, then we know that we have found the one we wanted. So we break the loop, and we set the trade entry price to the order status average price. And we can return from the function, because otherwise we are going to call the check order status again in 2 seconds thanks to the timer object. So it's a bit like an infinite loop every 2 seconds until the order status is filled. And same thing here. Yes, I'm not sure that we have the arguments in the same order. So we have contract and order ID, and here order ID and contract. So let's have it like this. And we missed the contract argument. Sell.contracts. And the order status must be in lowercase, so we need to make sure it's in lowercase here and here. So let's have a look by setting up a simple strategy. 1% of the balance. Breakout will be simple to trigger with a minimum volume of 0. Activate it, and let's see. Okay, so as I said, you can have the message about the difference between the current time and the trade time. It's normal. And we get the balance, the trade size, which seems logical, 1% of it, a short signal, that is this log, so we can capitalize the message, then the order status, and finally we see that it was filled, so we got the filled status. Now that we have placed an order, assuming it has been executed, we need to follow it from the interface, add a new row to the trade component and update the P&L of this trade. To do that and update the interface safely, as usual, we are going to use the updateUI method of the root component. We can first loop through the BitMEX and Binance clients and then loop through their strategies dictionaries. So trades and logs. So we loop through the clients. Then looping through the dictionary, but still with a try except statement, because remember, if the dictionary is modified while we loop through it, it can trigger an error. For bIndex strategy in client strategies items, we loop through the logs. And we display the log. So I call the key log, I think, yes. Then we say it has been displayed. The exception is a runtime error. Then we can loop through the list of trades. So that will be for trade in strat trades. So if the trade Unix timestamp that we use as our row identifier in the trade component here, if it hasn't been placed yet in the body widgets dictionary, it means it hasn't been added yet to the interface. So if trade.time not in the self.trade frame, the body widgets, in the symbol column, we can select any column. Then we are going to call the method to place the trade to the interface. What we had as an argument so far in the addTrade method was a simple dictionary. We can change this to a trade object to take advantage of our data model. And we'll have trade, and for example the time. Here we have trade against time. We can convert it to a string right after. The symbol, the exchange. So we don't have the exchange in the trade data model, but actually the exchange is part of the characteristic of a contract. So we can even add it here in the contract data model. So that will be exchange equals exchange, because we pass this argument here. So that will be in lowercase. Getting back to the trade component, we now have access to the contract, to the exchange of the contract, that we can capitalize. Then the strategy, the side, so long or short, trade.side, and we can capitalize the quantity and we need to import the model. From models, import all, so that it's accessible, yes. So we pass the trade object. Otherwise, if it has already been added to the body widget's dictionary, it means the trade is already displayed in the interface, and we can update the PNL on the status of the trade. So we will need to know how many decimals we display to the interface for the PNL part. So that will be with precision. So for Binance, we can use the price decimals. Otherwise, if we have BitMEX, the precision will be 8 because the PNL will be always in Bitcoin. So the PNL as a string, we use a string formatting as we already did before. So this is 0. The precision, so we have already done that when updating the watchlist component, so feel free to get back to these videos if you're not comfortable with what we are doing here. Then we can use the trades component, the trade frame, the body widget, select the PNL var, because to remind you it's a string var, and set it to the PNL string. And we need the time index to select the right row, so that will be trade.time. Actually, it can even be updated right after we add the trade to the frame, so we don't need this. And we can also update the same way the status of the trade in case it has changed. So status var, and we set it to trade status, and we capitalize it. To calculate the PNL, we can use the bid and ask updates, because the bid is the best possible price at which you can close your long position, and the ask is the best price at which you can close your short position immediately. So this happens in the onMessage method of the connectors. We will start with Binance because it's easier. So we go here in the book ticker updates. We're going to loop through the strategies. So for bindex strat in the strategies and items is a strategy contract, so the symbol is equal to the update, to the symbol update that we've just got. We can update the PNL. So let's separate it with a comment. We loop through the trades. For trade in the strategy trades, if the trade status is open, we're going to update the PNL. And we also need the entry price to be available. So if the entry price is not known, in case the order was not filled yet. So two cases: if the trade side is long, the trade PNL is going to be equal to, so trade.pnl we take the bid, so the exit price, the potential exit price, and the trade minus the trade entry price multiplied by the quantity. Almost the same with the short, we just take the ask instead. and we reverse the calculation. And as usual, since we are looping through the strategies dictionary that can change, we surround it with a try-catch, try-except statement. On the bitmap side, it's slightly more complicated, but we can copy a part of it, because the P&L calculation will depend on whether we have an inverse contract or not. So that will be here, the loop. We can create a price variable, so if the trade side equals long, the price used as an exit price, as a potential exit price, will be the bid price. Otherwise, it will be the ask price. We are also going to take the multiplier to a variable, just to simplify a bit the formula. Okay, so if we have an inverse contract and otherwise, so otherwise the formula will be similar to the one we had on Binance. So we use the price here and here multiplied by the multiplier. For inverse contracts, the formula is a bit different. So if the trade side is long, we have the trade P&L equals to 1 divided by the trade entry price minus 1 divided by the price times the multiplier times the trade quantity. Otherwise, for a short, it's the reverse, so minus 1 divided by trade entry price times the multiplier times the trade quantity. Okay, just checking. Ah yes, this needs to be here, and the dot is here. So let's see if everything works. With a simple strategy on Binance, okay, so we do have all the information, the trade size, the P&L is updating. So this is in USDT. We only need to change the time to a string. To do this, we get back to the trade component. So we need to create a datetime object. First, I need to import the datetime library. I create the datetime object. And using the from timestamp method that takes as an argument a unique timestamp in seconds, then I convert it to a string using a specific format. with the hour and the minute. And we can pass this to the text argument of the first label. I think also in BitMEX, yes, here I passed the prices key, but it's price. So let's have a look if everything works. We will test with BitMEX. And that's it. We have all the information, the date time is in a string format, and we have the Bitcoin PNL that updates live. We are currently able to check whether the conditions are met for a long or short trade. Open a position and monitor the position in the interface. The last step to close the trading cycle is to be able to close a position when the take profit or the stop loss has been reached. Of course, this is not the only way to close a position. You could, for example, choose to close a position at a given time of the day, or only when a signal on the opposite side is triggered. There are many ways. We can have a method to check whether the take profit or the stop loss has been reached. So let's call it check TPSL. And we will have a trade as an argument. So the idea is to check some simple conditions, whether the take profit has been triggered, so by default it will be false, or the stop loss has been triggered. We can use the current close price to compare it to the trade entry price. And if the trade is a long trade, so the side equals to long, let's first check that the stop loss is not known, just in case you decide in your own strategy to make the stop loss not mandatory. If the price goes below or equal to trade entry price times the stop loss divided by 100. So this gives us the stop loss exit price for a long trade. Then we simply set the stop loss boolean to true. Quite similar with the take profit. So if the take profit is not known, we modify the formula a bit, and we set this boolean to true. Then almost the same with the short, we just change the formula a bit. So for the long take profit, we want to check whether the price goes above or equal to the take profit price, and same for the short stop loss, we want to check whether the price goes above the stop loss price. If one of these two boolean is true, so if take profit triggered or stop loss triggered is true, then we know that we need to exit the position, so we will log this. If we had a long, then the other side is going to be sell. Otherwise, we will have a buy order to close the short position. We use the client to place a market order again. The contract, market order, the trade quantity, and the other side we have just chosen. So if the request was successful, if the order status is not known, we know that the order has been placed, so the position will be anyway closed. That will be trade.status will be now closed, and the ongoing position variable is going to be false. We can even add another log saying that the exit price the exit order on this symbol has been placed successfully. And this method is going to be called every time that we have a trade update for the same candle. So this is here. We loop through the trades, we check whether there is one that is open, and that we have the entry price available. And we call the self check take profit stop loss method with the trade object as an argument. So I'm going to start the program with the breakout strategy again and leave it running a bit with the Binance chart next to it so that you can see how positions are entered and exited. If you are on Mac, there are a few things to adjust so that your application looks better. Indeed, there are borders around the logging component, around the entry widgets, and around the option menu currently. Also, depending on your screen resolution, the application, the entry boxes might be a bit too wide for the moment. So regarding the logging component, we can simply add this argument, highlight thickness equals false. We do the same on the watchlist component for the entry widgets. And on the strategy component, we look for the entry widgets and we do the same. So we don't need to do it here because we are only defining the widgets. There are also some on the show pop-up method. And that's it. We do the same for the option menu, plus one argument, BD equals 0 for the border. And to reduce the width of the entry widget, we can do width and use the parameters that we had defined here, but that I hadn't used. So this is base param, and we use the width key. And the last problem is that we cannot change the background color of the button for the moment. So we are going to install a library named TK macOS X that will allow us to do this. So you would simply import this library, import TK macOS X as TK Mac, and everywhere that you see a button initialization, so tk.button, you are going to replace tk by tkmac. Then you will add also the borderless argument and set it to true. So we look for all the buttons. Here we have only definitions. We have some here, so borderless equals true, and we use the tkmac library instead. We have one more here. And yes, that's it. We have one on the watchlist component as well, because there is a button to remove a symbol. So we can find it here, tkmac and borderless to true. And I didn't import the library here, so import tkmac OS X as tkmac. So basically, if you're on Mac, everywhere that you see that we add a tk.button, you replace it by a tkmac OS X button. And after these few changes, the application should look very much like the one we have on Windows. Whether you create this program for other people or for yourself, since it has an interface, the question you should always ask yourself is how to prevent users from making mistakes when using the program. In particular, you should pay attention to the parts where the user has a bit of freedom, like the entry widgets. Indeed, the user can currently type anything. Nothing prevents them from typing ABC in the balance percentage box instead of a floating number. To take this into account, we are going to add an entry validation feature to our entry widgets. We somehow already had one when we created the watchlist component, because the program wasn't accepting a symbol that wasn't part, for example, of the Binance symbols. But we can have something that will simply refuse to type an unwanted character. In the strategy component, if we take a look at the dictionary we use to describe the widgets, we already know exactly what type of data we want in the entry widgets. For example, the take profit and stop loss percentage requires a floating number. The RSI requires an integer. So we are going to write a callback function that returns true if the text in the entry widget is valid and false otherwise. So if the text in the take profit entry widget contains only numbers and potentially a decimal point, the entry, the text, will be accepted. And we will have a callback function for floating numbers and another one for integers. We can write these two functions in a new module because they could be useful not only in the strategy component, but in other components. I'm going to call this module utils. So utils. Okay, so first I'm writing the callback function to check the integers. The text argument is the value that the text will have in the entry widget if the change is accepted. So first case, if the text is empty, so if it's an empty string, we return true, because we want the user to be able to delete what he typed. For example, when he does this. Then we are checking with a loop, with an inline loop. So for, let's say, x is a character in the string, so we loop through each character in the string. So if x is in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then we can go further. Otherwise, we will return directly false. Because an integer can contain nothing but one of these numbers. We can also put an additional security and check that the text can be converted to an integer. So we use a try-catch, a try-except statement. except. So if it doesn't work, it will trigger a value error, and we will return false. But if it works, we can return true. Then I'm going to write the one for the floating numbers. So note that we accept only positive integers here, and that will be the same with floating numbers. So for the floating numbers, it's almost the same. We just try to convert it to a floating number, and we have an additional condition. We want to have potentially a decimal point, so text.count, we count the number of decimal points in the text that we typed, and it must be maximum 1 decimal point. So it's possible to have no decimal point, it's possible to have 1, but you won't have a floating number with 2 decimal points. The next step is to register these 2 callback functions in the component. So we have entry widgets in the strategy component, and for example we can register them. So valid integer equals register, and we need to import the 2 functions from the util module. So that will be from utils import all. And same with the floating number, so valid float. And finally, when we are going to create the entry widgets, so let's look for some. For example, here, when in the show pop-up method. So if we have an entry widget and the data type key is an integer, we're going to add an extra argument to this widget that will be using the config method. We need 2 arguments, validate equals key, that means how the callback function is going to be triggered. In that case, it means that it will react to keyboard entries, but there are other options. For example, you can choose to react to call the function, the util function, when you focus on the widget, or when you click in the widget. And the second argument is validate command, that is a tuple. So the first element of the tuple is the function that we registered for the integer check. So this is valid integer. And the second argument is a code to indicate what will be the argument of the callback function. So %p, for example, means that the argument that is passed here is a new text, the potential new text, in case the change is accepted by the function. But you could have %s, for example, that is passing an argument to the callback function, that is the text before the change. So we do the same for floating numbers. In case we indicated a data type of float, we this time register we use the register function validate valid float. So quite the same with the add strategy row method. We have the entry widget case, and we modify the widget that we just created depending on whether we indicated we want an integer or a floating number as a data type. So base param here. Okay, so we can test. I'm even going to print the text that we receive, for example, in the check float format. Just one more thing here, in the check float format we need the decimal point as part of the text as well, even though we check the number of decimal points in this condition. So let's test. So add a new strategy. If I type A, B, C, it doesn't work. You can see the text it receives, but if I type 0.2, this time it works. I cannot type another decimal point, so it really takes only floating numbers. We can test with integers as well. So for the RSI, if I type 0.2, so 0 works, but not 0.2. ABC as well doesn't work. 1, 2, 3, that works. Good, so that way the user will be less likely to make an error when typing the parameters. Another way to improve the program can be to extend the capabilities of existing widgets. For example, the watchlist component requires to input the name of the symbols we want to follow. But it would be great if, when we start typing the name of a symbol, the program helps us by displaying a small list of symbols that match what we have typed so far. This is what I'm going to call the autocomplete entry widget. When you think about extending the possibilities of an existing class in Python, in this case the TechInter entry widget, you should immediately think about inheritance. The widgets that we are going to create will inherit from the TechInter entry class. So I'm creating a Python module specially for this new widget. I'm calling it autocomplete widget. So importing TechInter, of course, the typing module, then the class. So I'm calling it autocomplete. It inherits from the entry widget, and when we initialize it, so when we initialize it, we will need the list of symbols for the exchange, so that we can see which ones match what we have typed. So that will be a list of strings and the other arguments. Then we initialize the entry widget. Okay, so we can create an instance variables for the list of symbols. So what is the functionality that we are looking for? We want something that displays a list when the user starts to type something in the entry widget. To follow what the user types, we can create a string var object and pass it as a text variable argument of the entry widget. So that will be self.var equals tk.stringvar. And we configure the entry widget, its text variable. That will be the variable we've just created. So it is similar to what we have done with option menus, because we are following the value of the option menu with a string var object as well. To trigger a callback method when the string var value changes, we can use the trace method, so that will be var.trace w like write to indicate that we call the method when the value changes, and the callback method will be changed. So we can create it here, changed, and it automatically receives some arguments that we won't use anyway, but that are all strings. So the mode here will be W. The first interesting case would be that whenever the user types something, we could make what he types to be in uppercase automatically. So that will be, we select the variable, we set it to itself, but we select its value, and we set it to uppercase. Then we are going to prepare to create a list box widget to display the matching symbols. So that will be, we'll call it LB. And the maximum number of items that we will have is 8. So we can define this variable here. And you see I'm not providing a parent window or a frame because we will use the place method instead of the grid or pack method so that the list box shows in front of all the other widgets. So that will be lb place. To know where to place it, we use the x and y arguments, and we place it next to the entry widget. So we take its y coordinates and the same with the x. So let's see how it looks so far. First, I need to replace the entry widgets by the autocomplete widget. So importing from the interface autocomplete widget, the autocomplete class, and I'm replacing these two entries by the new class. I need to pass a list of Binance symbols for the Binance entry and the list of BitMEX1 for this one. So if I type XBTUSD, you see it converts what I typed to an uppercase and it displays a list box. So list box, though, is not at the right place. It would be better to offset a bit to the right and down. So that will be, we can use the entry widget width for this. Self.winfo. We offset it by the entry widget width, and same for the y coordinate, plus self dot the height, let's say plus 10, so that it can be seen a bit better, you will see. Okay, now it's better. To avoid the creation of a new list box every time that we type something, we can have a variable, a boolean, that will be lb open, false by default, and this will be called only if self.lb open is false. Then when the user deletes everything from the widget, we need to destroy the list box and turn the boolean to false. So if the variable is an empty string, we take the list box and we use the destroy method and we turn the variable, the boolean, to false. So that will be only in case, of course, the list box was already open. And yes, here it's lb open, that is true. Okay, so now we have our list box and we need to populate it with the symbol names that start with the one we have input. So I'm creating a list that will be symbols matched equals to, we loop through the list of symbols, and if the symbol we are looping through is, well, starts with, so we use the starts with method, the variable that we have currently. So we will have a list of symbols that start with, for example, XBT in the example I have shown just before. So if the length of the list is more than 0, we are going to insert these symbols to the list box. So for symbol in symbols matched, we use the insert method in the end. Otherwise, if the list is empty, we will simply delete the list box if it's open. And just before inserting the symbols, we need to make sure that it was empty before the insertion. So we use the lb.delete method and we delete every element. So from 0 to tk end. I'm using a try except statement because I noticed that sometimes there can be errors when doing this operation. Okay, let's have a look. If I type xbt, good. We can see that all the symbols and bitmaps that start with xbt are displayed in the list. And the list box disappears when I type nothing. This could be even better if we could navigate through this list with the keyboard arrows and eventually select one item. For this, we are going to bind the keyboard arrows to a callback function. So self.bind the up key, and we'll have a callback function named up down. Same for the down key. So the method will be as follows. It receives an event argument automatically. So if the list box is open, we are going to get the current index of the selection. So for this we do lb curse selection. If it's equals to an empty tuple, it means that no item of the list box is selected. So in that case we will create a variable with the index that will be -1, representing that no item is selected. Otherwise, the index will be cell.curseSelect. And this returns a tuple, so we need, because the list box can have several items selected at once, so we take just the first one because we will always select only one item at once. We also are going to need the size of the list box, so the size, the number of elements in it. Okay, so two cases. If the index is more than 0, and the key that we pressed, so for this we use the event keySym attribute, so if it's up. So why do we want an index more than 0? Because if we have index equals 0, it means that the current element that is selected is the first item of the list. So we cannot go more above this. So in this case, we simply clear the current selection. So we pass the index for this. So that the highlight on this item disappears. Then we change the index because we just pressed the up key, so we are going to move up. The index will be index -1. And we set the new selection to lb.selectionSet to the new index, and it needs to be a string. And we need to use the activate method so that we can indeed see the item selected. Otherwise, if we pressed event.keySym equals down, we need to make sure that the current index is less than lb size -1. This is why we need the list box size, because if we are already at the bottom of the list box in the last, selecting the last element, we cannot go even further. So same thing, we are going to clear the selection, lb select clear. We are incrementing the index, and we set the new index to this increment. So let's put it as a string directly here. So yes, it's actually key sim, yes, with a Y here. So let's see if we can indeed go up and down in the list box. So XBT. And yes, it does work, and you can see I cannot go more below the last element. And same with the first element. And the list box still disappears when I type nothing. So it would be good now if when we press the right key, then the element that is currently selected is displayed in the entry widget. So let's do this with another callback method. So we bind the right arrow and we'll have a select method. So we can have the method here, def select, it takes an event argument, so still if the list box is open, we are going to set the variable, the entry variable, to the list box selection, thanks to the get tk.active method. After we have done this, we want to destroy the list box, so lb.destroy. And we set the cursor at the end of the entry widget. So iCursor tk.end. Okay, so that should do it. Let's have a look. XBT, I'm going to select XBTH21, right key now, and it works. So you see the cursor is at the end, and it selected the one I wanted. So I can redo it, XBT, XBTM21, and it still works. Same with Binance, Bitcoin. So it's going to be easier than simply remembering every symbol name. One problem you will often encounter when using Tkinter is the need for scrollable frames. It can be useful in many components related to trading. And in our case, it will be useful in every component, because if you run the program for a long time, the trades list will accumulate and you don't have unlimited space on your screen. Not all Tkinter widgets are scrollable, and frames unfortunately are not. But don't worry, thanks to what you have learned so far, and to some elements I'm going to explain, we will overcome this issue. We are going to create a custom frame class that inherits from the Tkinter frame class. I'm calling the module scrollable frame, importing Tkinter as usual, and I'm going to create the class that I will call scrollable frame that inherits from a Tkinter frame. So we need a widget that is scrollable and that would let us place a frame inside it. This widget is called a canvas. It allows you to draw things inside it, but also to place the other widgets inside it. So if we place a frame inside this canvas and pack a vertical scroll bar on the right of the canvas, linking the canvas and the scroll bar, it will be able to scroll what's inside the canvas, that is to say, the frame. So creating the canvas. If you don't set highlight thickness to 0, there will be a white border around this canvas. So it will take the keywords arguments that we pass to the scrollable frame. Then I create the vertical scroll bar. And finally the frame that will go inside the canvas. So you see I'm packing the canvas and vertical scroll bar like any other widget, because their parent window is a frame. But I didn't pack the subframe because it is placed inside the canvas, and you need to use another method to make it appear. This method is called createWindow. So a bit of explanations about the arguments. The anchor argument means that the frame will be placed at the top left of the canvas, like northwest. And the tuple 0, 0 are the coordinates of the frame from this top left position. We place it at the top left, otherwise it will be complicated to align this frame with the headers that are not in the canvas. Then we are going to link the canvas with the vertical scroll bar thanks to the Y-scroll command argument. And the last thing is to indicate the scroll region of the canvas whenever the content, the subframe, changes. So we select the subframe, we use the configure event, that means whenever the subframe changes, and we are going to bind a callback method. Selecting the canvas, then configuring it, defining the scroll region to self.canvas bbox all. So bbox all means the coordinates of the canvas content. Now we can replace the basic frames by scrollable frames first, for example in the trade component, and there will be a few things to adjust. First, we need to have a separate frame for the table headers and another one for the table body, that is the scrollable frame, because we want the headers to be sticky at the top when scrolling. We could of course skip this part and think, okay, it's not that important, but as I said many times, this is a real-world project, and with great project comes great responsibility, so you will learn how to code a nice table. So creating a frame for the headers. We need to remove the bold font because otherwise it will increase the width of the headers and we won't be able to have the headers perfectly aligned with the table body. I'm going to create a variable that is the column width. So that we can apply it both to the headers and then the table body. Then I just need to pack the headers frame. We still make sure that it is at the top left. Then the scrollable frame that I need to import. And we'll set a default height for the canvas that will be 250. And when we add a new trade, we will place the new widget not directly to the table frame, what we had so far, and not to the body frame, but to the body subframe. Because we are using a scrollable frame. Also, the body index can now start from 0 because we have a dedicated frame for the body and no need to reserve the first row to the headers. Let's take a look at what we have so far. The scroll bar didn't take the full height of the canvas. By default, it takes as few space as it can. So we can change this behavior by adding to the vertical scroll bar a fill equals tky argument. Same kind of problem with the width. We would like the width of the canvas to be the same as the headers frame. So we can apply tk.x both to the body frame and to the canvas inside it. We will even add an expand equals true to the canvas to make sure that the widgets inside the canvas expand to the canvas width. So let's see. Okay, it's much better. So we can add the same for the watch list. And just before that, I think I forgot, yes, the width for the columns, for the new trades, for the body widgets. So we have a frame for the headers. We remove the bold font. The column width will be 11, so shell.colWidth. I'm also going to add an additional label, an additional header, to take into account the width, the space needed for the scroll bar to the right. So we'll say 2 should be enough, and we can do the same on the traits component. Then we can pack the headers frame. Then the body. And we still set the body index to 0. And when we add the symbol to the watch list, we will use the width that we have selected, so colWidth. And for the remove column, 4 will be enough. We change the parent window, that will be the body frame subframe. And we can have the height of the scrollable frame to be 250, like the traits component. And here we pack the headers in the headers frame. So let's have a look. Okay, so you see we have a scrollable frame and the headers are well aligned with the table content. So I'll just remove on the logging component there was a border, so setting it to 0. The strategy component is a bit more tricky because we have 3 different types of widgets in it. We have option menus, entry widgets and buttons, and this will have an influence on the way we try to align the headers with the widgets in the table body. First, let's remove the bold font from the headers. And add the global font to every type of widget so that we are sure that this won't be a problem when aligning the widgets together. So we need it here, for example. Here and here as well. So again, we need two different frames, one for the headers and one for the table body. What I propose to do is to create the headers by looping through the base params list so that we can use the width of each key so that it will be the same as the width of the header. So for the buttons, the headers will be empty. So we'll just take the headers from here and insert them in the dictionaries. We need a width for the buttons column as well. So width So I know that these values will fit in my screen, but you may want to adjust this to your screen size, and it's the same for the program in general. So we loop through the base params, we don't need the headers list anymore. We take the header key, the width of the column, and the parent window is the headers frame. Then I can create the scrollable frame, cell.body frame, I need to pack also the headers frame, so headers Same thing as for the two other components. We use the width of the base param, so we already have it for the option menu. For the button, and for the entry widget, so depending on if you followed the video for Mac users, you may already have it. I'm also adding the additional column, the additional header here, like for the other components. And last thing, we change this to body frame, subframe. Here I think I need a bit more width. and let's see how it looks. Okay, it doesn't start so bad in terms of alignment, but then you see it's more and more offset. So it's all about borders around the widgets. If you want, for example, a label width to match with the button width, since by default the button has a border width equals to 1, the label must have a border width of 1. For the option menus, we need a border width of 0, but we also need to remove this icon. So we already have the border width of 0, and for the entry widget to match, we will need a border width of 1. For the headers, I'm going to add a border of 1, but I will not show it. So it will affect the width, but it won't be shown because it wouldn't look good to have borders just around the headers. So to hide the borders, we use the relief argument and we set it to tk.flat. There are actually two cases, one for Windows and one for Mac. Regarding the option menu, on Windows you need to remove the font argument, the highlight thickness one, and you need also to remove the highlight thickness one for the entry widget. This way you do get well-aligned columns and headers. On Mac though, you still need the arguments I have specified at the beginning, so these two. By the way, you can set the background color to the BG color only on Mac, because this will remove the white background around the option menu. And again, only on Mac you need BD, the border width, to be equals to -1. And on Mac also you need this to be 0 for the entry widget. So it's a bit tricky, even very tricky. You wouldn't find this by yourself immediately when starting with Tkinter, but by experience, by experimenting on both platforms, on both Windows and Mac, you would end up finding that this is the combinations that gives you the right alignment between the body and the headers. So since I'm on Windows, I will set it back to the original values. And we can have a look. So you can see the headers and the body are fine. We can add some padding between the columns to space a bit the columns. So just 2 should be enough, both on the headers and the body. And you see it's still well aligned, but the columns are better separated. Again, depending on your platform, whether you're on Windows or Mac, you may need to adjust the width of the widgets to adjust it to your screen size and resolution. So let's see if we can indeed scroll. Yes, it works. You may want to bind the mouse wheel to your scroll bar, because currently you can use the mouse wheel only when your mouse is on the scroll bar, but when it's on the frame, it doesn't work. So we are going to bind the mouse wheel to your scroll bar when the mouse is on the strategy frame, because otherwise it won't be very convenient. So we can first use a takeInter event to identify when the mouse enters the frame and leaves it. So that will be cell dot. So we use the subframe. Enter and leave. And we'll call the callback activate mouse wheel. So when the mouse enters in the frame, we are going to bind to the canvas the mouse wheel, so bind all. To a method that we will call on mouse wheel that will let us indeed scroll with the mouse wheel. And here we just remove what we have created here. So when you indeed use your mouse wheel, we will take the canvas and its yView scroll method, and then we will say by how many units the mouse will scroll. So I give you a formula for this. If you decrease 60 to 40, for example, you will increase the sensitivity of the scroll bar to your mouse wheel. So let's have a small test. Okay, you see, it works, so that's very convenient. So quite a tricky lesson. Don't get discouraged if it was a bit hard for you. Quite the contrary, it is encouraging to see that with takeInter you can do almost anything you want. During this course I used mostly PyCharm to close the application, but notice that if I use the red button on the top right of the interface, it also closes the interface. But something is wrong. Can you see it? Right, the program is still running, but why? Well, you have only stopped the main loop by destroying the root component, but there are still two other threads running at the moment, the two WebSocket threads. So you need to create a callback method that will react to the fact that the user closes the interface, to be able to close also the WebSocket connections. So we use the protocol method. And the callback method will be ask before close. When the user clicks on the button to close the application, this callback method will be triggered. You can then display a message for the user to confirm this action to avoid any accident. So we will import a specific widget. So we create a window that will ask yes or no whether the user wants to close the application. And the result of the action of the user will be stored in this variable. So if the user clicks yes, result will be equals to yes. So in that case, we can continue. To close the WebSocket connection, you can use the WebSocket app object WS of each connector and call its close method. But for this, WS must be public. So we remove the underscore, and we can remove this initialization to none and simply hint the type of the variable. So this is a WebSocket app object. You will have to change this everywhere, so we look for WS everywhere in the code. And you can select all the occurrences of this variable and simply then type WS. And you see it replaced it everywhere. Same for bitmex. However, remember that you have created a mechanism to reconnect automatically when the WebSocket connection drops. So we will need to disable this mechanism when clicking on the exit button. For example, we can have a variable that will be a boolean, and we will reconnect only when it is true. Otherwise, we will break the loop. So by default it will be true, and same for binding switches. So before calling the close methods, we will set the reconnect boolean to false. And finally, you need to call the destroy method on the root component, because this callback method overrides the default behavior, so it won't close by itself. This way, if you close the application, the Python program will terminate entirely. All along the course, you were starting the program from PyCharm. At some point, when the program is very advanced and very well tested, you will probably want to start it even without opening PyCharm. To do this, you can create an executable batch file on Windows and a command file if you are on Mac. On Windows first, create a file, so not a Python file, but just a file. You can call it start.bat. And when you start the program from PyCharm, it shows the terminal command it is using to start your Python file. So you can copy it, but you don't need this part, because your start.bat file is located in the project folder, so it knows where your program is. And you see, it works. On Mac, you are going to create a new file, but with a different file extension. So that won't be a batch file, but a command file. This line is to tell to the terminal to navigate to the directory where the start.command file is. Then you use the same command as PyCharm is using to start the Python file. However, on Mac you need to add the permission for the current user to run this file as an executable. This can be achieved through the terminal, so open a terminal from PyCharm, and then type chmod u+x and the name of the file. Then you press enter, and now your start.command file is executable. U means the current user, plus means adding a permission, and X means the permission to execute. Currently, if you add symbols to the watchlist, if you add strategies and then restart the program, your watchlist and strategies will have disappeared, because your workspace is not saved. It's going to be a bit annoying to set up everything again every time. So what you can do is to create a simple database to save the information and automatically load the data when opening the program. There are many types of databases in the programming world, but to get started, SQLite is really nice because it is simple to use and you can easily visualize the data because it is a relational database. That is to say, the data is organized in tables. You can create a module dedicated to the database operations. Let's call it database. And you import SQLite 3 and typing. SQLite 3 is already included with the Python installation. Then you are going to create a class with two methods. One to save data to the database and one to read the data from the database. We first create a connection to the database. With SQLite, it will create a database file in your project folder if it hasn't been created yet. Here you tell to the SQLite connection that when you get data from the database, you want it to return a list of SQLite raw objects, which you can access like Python dictionaries. Otherwise, the default is a list of tuples, which is less convenient. And here we create a cursor object that will be used to actually make the queries to the database. Now that you have opened the connection and created a cursor, you will have to create the tables for the data you want to store. One table for the watchlist and one for the list of strategies. The syntax is the following. You have to specify the table name, then the columns, and the type of data in these columns. For example, text, boolean, floating number. So you use the cursor to execute the SQL statement. And you create a table as well for the list of strategies. You see I'm creating only one column for the extra parameters because these parameters will depend on the strategy. And there could be many in your own application. So it wouldn't be very convenient to create one column for each of these parameters. I'm creating columns only for the data I'm sure will be available. You may also have noticed that I made the column names to match the name of the parameters in the strategy module. Then you simply need to commit your changes. Otherwise, if you close the database connection, the changes won't be saved. Next step, creating a method that inserts data to the database. So we'll need to know the table name and a list of data, so a list of tuples. Each tuple is a row to insert to the database table, and each element in the tuple is a value for a column in the row. First, you have to delete the previous content of the table using this syntax. So we insert the table name with the string formatting. Then the SQL syntax to insert data is the following. You first have a tuple with the column names and another tuple with question marks based on the number of columns in the table. The question marks let you insert data dynamically. To save some space in the code, it would be better to create this statement dynamically, depending on the columns, since the method will be used to both save the list of strategies and the list of symbols of the watch list. So you need to get the list of columns for the table we are interested in. To do this, we can make a simple query. So selecting all the rows for the table we want. And then you would loop through the description attribute of the cursor that is returned by this statement. So for description in table data, the description attribute. And you take the first element of the description element, that is a tuple. So this creates a list of columns. Because description is a list of tuples, and the column name is the first element of each tuple. This way you can write the SQL statement in only one line, using the string formatting and the join method. So SQL statement, the string formatting, then the first tuple with the name of the columns, we use the join method. Then the second tuple, so still using a string formatting mixed with the join method. To explain more in details, the first join method converts the list of columns to a string where each element of the column is now separated by a comma. The second join method does the same, but I created dynamically a list of question marks. The number of elements in this list matches the number of columns in the table. That's why we have the length method. Finally, you can use the execute many method that lets you insert several rows at the same time. It takes the SQL statement as an argument and a list of tuples, so what we called data. While the simple execute method would take the SQL statement and only one tuple as argument, so it would insert only one row. And we commit the change. The method to get data from the table is quite simple. We call it get, and it takes as an argument the table name. You just execute a SQL statement to get all the rows of the table. And then you call the fetchAll method on the cursor object. This will return a list of, so typing.list, SQLite3 row objects. And each row object can be accessed like a Python dictionary. So this is it for the workspace data class. In the next lecture, you will see how to actually call the save and get method from the interface. Before loading the workspace, you need to save some data to the database. So let's create a button to trigger a method that will do this. The question is where to put this button, since it doesn't really belong to any of the components. If you want to avoid overloading your interface with too many buttons, you can create a TechInter menu in the root component. So you create the menu widget. Then you configure the root component so that it will use this widget as a menu. Then you create another menu widget. And that will be the first tab of your main menu. Tier-off equals false means that your menu tab cannot be detached from the main menu. You then attach this menu tab to the main menu thanks to the add cascade method. And you can add a command to the workspace menu with the callback method that is triggered when you click on this command. So the callback method will be called save workspace. I'm going to create the save workspace method at the end of the root component. Just showing you how it looks so far. So we have the menu here with one tab and one comment. To save the watchlist symbols, it's quite easy. You need to first create a workspace data object in the watchlist component. Then, getting back to the save workspace method, you will create a list of tuples to pass to the workspace data save method. So the list, you loop through the watchlist body widgets, like you did with the updateUI method. So for key value in cell.watchlist frame.thebody widgets, we loop, for example, through the symbol column. We get the symbol of this particular row, so value.cget text, and we get the exchange. Then you add the symbol and the exchange combination to the list as a tuple. And the tuple, the elements of the tuple must be in the same order as the columns of your table. Finally, you can call the save method of the watchlist database object. So the table is watchlist and the data is the list of symbols in the watchlist. By the way, if you want to explore the data of SQLite database, just to see a bit better how it looks, there is a program available for this. It is called DB Browser for SQLite. You can download it, install it, and open the database.db file with it. And you will be able to visualize the saved data. Let's already test the save workspace method. So I will add 2. Okay, so let's see if that worked. I open the DB browser for SQLite. I select the watchlist table, and you see we have the 2 symbols that were saved. It will be a bit more complex for the strategies. You still have to create a list to pass as an argument to the save method, and you loop through the body widgets of the strategy component. So body index, b index, strat, this is a dictionary, then you are going to get the value of each column, the ones that are common for the 2 strategies. So for example, strategy type, strat, and we need the strategy type var. And as I said in the previous lecture, since the extra parameters will be different depending on the strategy, you can store them all in one column with a JSON string. So you prepare a JSON dictionary, and then you loop through the parameters defined in the extra params dictionary of the strategy component. So this needs to be a public variable. We are going to change it. I select all the occurrences of this variable. Extra params without the underscore. And the PyCharm warning disappears. So the code name, then you are going to fill the JSON dictionary thanks to the additional parameters dictionary. This is where you stored these parameters. So again, it needs to be public. Finally, you are just going to append a tuple to the list for each strategy. So appending a tuple for this list. And the extra parameter JSON dictionary can be converted to a JSON string with the JSON.dumps method. Remember, you used this in the WebSocket part. So I need to import the JSON library here. Then we create a workspace data object in the strategy component. And we can call the save method. So strategy frame, db, save, and we pass the table name as an argument, that was strategies, and the list of tuples. You can even add a log to the interface to acknowledge that the workspace was saved. And actually, yes, we need to loop through the rows, not through the columns. So to do so, let's create a short variable for the body widgets, strat widgets. That will be shorter. And we will loop through the body widgets, for example, the contract column, so that we can access each row of the column. So that will be b-index. We loop through the column index, and then we access the body widget dictionary, the column, the key, and the index, b-index. So maybe a better way to build this body widget variable would have been to create first the rows and then the columns. And we remove this because we looped only through the keys, not the keys and values. Let's have a look. Okay, so it seems to have worked. We can check the column. We have all the JSON data. We have the balance percentage, contract, time frame, everything. The next step is to load the data when each of these two components is initialized. Not a big issue with the watchlist component. We can do this at the end of the initialization function. So we get the table data, watch list. We loop through the list of symbols. So for S in saved symbols, and we can use the add symbol method. You can see it works. On the strategy side, the code is going to be a bit bigger, so better create a method for it. Let's call it load workspace, and we'll have it at the very end. We get the data, Then we loop through the data. We add a new strategy row, and the difficulty is that we now need to fill the widgets, the entry boxes for example, in these rows. To do this we need to select the right body index, so b-index equals cell dot the global body index variable -1. -1 because remember, every time that we add a new row, at the end of the function, of the method, we increment this variable. Then you loop through the base parameters and extra parameters. You get the code name as usual. And depending on the type of widget, you will set the widget content to be the one you saved in the database table. Only if the value of the cell in the database table is not known, of course. Like here. So if base param widget type is option menu, and the row code name, because we've set the columns to have the same name as our code names, for example balance percentage is the same in the table, we select the body widgets, the row we are interested in, so the last one that was added, the code name, plus underscore var because it is an option menu. And we set it to row and select the column with the code name. Otherwise, if it's an entry widget, it's almost the same. So entry, no underscore var here, and so elif. And we need to change the method, it's insert tk.end, and then the text to insert. For the extra parameters, you first need to convert the JSON string to a JSON object. Then you loop through this JSON object, like you loop through a Python dictionary. You select the additional parameters dictionary, the b-index, the parameter, and we set it to the value of the table. So here actually it's the body index after the column. And you would call this function, this load workspace method, at the end of the initialization function. And you will see it loads the workspace. So much easier than typing all the times all the strategies and adding again all the symbols to the watch list. This short lecture is about another good practice in Python, the requirements file. In this file, you will indicate to potential other people working on your code which external libraries you have used during the development and the version of these libraries. It will also let you see a summary of the libraries versions I've been using in this course, even though I don't expect the version of a specific library to change something about the content of the course, because these are very stable libraries. We can create this requirements file automatically thanks to another library called piprex. So I will install it with pip install piprex. Then, still through the Python terminal, you would simply type piprex dot, and the dot is to mean that we look for libraries from the current project folder. And it will record only the external libraries, not the ones that come with the Python installation. So these are the 5 libraries I've been using in the course. Like I mentioned early in this course, once you have seen how to integrate one API to your program, adding more exchanges isn't that hard. I also mentioned that Binance has a very stable API across its different platforms. The API for a spot account on Binance is almost the same as the one for futures. Let's see how to create a connector for Binance Spot. But first, do we need another connector? Actually, no. The API is so similar to what we have with the futures that it's much more efficient to modify a bit the existing connector rather than building a whole new one. When initializing the Binance Futures client, you can add another Boolean argument to indicate whether to connect to the futures or spot account. By the way, it would make sense then to change the class name to simply Binance client. So if the futures Boolean is true, you will use the base URL of the futures API. So creating an instance variable for it. Otherwise, you will use the ones of the spot account that you can find in the documentation. Binance Spot has a testnet platform, but it can be accessed only through the API. To generate the API keys for it, you can follow the guideline on this page. So modifying a bit the URLs. Then, all you need to do is to change the endpoint in each method depending on the self.futures boolean. For example, with the getContracts one, we will have if self.futures else, and we take the endpoint for the spot account, for the spot API. So API v3. For the getBalance method, that will be if self.futures API v3, and you would do this for every method. Always make sure with the documentation that the parameters are the same and that the JSON response is structured in the same way as for Binance Futures. Otherwise, you would need to adapt a bit the parsing of the data. Talking about the parsing, the API JSON responses are still parsed and transformed into data models in the models module. So in the models module, you should also take into account whether the data comes from Binance Spot, Binance Futures, or BitMEX. Because currently there is only the Binance or BitMEX case. So what you can do is to create a variable called platform that will be, if it's futures, platform will be Binance Futures. Otherwise, that will be Binance Spot. And this is what you are going to pass to the models. For example, here. This is to take into account the differences between the data of a futures account and a spot account. For example, on a spot account, with the balance method, you wouldn't have the initial margin key. Instead, you have only a free and locked balance. for an order, you wouldn't have the average price key. So take this as a practice exercise, don't forget about the WebSocket, and check everywhere, including in the strategy module, how the use of a Binance spot account could affect your code. I give you a hint. For example, you cannot short with a spot account. So the Binance Spot API implementation will be available in the source code at the end of the course, but first try to implement it by yourself. After these 10 hours of lectures, the first thing I want to tell you is congratulations. Together we covered many topics. They were often quite technical, and learning at the same time to code, to design an interface, to connect with APIs, and to do all this for trading is definitely something not easy. So even if you found it difficult, you must be proud of yourself. I would say this was only the first step of a big journey for you, because now you will want to take your own ideas to code, and I hope you will keep in mind all the challenges that we discussed during the course and their solutions. The goal was really to provide you with a general guidance of practices to follow when creating a trading program, and at the same time to be realistic by showing you a real-world project. My advice is now to try your own ideas, and it is very likely that your own ideas will require to add many more things to the program. Maybe more interface components, maybe a totally different logic for the trading part, and probably more API methods. The crypto exchanges get more and more solid, and the quality of their services is definitely increasing, including their APIs. So that's a good time to start to learn about trading and APIs together. However, the big trap you could fall into is to try to do this too quickly and make your program less stable. Try to always keep the program clean by adding step-by-step, small but well-organized pieces of code. And don't feel constrained by what we have built together. Try to make your own program from scratch with simple but useful ideas. I keep believing that the best way to learn is learning by doing, especially given the fact that you can find so much help on the internet if you are stuck on some part of your code. I keep learning new things every day, so don't get intimidated by everything left you have to learn, just sit and start coding. There are really so many things you can add to a trading application, and it is so pleasant and satisfying to know that when you have a new idea, you can simply open your code editor and start implementing this idea without having to rely on someone else. Over the course, I did my best not to leave unexplained lines of code, and I hope the course organization I chose was easy for you to follow, and that overall you found this course useful and pleasant to attend. I would be glad to hear your feedbacks about it, and if you think there is anything else you would like me to teach you in another course, maybe backtesting or the implementation of a specific kind of trading strategy, just let me know. So, all the best to you guys.